Hello everyone, I hope my voice is clear to everybody. Any problem, any issue? Hi Avenger, wow, catchy names man. So yeah, I'm back with another topic, but this time I can say an interesting and quite relatable topic. Uh, so generally in maths itself, whenever we think about math, what comes in your mind? Variables or equations, formulas, integration, differentiations, limits, and so much of complexity comes in your mind, correct? Right, that's what happens. Good evening, good evening everybody, how are you all good? Your voice is not clear, my voice is not clear. Okay, IITian, let me check. Is it clear now? Better? Check once. Yeah, okay, great. I think if even now it's not clear, then there is a speaker issue. Please check on that. You distracted me. What I was saying, yeah, I was saying a very nice thing here. Please let me complete. So I was saying that whenever we think about maths, what type of things comes to our mind? That variables, equations, differentiation, integration, uh, too much of complexity. But this topic, I personally feel that this doesn't give you that much of the feel of the regular math which we keep on doing, correct? Permutations and combinations. Permutation combination basically is just about counting, count, imagination, real life you can actually feel that this applies in your real life, although every topic does, if you come to me and tell me, sir, where this is used, that is used, so almost I can tell you each and every topic, which each and every concept itself which you study in math is going to be applied somewhere or the other, correct? That is for sure is going to happen. Now this particular topic, even more you will feel relatable, even more you will feel that this is going to be applied. This is, yeah, I can feel it, this is happening in front of me, this is something which I've done before, but I didn't think through it with mathematics. Okay, so permutations and combinations, a good topic, interesting topic. I won't say easy, yeah, easy to understand if you are well and good at imagination. So that's fine. Yeah, IIT, that's fine. There is no link. I'll try not to keep any link between the two topics. Binomial theorem was different. There also I told you that you don't need to know PNC. Whatever was required, I told you. So let's start from scratch for this topic. If you're studying this for the first time, it's going to be very good for you. You'll be very interested, right? Yeah, IIT, I said no need. It's fine. You can start. This particular topic, according to mains and advanced, yes, definitely very important. Direct questions from PNC is also asked, and indirectly this particular thing or concept is also applied in almost many topics, a lot of topics. Again, 3 to 4% of the weightage, I would say, is there in mains, even in advance. Yeah, advance it varies from year to year, but mains I can definitely tell you that a lot of questions, direct questions itself are asked. Direct question, by direct question what do I mean? By direct question I mean that there is a category, there is going to be a category, there are going to be categories of different types, or different questions, specific category, you can say standard categories for so many questions. So directly category based questions are asked. If you understand one scenario, you will be able to do the questions based on the similar scenario at other places as well. So that's going to be a good thing. Yeah, this, so I hope everybody celebrated Rakhi. I celebrated it too. Now I think we have to okay, a lot of things. We'll start with the very basic thing which we need to know. Sometimes we don't think about fundamental principles of counting, and we start learning PNC, or we start learning PNC with the formulas, with the direct go through approaches. So that I believe is not correct, because first we need to understand what this chapter is all about. So try to increase the volume. I'm already shouting, Etienne. All right, I'll keep my volume up. I think volume is quite good. Okay. All right. So other topics we'll do after understanding what is the fundamental principle of multiplication, or I would say fundamental principle of counting. What is the fundamental principle of counting? How should you count? How well are you at counting? Sir, we know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is counting. How do you think? We are in grade 10s, 9s, 11s. We have passed our primary ages. So definitely we know counting. I'm not talking about number counting. I'm talking about counting the scenarios, counting the ways, counting the methods of doing a particular thing. That's very important. Getting my point? Okay. So let's start with fundamental principles of counting. Okay. Count the dots. How do you count? If you're still counting like this, no, that's not correct. How do you count? You know the wiser way to count. 6 dots are like this and column wise, and we have 5 dots row wise. Right, so we know what to do. We know that 6 into 5 will give us 30. So what have we done? First, we are actually here, one very important thing to understand is, what are we doing? Why are we doing 6 into 5? We know doing this gives us the answer, and generally also if we are supposed to count number of boys or number of people in rows and columns arranged, we'll just multiply the number of rows with number of columns. That's what we do. But why? Why are we doing this? Let's think about this particular question. Pens and, this is pens and pens, markers. Suppose we have got something like this. Suppose we have 5 pens. So we have P1, P2, P3, P4 and P5. We have 5 different pens. Okay. We have 5 different pens and we have 3 different markers. So we have M1, let's say M2, and let's say we have M3, 3 different markers. Now, I'm asking you 2 questions. First question is, in how many ways can you choose a pen or a marker out of 5 pen and 3 markers? Pen or a marker. Either you need to choose a pen or you need to choose a marker. Right? That's the choice. You have a choice. Either you'll choose a pen out of 5 or you'll choose a marker out of 5. That's what you're going to do. So in how many ways are you able to choose a pen? You have 5 pens. So obviously you can choose it in 5 ways. Either you'll choose pen 1, you'll choose pen 2, pen 3, pen 4 or pen 5. Correct. So you'll choose pen in 5 ways. Now your choice is, you have to choose one thing at a time. Either you are choosing a pen or you will be choosing a marker. Correct. What I'm saying is correct. Getting my point? So next thing is marker. We have 3 markers. Now one thing we are doing, either or. We are doing or situation. We are not doing 2 things at a time. We are doing just one thing at a time. So I'll say that 5 ways to choose a pen plus 3 ways to choose a marker. So total I have 8 ways to choose a pen or a marker. Either, suppose these pens and markers are kept in front of you, you have to choose one thing. Close your eyes and choose. So whatever you'll pick, either it will be a pen or it will be a marker. So either you'll get a pen, 5 ways to get a pen, right? Or you'll choose a marker, 3 ways to get a marker. That's it. So 8 ways. Now if I ask you, in how many ways can you choose a pen and a marker? Now you have to do 2 things. Now it's not that you are going to choose one pen or one marker. You're not doing one thing at a time. You're doing 2 simultaneous things, right? You're doing continuous process, one process after another process. Think of it like that. Let's do it again. P1, P2, P3, P4, P5, M1, M2, M3. Okay. Now you have to choose either, you have to choose a pen, also a marker. One pen and one marker. So what can be the possible scenario? Suppose you picked up pen 1. With pen 1 you can pick marker 1, right? With pen 1 you can pick marker 2. With pen 1 you can pick marker 3. With pen 2 you can pick marker 1. you can pick marker 2 and you can pick marker 3. So you can see, right? Now these are different choices. All of these are different choices. Similar choices we are not counting. All of these are different choices. And what are we doing? We are doing one task after that continuously. In the same scenario, in the same work task, we are doing two things at a time. One pen and one marker. Correct. So similar thing will happen with P3. Similar will happen with P4. Similar will happen with P5. So what are we going to have? 5 into 3. Total scenarios will become 3 here and 5 here. So 5 multiplied with 3. Now difference is when we have to do one thing at a time, that means or scenario. Either we are doing this or this. We can finish a work by this method or that method. Or we can finish, when we have to finish the method, when we have to finish the process, we have to do 2 or 3 methods simultaneously, then the process will be finished. This is two different things. So, notes are not coming. ITN, I uploaded the notes. I'll check with the team once again. Okay, I'll check with the team once again. Okay, maybe something. I don't. My personal Telegram thing is not there. I'll check with the team anyway. Okay, so get my point. Either we are doing one thing at a time or we are doing simultaneously 2-3 things. So here also 5 ways to choose a pen. This is ways to choose pen. And this is ways to choose marker or to pick marker. And we multiplied. Why? Because we are doing 2 things at a time, 2 things simultaneously. And here we added because we are doing one thing at a time, either this or that. Okay. Now, suppose same thing, suppose you are traveling. Suppose you are traveling by your vehicle, car, bike, whatever it is, and you are switching between 3 cities. This looks like Delhi to me, right? I hope I'm correct, right? This is Jaipur, and let's say this is Mumbai. Correct? Understand this very carefully. Suppose you have some 3 ways to go from Delhi to Jaipur, and then some 4 ways, or let's decrease it, let's say 2 ways to go from Jaipur to Mumbai. Now if I ask you the question, in how many ways can you go either from Delhi to Jaipur or from Jaipur to Mumbai? You'll have to say either you'll be going from Delhi to Jaipur or you'll be going from Jaipur to Mumbai. So you will have either these 3 ways, either you have this 3 ways or you have these 2 ways. Right. So total number of ways in which either you can go from Delhi to Jaipur or Jaipur to Mumbai, you have a choice. So 3 plus 2, 5 ways. But if I ask you in how many ways you can go from Delhi to Mumbai via Jaipur, crossing Jaipur. So let's say this is your T1, then this is your T2 and this is your T3, for example. Let's say this is T4 and this is T5. Just giving you a scenario, suppose you chose T1. So with T1 you can choose either T4 or T5. With T2 either you can choose T4 or T5. With T3 also you can choose T4 or T5. What am I asking? I am asking you in how many ways you can go from Delhi to Mumbai crossing Jaipur. So you will have to say 3 ways to go from Delhi to Jaipur and 2 ways to go from Jaipur to Mumbai. And because this time you are doing simultaneous task, one task after the another, you will have to multiply 3 into 2, that will give you 6. This is why when we multiply, when we are doing simultaneous things, one thing after the another, right? So you have to multiply. If you have a choice either this way or that way or some other way, then add. Okay. Get my point over here? I hope everybody got when to add, when to multiply. So in counting, this itself is very important, when to add and when to multiply. Why do we multiply? Because we are creating scenarios. We are coupling things. We are making, you can say, sets. So that is why we are multiplying. Okay. Rows and column only, same that what we saw in the starting, no? Same thing actually. If you go into detail, you are doing the same thing. T1, T4, T1, T5, T2, T4, T2, T5, T3, T4, T3, T5, 2 rows, 3 columns, 6 ways, right? Now same thing, let's see one more scenario of the same thing. Suppose you are going into a cinema hall watching a movie, and this time you are not interested in watching the movie. Let's say you are doing something else. What are you doing? This time what are you doing? That you have to enter and exit the cinema hall. Enter and exit the cinema hall. That's it. You are not watching the movie. You just have to enter and exit the cinema hall, and you have to count in how many ways can you do that. So in how many ways will you be able to enter the cinema hall? Either you will enter from gate 1, you will enter from gate 2, gate 3, gate 4, gate 5, or let's just count. Imagine. See, in this chapter, better you imagine, more comfortable and more accurate you will be. You won't actually need to remember the methods if you are able to imagine very well and count very well. I'm not saying every time, sometimes standard methods you have to follow, but this chapter itself will get interested if you are imagining yourself in that situation, in that real life situation. It will get much better and more interesting. Okay, what I was saying, suppose you got in from gate 1 and got out from gate 1, one way. You got in from gate 1, got out from gate 2, two way. Got in from gate 1, got out from gate 3, got in from gate 1, got out from gate 4, got in from gate 1, got out from gate 5. So for gate 1 itself, 5 ways are there. Correct. So same thing you will be doing with gate 2. You will get in from gate 2, exit from gate 2, or gate 2 entry, gate 1 exit, gate 2 entry, gate 3 exit, gate 2 entry, gate 4 exit, gate 2 entry, gate 5 exit. So totally, are you getting, to enter? You have to enter in this cinema hall, you have 5 ways, and to exit in this cinema hall, you have 5 ways. And what did I say in the starting? That you have to enter and exit simultaneously, and you have to count in how many ways are you able to do that. Enter and exit, both the things. So watching the movie is not an option. You just have to enter and exit. No watching the movie or nothing else. So 5 ways you can enter, 5 ways you can exit. You are doing both the things simultaneously, one after the another. So total ways will be 25. Now suppose if I ask you that you have to enter and exit the cinema hall, but the gate which you use to enter the cinema hall, you cannot use it to exit. For example, if you have entered from gate 1, you cannot exit from gate 1. In this case, can you tell me what will be the answer? Very good, 20. Because this time you can use any 5 gates to enter. That means 5 ways to enter. But you cannot use the same gate to exit. So 4 ways to exit. So that means total ways will be 20. In 20 ways, you can enter and exit the cinema hall without using the same gate which you use to enter for exit. Get my point? Right? Can we move ahead? That's what we need to. Now let's see another scenario. We are just seeing scenarios, different scenarios which we see in our day-to-day life, and we are just looking at them with the view of fundamentals, principles of counting, or with a view of counting. We are just trying to count now. Okay, same scenarios we must have done we have gone through so many times, but now we are just counting the number of ways we can get the result. Okay, you know this also, that if you toss a coin, this is a very familiar scenario. If you toss a coin, what can happen? Either tail or head. Standing coin is not an option. Okay, don't think that, sir, what if the coin stands on the ground? In that case, we have one more option. I'm talking about a valid situation, okay, where coin actually gives a result. Tossing a coin actually gives a result. This has happened. This does happen actually. Coin sometimes stands on the ground or gets stuck somewhere on the ground, but here we don't have that scenario. So a coin to be tossed will give you 2 outcomes, right? Single coin. Okay, there is a problem. This coin is of dollars, but these are Indian rupee, right? This is INR, this is USD, but don't mind that. Okay, so if you toss one coin, you will get tail or head. 2 scenarios, either tail or head. Listen to this very carefully, because this same thing is used in many other concept formulas, or other scenarios also, more detailed questions also. This same thing, if you are able to think, if you are able to understand, you will be able to understand those as well. Okay, okay. So one coin to be tossed will give you either tail or heads. Okay, what if I toss 2 coins? what happens? Tail, tail, both coins will get tail. One coin tail, one coin heads. One tail, one heads. Or you'll get one heads, first one. Now this is different. This is different. This is different, right? Coins are two different coins. So first one head, second one tail, right? And two heads. Tail heads, heads tails, heads heads. 4 different scenarios you'll have. 4 different outcomes you'll have on tossing 2 coins. Okay. Very good, Vijay. Now 3 coins. Don't write, no need to write. But yeah, I can show you that either all 3 of them can be tails, right? All 3 of them can be heads. Yeah, all 3 of them can be heads. Or 2 tails, 1 head. Correct? 1 tail. This one, tail, head and tail. This one is also a scenario head, tail and tail. This is also a scenario head, head and tail. Head, tail and head. Again, this is different, this is different. Okay. Tail, head and head, 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 head. So totally 8 scenarios, 8 outcomes, not scenarios, 8 outcomes you are getting. So what do we notice? That tossing 1 coin gave us 2 scenarios, right? One action had 2 outcomes. Same action if we repeat it twice, we got 4 outcomes. That means 2 to the power 2, right? What am I trying to say? 1 coin had 2 options, 2 outcomes, right? So head or tail. If I did the same action twice, if I repeated this action, that means I tossed 2 coins. My number of outcomes became 2 to the power 2. If I repeated the same action 3 times, where one action had 2 outcomes, outcome 1 and outcome 2, let's say. My one action had 2 outcomes and I repeated this action 3 times. So 2, that means number of outcomes to the power 3. The number of times I am repeating that action. So totally I got 8 outcomes. That's what I am having. We know this, we know this. If we have done probability in class 10th also, no, same type of questions. But I am saying counting more, we need to think about counting more accurately, in more depth. That's what I am trying to. Outcomes when we toss n coins, how many? 2 to the power n. Suppose we toss 10 coins. So total number of outcomes will become 2 to the power 10. If we toss 20 coins, total number of outcomes we will get is 2 to the power 20. Right? 2 to the power n is going to be my number of outcomes. And from here we also learn one more thing. Right? This statement also, when an action having m outcomes is repeated n times. One action had 2 outcomes. Here m means 2. One action had 2 outcomes and we repeated it n times, then total number of outcomes will be m to the power n. Total number of outcomes that become will be m to the power of n. For example, many ways we can apply this scenario. Very basic thing, very basic question which is asked is, suppose you are attempting 10 true or false questions. This is something which will be common. The common question asked on this particular concept. If we have 10 true or false questions, then in how many ways can we attempt these 10 questions? We don't have the choice of leaving, we have to attempt all of them. In how many ways can we attempt these questions? Every question, suppose question 1 had 2 choices, true or false, we have to attempt. It's not that, suppose we don't have, if we can leave one of the questions, then we'll say that leaving is also an option, but we have to attempt all of them. Then every question will have 2 choices and all 10 questions like this, we'll have 10 questions, right? One action had 2 outcomes, either true or false. We are doing it 10 times, so total number of outcomes will become 2 to the power 10 outcomes. Getting my point? Simple, just like coin tossing. We are repeating that same action, right? Yes or no, true or false, multiple choice questions. Suppose we have something like this. In how many ways can you attempt 10 MCQs, each having 4 options and only 1 option can be correct in each of them? Simple. One action had 4 one action has 4 results, 4 options or 4 outcomes, and we are repeating that 10 times. So total number of outcomes will become 4 to the power 10, correct or not? 2 to the power 4. No, MCQs, each having 4 options, 4 options, 4 options. So question 1 has 4 outcomes. Suppose question 1 will be four options. Option 1, option 2, option 3, option 4, right? Like this. It will have 4 outcomes. 4 to the power 10, correct. Right? So one action had 4 results and we are repeating that. How many times? 10 times, because 10 MCQs, correct. In how many ways can you attempt all of them correctly? One way only. All of them correctly means you have seen the answer key, right? If you have given any MCQ question paper, then you must have seen the answer key. Answer key is fixed. Answer key is always fixed. Suppose first option correct answer is A, second is A, third is B, fourth is C, then D, then A. Suppose something like this, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Suppose this is the answer key. Answer key is only one, no? Are there multiple answer keys? Single correct options are there. So there will be only one way in which you can attempt all of them correctly if you have given this particular answer key. So only one way to give all the answers correctly. Getting my point? Imagine yourself in this situation. Obviously, there will be only one answer key, one correct answer key. There are not multiple answer keys, single correct options, single correct answers. So one answer key only. So what you can do? Either any one, if you have to attempt all of them correctly, none of them. Suppose you gave this one as B, that means your all are not correct. So there can be only one way in which you can attempt all of them correctly, only one way. All of them wrong also, all of them wrong can be multiple ways. We'll talk about them later, but all of them can be in multiple ways, right? Definitely multiple ways. Here can be 3 options, all of them wrong. If option A is correct here, then if you give B, C, D, anything, right? Suppose option A is correct here, or you gave B or C or D. So here don't say that only one option. Yeah, if this was true or false, suppose if these were true or false questions, then attempting all of them correctly and attempting all of them wrongly, both will have one way only. But these are multiple choice questions. 4 choices are there, right? So there can be multiple ways. Suppose A is correct answer and you have given B or C or D, all 3 are wrong, no? So there can be multiple ways, more ways. If it was true or false, then yes, only one way. Now, in how many ways can you attempt such that at least one is correct? Obviously, either all of them wrong. These two, let's think about true or false, not multiple choice. Let's talk about true or false here, not multiple choice. In how many ways can you correct? Can you attempt such that at least one is correct? Forget about MCQ. Here, let's say these are true or false. At least one is correct. That means total ways of attempting true or false. Every question will have 2 choices, true or false. Total ways to attempt will be 2 to the power 10. At least one correct. This is, now here you have to think with a complementary approach, or I can say that what not be done. You can attempt all of them in 2 to the power 10 ways. And in how many ways can you attempt all of them wrong? All of them wrong, only one way. So if we subtract this one way, at least one will be correct in the remaining results. Can I say that? In the remaining result, at least one of them will be correct. So just imagine these type of situations starting from now itself, so that you'll have a better understanding. Just a minute. Get my point? Okay. Now, next thing is arrangement. We do this also in our day-to-day life. We do arrange things, right? Now I'm asking you to count or to observe how do you arrange things. For example, let's say you have 4 books, physics, chemistry, maths and biology. Okay, you have 4 different books and you have to arrange these 4 books in 4 different shelves. 4 different shelves, right now. Okay, so last question come out of it, don't worry. These were just simple scenarios which I wanted to show you where you can count, right? Same application. Arrangement, this time come in this scenario. Imagine yourself to be arranging these books. You have 4 books. You have 4 books in your hand. Physics, chemistry, maths and biology, and you have 4 shelves. Here you have to arrange, not everywhere, only in these 4 shelves, let's say. Suppose you are supposed to arrange only in these 4 shelves. Okay. Now you have You have 4 books, you're starting from the first shelf. For the first shelf, how many choices do you have? You can keep either physics, either chemistry, either mathematics or biology. You can keep any of the book. So for first shelf, you have 4 choices. Okay, now out of the 4, I don't know which one, but one of the book is placed here. Out of the 4, I have already placed one of the book over here. Correct. Now for the next shelf, one book is placed, one book you have placed. You don't need to worry which one, but one you have placed. So you'll come at the next place and you'll see that, okay, now I have just 3 books left and here I have 3 choices. I have 3 ways to put a book because I have 3 books. Either I can put any one of the 3. Now next one, you'll have 2 choices, and in the end, by the time you come to the last shelf, all the 3 books are kept and only 1 book is left, so only one way you can put. Now what have you done? You have done multiple things. It's not that either you have to place here or here or here or here. You are doing 4 things at a time. You are doing 4 things at a time. Getting my point? You are doing 4 things at a time. So you'll multiply. You are doing these tasks simultaneously. Okay? So 4 3s are 12, 12 2s are 24, totally 24. In 24 ways you can do this arrangement. Imagine this. Okay, you can do this arrangement in 24 ways. Either 4 over here, 3 over 3, 4 ways to do this work, 3 ways to do this work, 2 ways to do this work, and 1 way to do the last work. Why are we multiplying? Because we are doing 4 things together. This is very important to understand, that where to use or and where to use and. Okay, get my point? It's not an or task, it's an and task. We are doing all the things together. First we did this, then this, then this, then this. That's why we multiplied. Got my point, everybody? Sir, how is MTG NCERT at fingertips? For every book is good, Parshva. You know, you just need to make a good use of it. You know, it's not good to keep too many books also at a time, right? If you can study, you have time to understand that. If you have time to go through that, it's good. Many books are there. Cengage, MTG, so many books are there. It depends on which preparation are you. For JEE you are asking, yeah, it's a good book, I would say. For formulas for fingertips, definitely yes. 10 athletes are competing in a race. In how many ways they can occupy top 3 positions? There are 10 athletes. There are 10 athletes and they are competing in a race. Now over here, suppose you had 4 shelves, but you had 6 books. Suppose you had 6 books. Again, imagine yourself in the same condition. Either you'll keep all the 6 books here, okay, or after keeping one of the 6 books, for the first place you'll have 6 choices. 6 ways to keep a book in the first shelf will be 6 ways to keep a book in the first shelf. So we have written 6. Next shelf, one book is already kept, so now you have 5 ways. 2 books are already kept, now you have 4 ways to keep a book here. Okay, 3 shelves only, so we don't need to think about more. Now total number of ways to keep 6 books in 3 shelves would become 6 into 5 into 4. We have to multiply because we are doing 3 things simultaneously. So 120 ways. Correct? So it's not necessary that you should have 4 books and 4 shelves only. With lesser shelves also you can do this arrangement. 10 athletes are competing in a race. In how many ways they can occupy top 3 positions? I think 7. Yes, Aryan, very good. Great. Hi Aryan, how are you? God bless you. 10 athletes are competing in a race. So let's say top 3 positions. This is first, this is second, this is third. Okay. On the first position, how many athletes can come? How many athletes? Only 1 athlete will come. But what choices you have? How many choices you have for the first position? Or let's start with third position. How many choices do you have for third position? You have 10 choices. All 10 can be third. Any one of the 10 can be third. Correct? Once somebody has come third, Now for second and first position, the remaining will be left. So let's say now for the second position only 9 are left, and for the first position only 8 are left. Same thing we are doing, right? We are just arranging. This is first position, this is second position, this is third position. So if we have 10 choices for the first position, for second position we'll have 9, for the third one we'll have 8. 720, correct Vijay, right? So we'll have 720 ways to do this. Simple to think. And we are doing all the three things simultaneously, one after the another. Keep this in mind, okay? That whether we are doing this completing this process by doing multitasking, right? Simultaneous tasks, or we are doing, we are having a choice that either we can complete it this way or we can complete it that way, okay? 7 flags of different colors are available. How many signals can be transmitted by using 2 flags at a time? By putting one above the another, leave it, okay? Leave that part, or by putting one above the other. Let's say we are putting like this. One flag will be here, one flag will be here. One flag we can put here, one flag we can put over here. And 7 flags we have. We have to pass a signal. You must have seen, no, those scenarios where they give signals using 2 flags. Red, green means something, green, yellow means something, or green, blue means something else. So there are, how many signals can be passed? If you have 7 different flags and you can use 2 at a time, just think like that. So for the first one, you have 7 choices. Suppose you have 7 choices. Beggar, how many have? Yeah, all the colors of rainbow. Let's say you have all the 7 colors of rainbow. So first flag, you can pick any one of the 7 flags. Now second one flag you have already picked. So remaining will be 6 flags. So 6 flags for the remaining choice. Getting my point? For the first flag, 7 choices you have. Any one from the 7, from all the violet, orange, blue, green, 7 colors, any one color you chose, remaining will be 6 colors. So in the other hand, you'll pick one of the 6. So 7 ways to complete first thing and 6 ways to complete second thing. And because we are doing it simultaneously, we'll just multiply 7 into 6. That means we have 42 ways to complete this process. How easy it is to understand. Just a minute. Why is this not moving? Okay. Okay, try this one. Just try for a minute. Take 30 seconds, 40 seconds and try this one on your own. I'll explain. In how many ways can a key of 3 digits be decided for a number lock containing numbers 0 to 9? Those suitcase keys, right? We roll and fix a digit and get my point, right? 0 to 9, there'll be 3-digit lock, 3 digits, a lock of 3 digits. We use it on, I don't know nowadays which suitcases are you guys using, but I've used that one a lot, which had 3 numbers at one, like it'll be circular, and in the front we'll see 3 numbers and remaining will be at the back. So in how many ways can you set the lock there? Can you think about it? Give it a try. Basically, what are we going to do? For the first, now suppose 3-digit lock is there. What can be the locks? 000, 001, 002, 003, 004, 005, 006, like that. 011, 022, 033, too many. We cannot count on fingers. So we have to use the principle of counting, the fundamentals of counting. They'll be, 0 is also a log. It's not saying the numbers are not repeated or all the 3 numbers can be different. There is nothing such given to us, correct? So any of the digit from 0 to 9 can be a number in that 3-digit lock. So for the first position, there will be 3 positions. For the first position, how many choices we have? 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good, Vijay. For the second place also we have 10 choices. For the third place also we have 10 choices. Who said they cannot repeat? 0, 0, 0 is a lock, right? 1, 1, 1 is a lock, 2, 2, 2, 3, 3, 3, 4, 4, 4. Like that, all are correct locks. So total number of possibilities or total number of arrangements of these numbers, total number of possible keys or total number of ways to form a key can be 10 into 10 into 10. That means 10 to the power 3. We have to do all of them at a time. Correct? We are doing this task one after the another. Palindromes, do you understand? Palindromes means Malayalam, M-A-L-A-Y-A-L-A-M. If you are going through computer coding or something, you must be doing this code. You must have done this code of making a palindrome, or palindrome is a common term. You must have gotten. Palindrome means you read it from this side, that side, same thing. You read it, Malayalam, if I read from this side, M-A-L-A-Y-A-L-A-M. If I read it from this side, M-A-L-A-Y-A-L-A-M. But we have to create a 5-lettered palindrome. This is a palindrome. Palindrome means you read it from either side, it's the same word. 5-lettered palindrome, that means, suppose, right, let me erase this. Okay, 5-lettered palindrome you have to make. Now, how many letters are there in English alphabet? I didn't say 6, 7, 20. Okay, rotor. Rotor is a palindrome. Any other palindrome you can say? Many famous palindromes are there. I don't know. Many names are even palindromes. Yeah. Okay, I'm not getting. Amma, yeah. Amma is such a nice word and such a good palindrome. Great. Ayo. 5 choices, 5 places we have. Nayan. Wow, good. For first, think about it like this. For first block, suppose we are filling this block. First block. Okay. How many choices we have? 26 letters in English alphabet. 26 choices we have. 26 ways to fill that. Correct? Now, whatever we have filled here should be here. Correct or not? Whatever letter has come here should be here also. So, should I say 26 ways to do this? No, right? I have taken 26 ways here, same 26 ways here, right? So, only one way. Why one way? Because whatever is coming here, same thing will come here. Correct? Now, remaining will be 25. Remaining choices I will have is 25. One letter I have put, right? I am not repeating. 25 here and same will be here. For this one, 24. So, answer will be 26 into 25 into 24. These many palindromes can be made using English alphabet. Right? Whatever comes here will come here. Whatever comes here will come here. So, one way only to fill this one. Right? Now, not same 24 ways or 26 ways or 25 ways. Same way. 24 here. For the middle one, I will have 24 choices. So, total number of palindromes which can be made using English alphabet will be these many. Too many, I think. Now, general applications also you can think about. Why do we have 10-digit mobile number? We have 10-digit mobile number in India, right? Nowadays, I think, yeah, it can start with any. So, itself, from 9 itself, if we start 1, 2, 3, 4, 5, 6, 7, 8, 9. General things if you imagine. We have 10-digit mobile numbers. If we start all the numbers from 9 also, to fill the first place, we have just one choice. Right? Now, for the second place to fill, 9 is used. 9 can be used again. In mobile numbers, numbers can repeat. So, now for the second place, we have 10 choices. 10 into 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 10. So many numbers. Billions. Correct? 10 into 10. All these. So many numbers can be made. There can be so many possibilities. That's why they keep 10 numbers. Suppose in a country, population is low. Right? A small country. Their population is low. So, they don't need to use 10-digit mobile numbers. India population is super awesome. Rombanalla. So, that's why we need 10-digit mobile number. We have too many people. And every person is trying to keep at least 2-3 mobile numbers. One for the school use or official use. One for just WhatsApp or something else, or multiple uses. So, nowadays, we might even need 11-digit very soon because the population is even increasing now. So that is the reason. So we have too many choices, we have too many numbers. Number codes we are making, then we have 26 into 25 into like that, or 3-digit code we want to make using alphabet itself, where 3 letter code we have to make with alphabets itself. Then it can be too many, right? And we can repeat also then 26 into 26 into 26. If we can't repeat, then 26 into 25 into 24. Getting my point? Now, in this same question, I said in the starting that in palindrome, if we cannot repeat the letters, in that case we'll have 26 into 25 into 24. But if we can repeat also, then 5 lettered, right? So 26 here, 26 here, 26 only here. These two will be 1, 1, because same thing will come. So 26 to the power 3, if we can repeat, because yeah, A. This is a palindrome. This is a palindrome. You read it from any of the side. This is a palindrome, right? 26 to the power 3. Tricolor flag is to be formed having 3 adjacent strips of 3 different colors chosen from 6 different colors. How many ways? Tell me. Tricolor flag. First strip, let's say. Second tricolor is our flag itself, Indian flag itself is tricolor, right? So 3 strips, you have 6 different colors. First strip, let's say you have 6 choices, 6 ways to fill the first strip, 6 ways. For the second one, having 3 adjacent strips and 3 different colors chosen. 3 different colors we are choosing, it's mentioned. If it is not mentioned, we have to by default think that yeah, it can repeat. But here it is mentioned that different color chosen from 6 different. So 6 ways to do this, 5 ways to do this, 4 ways to do this, 6 into 5 into 4. Correct? 120 ways. Sir, सिर्फ one side आ रहा है earphone के आवाज सिर्फ. Then other side is not working properly into edits tutorials. I think there must be some issue. Somebody, can you please confirm that if the voice is clear, because in my system it's showing clear only. Let me check once again. Vijay, can you confirm? Everything fine? Yeah. आवाज एक साइड कैसे आ सकता है? How can it come just one side? Okay. Next thing, in an exam there are 3 true or false coming. All is okay, right? In an exam there are 3 true false. This one you are asking, Avenger? This one you are asking 6 ways, 5 ways, 4 ways, right? 6 ways to fill the first strip, 5 ways to fill the second strip, and 4 ways to fill the third one, because 3 different colors we have to choose. So that's why. Okay. In an exam there are 3 true or false questions. In how many ways can we attempt the paper? If each question has to be attempted, that means question 1, let's say question 2, question 3, we just now spoke about this, right? Each question has to be attempted. So first one either true or false, second one either true or false, third one either true or false. Correct? We have to attempt, either we can give true or we can give false. It's not that we can leave the question. Either true or false, either true or false. Every action has 2 choices and action is repeated 3 times. How many times? So what will be the answer? 2 to the power 3. Every action had 2 choices and action is repeated 3 times. So 2 to the power 3. 2 to the power of 3. Getting my point? Yes or no? Okay. 2 into 2 into 2, 8. In an exam, 3 true or false are, this time we have, one can attempt or leave the question. We have the choice to even leave. If we don't know, we can leave the question. So this time what will happen? What has changed? What thing has changed? Nothing. 3 choices. Every question has 3 choices now. Either true, false or leave. We don't attend that. Right? Same thing with question 2. Either true, false or just leave. So 3 choices. right? Third question also, either true will give, either or false will give, or we'll have the choice of leaving. So every action has 3 options, 3 choices, or 3 things, 3 ways it can be done, and we are repeating same thing 3 times. So what will be the answer? 3 to the power 3. We are repeating it 3 times. So 3 to the power of 3, simple thing. Either we can leave or we can attempt. At least one question has to be attempted. At least one question has to be attempted. In how many ways we can attempt all the 3 questions? In how many ways can we attempt all the 3 questions? Total ways 27, right? Just now we saw 3 to the power 3. Total ways are 20. Whenever we have to do something like this, no, at least one, not neither, we should start thinking about complement, that total minus what if this does not happen. We do the same thing in probability also. Remember, so here also we can, at least one has to be attempted. Now what can be the scenario? Either I'll attempt none of them, either I'll attempt none of them, or I'll attempt at least one. Na? Either I'll leave all of them. I'm not doing anyone. I don't know anyone, any one of the questions, so I'm leaving all of them. So that's why in one way I can leave all of them. Total ways are 27. If from total ways I can subtract one way where I'm leaving all of the questions, because there is only one way to leave all of the questions. First one left, second one left, third one left. Right? Total ways minus that one way will give me the number of ways in which at least I'm attempting one. If I'm subtracting the way in which I'm leaving all of the questions, in that case I'm getting the number of ways in which I'm attempting at least one. Right? That's the choice, right? That's the only choice. Either I'll leave all of them or I'll attempt at least one. Attempt. Correct, wrong, leave it. Okay. Now it's a good question. Let's look at this one. Imagine yourself again while counting how many odd, see, in the entire PNC I would say, paying attention at type of questions. It's all about the more variety and type of questions you know, right? If you can understand the type of questions and understand the concept from that type of question, PNC is easy. It's about just the variety. It's not that there are standard methods. There are many standard methods, many books which will teach you different type of standard methods, but how many methods will we remember? So it's better we remember question scenarios, and definitely the standard approaches I'll keep telling you, where you need to actually stick to the formula, there are also I'll tell you. How many ordered pairs are there such that LCM of A and B is 3 to the power 4, 7 to the power 3? LCM of A and B is 3 to the power 4, 7 to the power 3. What does this mean actually? That means that there are there are A and B. A is some number which has 3 to the power something and 7 to the power something. Correct? Let's say A is already used, so X1 will use and Y1 will use. Okay, and there is a number B which also has 3 to the power something, which is let's say X2, and 7 to the power something, which is let's say Y2. Correct? Getting my point? So now I want total number of ordered pairs, these A and B. I want all these pairs A and B in which LCM of A and B is 3 to the power 4 and 7 to the power 3. How can I create that? That means the maximum of the power of X1 and X2 should be equal to 4. If this is 1, this is 4, LCM will have 3 to the power 4. If this is 2, this is 4, LCM will have 3 to the power 4. This is 3, this is 4, LCM will be 3 to the power 4. Now this is 1, this is 4, this is 2, this is 4, this is 3, this is 4, this is 4, this is also 4. Try to imagine the situation. Correct? When will the LCM of these two numbers will have 3 to the power 4? When maximum of X1 and X2 will be 4. What can be the possibilities? What can be the possibilities? Either I can have 4, 0, or I can have 4, 1, for X1, X2 I'm talking, or I can have 4, 2, 4, 3, 4, 4, 5. 4, 5 I cannot have, right? Maximum only it can go to 4. Right. Now with x2 also I have to check, right? 0, let's say this time x2 is increasing from 0, 1, 2, 3, 4. Now x1 from 0, 1, 2, 3, 4. Correct. So now 0, 4, this one is 0, this one is 4, 1, 4, 2, 4 and 3, 4. How many choices do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ways I can do this. I can get, if in all these scenarios of x1 and x2, in all of these 9, I am having LCM as 3 to the power 4. Correct. Now same thing we have to do with y1, y2. What can be y1, y2 maximum? Y1, y2 maximum can go to 3. Maximum they can go till 3. Max here is not a function, I am just saying maximum value they can go till 3. So here we have 9 different ways to do this. Here same thing you have to do, 3, 0, 3, 1, 3, 2. If this is 3, this is 0, this is 3, this is 1, this is 3, this is 2. In all these cases 3 will be the, 7 to the power 3 will be the LCM, right? Or 0, 0, 3, 1, 3, 2, 3 and one more 3, 3. Both are 3, that is also a case, right? 1, 2, 3, 4, 5, 6, 7. 7 ways. Now both things we are doing simultaneously, no? A and B. We are creating A and B. 9 ways to create A. 9 ways to create 9 ways to create 3 to the power x into 3 to the power x2, and 7 ways to create 7 to the power y1 and 7 to the power y2. Both things we are doing simultaneously. So what will be the answer? Answer will be 9 multiplied with 7, that means 63 ways. Why multiplied? Also pay attention. Why are we multiplying? We are doing this simultaneously, right? We are creating this, then we are creating this. At one go only we are doing this complete task. Now again we'll stick to fundamental principle of multiplication or fundamental principle of counting, one of the same thing only, not different. Sometimes we'll get constraints. Now what's written over here, very important thing, always start from the constraint. Whenever some constraint, some restriction is there, you cannot do this or you cannot do that, first put your focus on the constraint, what we are not supposed to do, what is not allowed. Okay, there start your question from there, that's what written. How many 7-letter words can be formed by jumbling the letters of triumph such that vowels are at extreme positions? 7-letter words. So how many letters we have? 1, 2, 3, 4, 5, 6, 7 only. So 7 letters and 7 letters word. 1, 2, 3, 4, 5, 6, 7. 7 spaces we have, 7 positions we have. Okay. Vowel should be at extreme positions. How many vowels? A, E, I, O, U. We have only I and U. Right? Any other vowel? Do you see? I'm bad in English. Such, really. Right? 2 ways only. 2 vowels. So to this position, okay, think like this. This position and this position, extreme positions. So these 2 positions will hold the vowels. In how many ways we can arrange 2 vowels in 2 places? 2 into 1. This 2 into this one. Correct. Now remaining ones we have to arrange over here. Vowel we had 2 vowels and we had 2 places only for arranging these vowels. The restriction is that we have to arrange the vowels at extreme positions. Correct. So we are arranging the vowels at extreme positions. 2 options, 2 ways to fill this place, 1 way to fill this place, to arrange 2 things at 2 places, 2 into 1. Right. Now remaining, how many are left? Out of 7, 2 are gone. So 5 into 4 into 3 into 2 into 1. Everything multiplied. How much? 120 into 2, 240. 5 factorial. Factorial, you know, right? This is factorial only. We are writing factorial only. Number of arranging, the number of ways to arrange n things at n places is n factorial. Do I need to mention that? I don't think so, right? You are getting my point. N factorial means n into n minus 1 into n minus 2, like that. So 5 into 4 into 3 into 2 into 1 into 2. That means total 240 ways we can do this task. We can complete this task in 240 ways. Okay, how many words can be formed by rearranging letters of Delhi such that vowels occupy odd places? Another restriction. Is repetition allowed or not allowed? Are there any letters which can be repeated? No, repetition is not allowed, right? Here repetition is not allowed. Okay. How many words can be formed by rearranging letters of Delhi such that vowels occupy odd places? Here also, don't think that repetition is allowed. I am mentioning that. Okay. Correct. Now, how many words can be formed by rearranging the letters of Delhi such that vowels occupy odd places? How many letters? 5 letters we have. 1, 2, 3, 4, 5. Okay. 5 places we have. D, E, L, H, I we have to arrange. What is the restriction? Restriction is that vowels occupy odd places. Vowels have to occupy odd places. Odd places means this is place 1, this is 2, this is 3, this is 4, this is 5. So vowel can be here, here or here. How many vowels do we have? We have E and I only. Okay. We have to arrange 2 things, E and I, at 3 places. Now pay attention, this is going to be important. We have to arrange 2 things at 3 places. Now in this particular job or in this particular task, what do we need to understand is that if we have to arrange 2 things at 3 places, it's not that we can split one thing apart and half of it, or divide it into 2 other places. We have to leave one place empty. That's what we have to leave, one place empty. Which place to leave empty? Either first place we can leave empty, second place we can leave empty, third place we can leave empty. So 3 ways to leave a place empty. 3 ways to leave a place empty, and remaining 2 into 1 ways to fill up 2 letters in the 2 places, remaining 2 places. Correct? Correct or not? Get my point, right? So here also we have to leave one place empty. So 3 ways to leave one place empty, and remaining 2 into 1 ways to fill up the 2 vowels in those places. Okay, now one place is empty. To leave that empty, we have counted the number of ways. One place is empty. How many letters are left now to arrange? 2 we have arranged. Out of 5, 2 we have arranged. Right? 2 we have arranged. Remaining 3 are there. So those 3 in 3 different places. One place is empty, remember, don't forget that. This 3 is for leaving the place, number of ways to leave the place empty. We have to think it in a different way, right? 3 ways to leave a place empty, and here we are doing, thank you Parth, same to you, 3 into 2 into 1. Now 3 places are left and 3 letters we have. 3 places, why am I saying? Because one place is empty, 2 only are placed, 2 vowels only are placed, right? So again 3 into 2, this into this into this. Total number of 3 2s are 6, 3 2s are 6, 36 ways to complete this task. This is actually important. Like if you can revise this afterwards, you'll get a good feel. You have to understand 3 ways we are leaving a place empty. Okay, then 2 ways we are arranging our vowels. Again, for remaining 3 letters, we have 3 into 2 ways to arrange those 3 letters in 3 places. Okay, great. Now we'll start mentioning repetition, allowed, not allowed. So far we were just assuming by default that repetition was not allowed. I didn't mention that, but otherwise I would say a disclaimer that if it is not said that repetition is not allowed, you have to assume that repetition is allowed. In a examination question, this happens, you have to assume that repetition is allowed and give answer accordingly. Okay. How many 4-letter words containing S can be formed using letters of discover when repetition is not allowed? How many 4-letter words? 4. All letters are different. Let's see, D, I, S, C, O, V, E, R. Yes, this is also important. We'll realize it. Afterwards, we have to check whether all letters are different or not. In exam, don't directly just hop on to the answer or solution. Check whether they are all different. Yes, here all of them are different. Let me write discover. Discover. Okay. Repetition is allowed and repetition is not allowed, and repetition is allowed. How many places? We have 4 places because we want to make 4-lettered word. Correct? Can you give me an answer here? One more restriction is there. There is one restriction that S has to be there in all of them S has to be there. Okay, so for putting S, how many ways do we have? Either S can be here, 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 because S has to be there, that's a restriction. For putting S over here, how many ways do we have? 4 ways. 4 ways to put S. In this word. Either first place we can put S, second place, third place, or fourth place. We can put at any of the place for S. Now, remaining 3 places we have. For 3 places, how many letters we have? S is gone, S is used. Repetition is not allowed. We are doing the first one, right? We are doing the first one. Okay. For S, for putting S, we have 4 ways. I'll write it again. Right? 4 ways to put S. Now, once you have placed S, remaining 3 places you have, and in these 3 places, how many letters you can put? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8, S is gone. S is gone. Repetition is not allowed. So, S is gone. So, 7 you have to put. So, in 4 ways, you will put S and remaining letters. Remaining 7 in 3 places. Remaining 7 letters in 3 places. So, how many ways? 7 into 6 into 5. So, what should be your answer? 7 into 6 into 5 into this 4. 4 ways to put S. Correct or not? Or you can also say 4 into 7 into 6 into 5. Same thing. Same answer you will get same. 4 into 7 into 6 into 5. Correct. How much is this? 840. Very good, Vijay. 840. Correct. Okay. One more thing. This can also be done like this. Complementary method also we can use over here. That total number of ways to form a 4-lettered word using the letters of discover. 8 letters are there. So, 8 into 7 into 6 into 5. Right? If we don't think about S right now, we have to make a 4-lettered word using the 8 different letters of discover. So, what we'll do? 8 into 7 into 6 into 5. Repetition is not allowed. Now, we can subtract those words which are not with S, in which S is not coming. That means we excluded S. One of the letter we excluded only. So, how many letters will remain? 7 letters will remain. So, those words will be where S does not come. Where S does not come. Those words where we are not including S. That means we are just arranging 7 letters which are remaining. That means 7 into 6 into 5 into 4. Whichever way you feel comfortable, you just need to know both the methods. That's what I'm telling. Right? This minus this. So, 1680 will be this and 840 will be this. The answer will be 840 only. It will come as 840 only. Answer will be same. Answer won't matter. So, remaining 3 letters, yeah, same thing which we used just now. Right? If repetition is allowed, no problem. Your choices differ now. Your choices will be more. If repetition is allowed, so that means now with S, you have 4 choices for S. With S, you have to fill up. For these remaining, do you have 7 choices or 8 choices? 4 choices to put an S. 4 ways to put an S in this word. Put an S is sounding, I don't know, right? 4 ways you can include S. Either S will be here, here, here or here. In 4 ways you can include S. After including S, you have 3 places left. In these 3 places, what will happen? Which letters can come? S can come. Repetition is allowed. S can come. Same letters can come. Anything can come. So, all 8 can come. Getting my point? All 8 can come over here. No? No. This is not the correct way. This, no, 4 into 8 into 3. No. 8 into 3? How? 8 into 8 into 8 or 8 cube? No. Think. Repetition is allowed this time. We have to think it with the complement method. No. How will you put 8, 8, 8? S will come, all S will come, all that will we cannot differentiate between SS, first S, second S, third S or 4S. These will be same words. So, doing that, if we are doing that, we are counting too many scenarios, right? 4S can be written in any position, first S, second S, third S, 4S, we are not differentiating now. So, we are counting too many methods. We have to think of another approach now. How? What can we think about? Tell me. Should we use complementary method over here? total ways of creating 4-lettered word using 8. So 8 into 8 into 8 into 8. These are total words which are of 4 letters and are using the letters of discover. Correct? Minus those words which exclude S. Minus those words which exclude S. That means we are not using S. 7 into 7 into 7 into 7. Getting my point? Why? Viji, 4 into 8 to power 3, in that you are including everything. Everything. Right? In that, position of S will also matter. So this is how you'll have to calculate. Right? 8 to the power of 4 minus 7 to the power of 4. How much? 8 to the power 4, I don't know. Somewhere around, okay, let's check. 4096 minus 2501. Yeah, 1695 should be your answer. S can be formed, right? Great. Now, there are 5 questions where this is also one standard type, you can say, or a common type which can be asked in different language or different scenario or question framing. But yeah, sorry. There are 5 questions, each having 3 options. In how many ways they can be attempted such that no 2 consecutive questions are marked with same options. No 2 consecutive questions are marked with same options. Just give it a while to think about this. I want you to imagine this in your, Vijay, you answered something? Okay, leave it. Imagine this, how this would be happening. I'll give you an idea. Suppose question 1, each having 3 options, right? Question 1, option 1, option 2, option 3, right? 3 options. So question 2 also option 1, option 2, option 3. Question 3 also option 1, option 2, option 3. Now the question is asking you to do one thing, that if you are choosing option A here, you cannot choose option A here. That's what. Give it a minute. I'll just fill up water and come back in a minute. Sorry. Yeah. Question 1 had any answers? Sir, Vijay asking for repeat the previous question. I don't think so. Vijay will ask herself. Ritz, don't worry. Now suppose from these 3, I choose any one. So how many ways I have to attempt the first question? How many ways I have to attempt the first question? Sir, I have 3 ways. I'll either choose option A, option B or option C. But if I have chosen option A here, I cannot choose option A over here. Correct? How many questions are there? 5, no? I'll write all 5. If I have chosen option A over here, can I choose option A over here also? No. So how many ways? Suppose in this one I chose option A. Here I cannot choose option A. I can choose option B or option C. So I have only 2 ways, no? Right? Now suppose I had 2 ways, B or C. Now suppose I chose option C. For this one, what choices do I have? A or B I can choose. I cannot consecutive, no 2 consecutive questions can be marked with the same option. They are not asking about same option cannot be marked only. No, no 2. If I have chosen, if I have 3 ways, if I have chosen any one out of 3 over here, that one I cannot use in the second one. I cannot choose in the second one. So 3, very good. 3 into 2 into 2 into 2. Great, Vijay. Right? Because this one I have 2 choices. Again, for this one also I'll have 2 choices. This one also I'll have 2 choices. This one also I'll have 2 choices. 48, correct. Very good. Understand this. First question I have chosen 3. First question I have 3 ways to do this. Once I have done this, second question I have remaining 2 ways to do. Because A I cannot choose, B and C I can choose. Suppose I chose B over here, then A and C I can choose. Suppose I chose C over here, then A and B I can choose. Suppose I chose A again, then B and C I can choose. Every time I have 2 choices. Consecutive options I am talking about. So 3 into 2 to the power 4, 16 into 3, 48. Correct? Got my point? Understanding the concept is important over here. Don't worry about answer. Answers will start getting. Okay? Now, next one. A flag is colored with 4 stripes using 6 different colors, no consecutive stripes being of the same. Same thing? Right? Same previous question. Same scenario, no? Flag to be colored with in 4 stripes by using 4 stripes. We have done this type of question, but this is related to the previous question, similar scenario. And I think this is a previous year question, but it's not marked. My PPT itself, I don't know why this comes like this. I've tried multiple things. I'm not that text heavy, but I'll ask the team to help. Okay. So first stripe, if you are using 6 ways, all 6 ways, all 6 colors are open to you. You can fill up any one of them. 6 different colors you have. First stripe you can fill with any of the 6 colors. So 6 ways to fill up the first stripe. Whatever color you used in the first stripe, that you can't use in the second stripe. Consecutive stripes, no 2 consecutive stripes being of the same color. That's what is mentioned. Correct? Same color, yeah. No, this can be done in. The entire question is not coming. Okay. So for if you have chosen any one, that you cannot choose. So 5 ways. Again, for this one you will have 5 ways only. This you can include, the top one you can include, but this one you cannot include. So 5 ways. 1 way increase, no? Very good. 750. 5 to the power 3 into 6. 125 into 6, 750 only. Let's do some more. Let's do some problems on making numbers. Yeah, same thing we can use. Same concept. Arrangement concept or counting concept which we are using. Same thing we can use to make numbers also, or to see some problems based on numbers also. How many 4-digit numbers with possible repetition of digits can be made with no digit less than 5? 4-digit number with possible repetition of digits can be made with no digit less than 5. Would you like to give? I'll give you 20 seconds. Come on, read the question, try it in your mind. Because directly looking for the solution, I don't feel nice with that. I don't feel that should be done with this by the students. Read it, think about it in your imaginations. With no digit less than 5. That means 5, 6, 7, 8, 9. 10 we cannot include. 5 we can use, 6 we can use, 7 we can use, 8 we can use, 9 we can use. That means 4-digit number you have to make. None of the digits should be less than 5. That means 0 cannot come, 1 cannot come, 2 cannot come, 3 cannot come, 4 cannot come. 5, 6, 7, 8 and 9 can come. So 5, 5, 5, 5. Repetition is allowed. Repetition is allowed. With possible repetition, it is written, it is mentioned in the question. 5 to the power 4 is 625, correct. Very good. How many 4-digit numbers can be formed using 1, 2, 3? Now see, here if it is not mentioned, you have to assume that yeah, repetition is allowed. If it is not mentioned, it is here also it's written that here it's not required to be mentioned that repetition of digits is allowed. In such cases, sometimes you have to assume that yes, repetition is allowed, because we are using 1, 2 and 3. We have to use 1, 2 or 3 and we have to make a 4-digit number. We can make only if repetition is allowed. We can make without repetition also. Without repetition we cannot make. Can we? So it does not need to be mentioned that repetition is allowed over here. Correct. Now if repetition is not allowed, for first place, how many options do you have? For first place, how many options do you have? 3. For second place, how many options? 3. For third place, 3. Fourth place, 3. That means 3 to the power 4. How much is that? 81. Correct. Got my point, everybody? 3 to the power 4. You can fill this up with 3 ways to fill this one, 3 ways to fill this one, 3 ways to fill this one, 3 ways to fill this one. Great. The number of 5-digit numbers which are divisible by 4 with digits from the set. Okay, this is a question PYQ, that means previous year question. Good, let's pay attention at this one. Number of 5-digit numbers which are divisible by 4. I think there only they are trying to play the trick. Divisible by 4 means last 2 digits, right? I am also forgetting. Yeah, last 2 digits. Last 2 digits should be divisible by 4. That's the mandatory condition for divisibility of 4. The number of 5-digit numbers, so 1, 2, 3, 4, 5, with digits from the set 1, 2, 3, 4, 5, and the repetition of digit is allowed. It is mentioned that repetition of digit is allowed. Okay. Now, last of the 2 digits should give me a multiple of 4, right? That means last 2 digits should be divisible by 4. So how can I form this scenario? 1, 2, 3, 4, 5 I have. Let's start with 1. If I club 1 with 2, 12 is divisible by 4. If I club 1 with 3, 13 is not. 1 with 4, 14 is not divisible by 4. 1 with 5, not divisible by 4. Okay. Then start with 2. 2, 1, 21 is not divisible by 4. 23 is not divisible by 4. 24 is. Okay, I'm just writing how many. I don't think many will get. 24 is divisible. Then from 3, 31, no. 32, yes. 3, 4, 34, 35, no. 41, 42, 42 is no. 43, no. 44 is. With 5, 45 is also not divisible by 4. With 5, 51, no. 52, yes. 52 is divisible by 4. 53, no. 54, no. 55, no. Right? So we have these 5 possibilities. So basically this is just one place only. Let's consider this as one place only. One place where there are 5 ways to fill this place. Why? Because last 2 digits should be a multiple of 4. So we have 5 ways to fill this place up. Remaining, anything can come. Repetition is allowed. So 5, 5, 5. All 5, any of the 5 can come. 0 is not there, so we don't have restriction for the first place also. So that's why 5 to the power 4. Again we got 625 as our answer. Easily we got the answer. Yes. Here advanced just wanted to check your divisibility maybe. And you know, advanced also, you know, it's not every time easy. There have been some years where advanced was really easy. It's 2016, if you look, the math was scary. Yeah, there have been some years when math was actually scary, but it's not always. And in every paper, you know, there will be some questions which will be your favorite ones, or you can pick them up, right? It will always happen. How many answer was 625, yes. How many 3-digit numbers less than 600 and divisible by 5 can be formed using 0, 1, 2, 3, 4, 5, 9? First case where repetition of digit is allowed. Read it once, please, everybody. Percent digit numbers. Where percent? Where beta? Where percent is mentioned? Ramatar? No percent digit numbers. 5 digit. Maybe the screen is not that clear. 5 digit numbers. Okay. Repetition of digit is not allowed. First case. Repetition of digit is not allowed. Okay. First we need to. Okay. 3-digit number we are making. So 1, 2, 3. Okay. 3-digit number we are making. What is the condition? We have to start with the constraint. It was written, right? It was mentioned that we have to start with the constraint. Constraint means the number should be less than 600. First of all, that is a constraint, and it should be divisible by 5. It's a divisible 5 is a good constraint for me, because I know either 0 should be the end digit or 5 should be the end digit. Correct? Correct or wrong? Correct? Okay, 0 or 5. So here for this place I have 0 or 5. Okay, then for the first one, what is the constraint? That number should be less than 600. Achha, 0 is also included in the set. So 0, I cannot start the number with 0. I cannot start the number with 0, otherwise it will be 2 digit only, right? So I cannot put 0 over here. For this one my constraint is I cannot put 0. And one more thing, yeah, I cannot take 9 also. If the number starts with 9, it will be more than 600, right? Only 9, right? I cannot take 9 also. I cannot take 9. So 2 different constraints. Okay. But this thing 0 or 5, either 0 is also okay or 5 is also okay. Now OR situation is here. So actually I have to make cases. Cases means I will be adding. Whenever we are making cases, no, basically we are adding. We are seeing scenarios where this is also a way of doing this, that is also a way of doing this. So far we were doing 0 can come and 5 can come, 4 can come, 3 can come and, correct? This time we have a choice. Either 0, all those numbers which are ending with 0 also are divisible, all those numbers which are ending with 5 are also divisible. Got my point? So I have to break this now. Either I'll take the case when ending with 0 or I'll take the case when ending with 5. I'll have 2 cases now, correct? Now if 0, it is repetition is not allowed. 0 we have used. So here 9 cannot come. 0 we have used, so 0 is not coming here anyway, correct? 0 is not coming here anyway. So for the second one, what option do I have? 9 cannot come over here. So how many choices except 9? 0 is already taken, 1, 2, 3, 4, 5, 5 choices for this one. 9 cannot come, 0 is already taken, remaining out of 7, we have 5 choices, so 5. Now for this one, repetition is not allowed, so 4. Repetition is not allowed, so 4. Or is it correct? 4? No. 4, repetition is not allowed, but 0 can be included in the middle digit. For middle digit, how many choices I have? I have taken 0, I have taken 5. For this particular place, except 0 and 5, 1 can come, 2 can come, 3 can come, 4 can come and 9 can also come over here. So 5 choices, correct? So 25 ways to do this one. Either I can complete this task by this method or I can do this. If 5 is coming here, then for the first digit, how many choices do I have? 5 is taken, 0 cannot be taken, 9 cannot be taken. 5 is taken already, so I cannot use 5 now. 0 I cannot use, number will become 2 digit. 9 I cannot use because number will go above 600. So how many choices? Out of 7, 3 I have removed. So remaining 4 choices. I have 4 choices now. Correct, for the first place. For the second place, 5 is taken, 4 is taken. Remaining anything. In the middle number, in the middle digit, anything can come. So 5. So this is 4 into 5. Oh, this is not 5. This is one way. Wait, this is one way. Right? This is one way. In one way only we can put 5, no? Like here also one way. This was 1. So 4 into 5. Total. So either I can complete this task using this approach or this approach. Either I can do this or this. So I'll add. Why am I adding? Now I have OR scenario. I have OR scenario. Pay attention. Okay. 25 plus 20, 45 will be my total number of ways to do this. That's it. Okay. Now 3 digit, same, okay, repetition of digit is allowed. Now you can tell me. Now it's even easier. Repetition of digit is allowed, not a problem only, correct? Repetition is allowed, na? Do I need to create cases now? I have 3 places. This one I can fill either with 0 or with 5. So 2 ways to do this. Remaining here, for first one how many choices do I have? Repetition is allowed. right? Repetition is allowed. I cannot use 0, I cannot use 9. Here I cannot use 0, still I cannot use 0 because that is a different constraint. If I use 0, number will be 2 digit. If I use 9, number will go above 600. So I have 5 choices. 5 is used, and for the middle one, no, 5 is not used, 5 ways. Now for the middle one, for the middle one, for the middle one, for this middle one, what should I do? How many choices do I have? Thank you, Somber. I'll improve. For the middle one, how many choices can you tell me? 7 choices, no? All the 7 choices. Any one of the 7 I can put. I have 7 ways to fill this up. Because repetition is allowed. 0 can come, 1 can come, 9 can come, anything can come. 7 chances. So 35 into 2, that means 70 ways to complete this. Okay, this we have studied in our, I think first chapter sets. If you have studied or you have completed studying, then you must have studied this. Otherwise, I'll also explain this. Number of elements, N A union B means, N A union B means number of elements in A union B. That means combination of, if A has some elements, B has some elements, all are different elements, A and B all are different elements, then number of elements in A union B. N means cardinality. If you are familiar with this term, N means cardinality. Right? N means cardinality. I hope you are familiar with this. Number of elements in A union B. Number of elements in A union B will be equal to number of elements in set A. Number of elements in union of set A and B will be equal to number of elements in set A plus number of elements in set B minus number of elements which are common to A and B, which are common in A and B. That's what it means. Correct? Number of elements in A union B will be equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. That means number of elements which are common to A and B. Got my point? This is something which we are going to use in the further questions, which will ease our problems, Second thing, number of elements in neither in A nor in B. So basically we are going to use this particular concept in the questions which are using either or neither nor, okay, in the cases when we have either or situation or neither nor situation. So either or means this one, either A or B. Number of elements in A union B means either A or B. I'll explain this with the questions itself. Number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay. Second thing, neither in A nor in B. That this means complement. A complement means all elements in A. Number of elements which are not in A. A complement means all those elements which are not in A. The complement of A, the set which has all the elements which are not in set A. Okay. I'll explain this. Don't worry about this. When we'll come to the questions, you'll understand this. And this is number of elements in A complement intersection B complement will be equal to total number of elements minus number of elements in A union B. That means same thing. Total elements which can be formed minus the elements in A union B. Okay, let's come to question and understand this more. How many 5-digit numbers can be formed which either begin with 2 or end with 5? Okay, either begin with 2 or end with 5. Thank you, Rameshwar. How many 5-digit numbers can be formed which either begin with either begin with 2? I mean, I want all those elements, all those numbers which are either beginning with 2 or they are ending with 5. I want those numbers also which are beginning with 2. I want those numbers also which are ending with 5. Right? How many 5-digit numbers can be formed? So 5-digit numbers 1, 2, 3, 4, 5. First, I'll see those numbers which are starting with 2, which are beginning with 2. How many such numbers can be formed? Can you tell me? First place has to be 2. This is 2 only. Here I can put 2 only. So one way, only 2. It should start with 2. Remaining digits, 10 ways for everything. 10 into 10 into 10 into 10, remaining 4. Repetition is allowed. It's not written anything. They have not written anything, so I can repeat. All the 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the 10 I can use for this one, this one, this one. First place I can fill only with 2. Correct? Now, this is my set A. I'll call this set A. Now, I'll call set B. What will be my set B? When 5 digits, 1, 2, 3, 4, 5. In set B, first place, oh sorry, not first place. In set B, what is my second condition? End with 5. So, I'll end with 5. I'll end with 5. Here 5 should come. So, again, this is one way only. For this one, I have 10 ways. For this one, I have 10 ways. For this one, I have 10 ways. For this one. Here, one more constraint. While forming the number, check. First place, you have to check. 5-digit number we are going to make. So, this one has only 9 options because 0 cannot come. Just remember that while doing the question, be careful about that. 0 cannot come over here in the first place. So, 9 options only. So, this is 9,000, 9 into 10 to the power 3. This is 10 to the power 4. This is 9 into 10 to the power 3. Right? Set A and set B. Correct? So what do I want? I want all those elements which are in set A and those elements which are in set B. I want all those elements which start with 2 and all those elements which end with 5. So I want this. What is the formula that we learned? Number of elements that are in A plus number of elements that are in B minus number of elements which are in A intersection B. Correct? A intersection B, do we need to find? Yes, we'll need to find A intersection B also. Which numbers? A intersection B, what will be this? Which numbers will start with 2 and end with 5? A intersection B means numbers which are starting with 2 and ending with 5. Because when I am doing number of elements in A plus number of elements in B, I am actually including those elements also which are starting with A and ending with 5. So I have to subtract that once. Right? So now A intersection B, that means numbers starting with 2 and ending with 5. How many ways to do that? Definitely 10 to the power 3. This is only one way. This is only one way. 10 into 10 into 10 for the remaining places. So 10 to the power 3. Correct? 10 to the power 3 ways. Now apply this. Number of elements in A were 10 to the power 4. Number of elements in B were 9 into 10 to the power 3. Number of elements in A intersection B are 10 to the power 3. So 10,000 plus 9,000 minus 1,000. Right? 10,000 plus 9,000 minus 1,000, that is 18,000. I think 18,000 should be our answer. We'll check it. Answer will be there. Understood the question or not? Either we have number of elements in A plus number of elements in B minus number of elements in A intersection B. A intersection B is 10,000. Intersection means both the conditions are being satisfied. Either this or neither of these, or both of these. Sorry. 18,000. This question can you do? Neither nor. Neither nor. This time we have the condition neither or nor. Right? Neither nor. 4-digit numbers which are neither multiple of 7 nor multiple of 3. So total 4-digit number. What was the formula? For number of, suppose A complement, B complement will be equal to total minus number of elements in A union B. What is our A? A means elements and multiples of 7. A means multiples of 7. What does B mean? B means multiples of 3. Right? Multiples of 7 and multiples of 3. Okay. B means this thing. We need to find number of elements which are neither multiples of 7 nor multiples of 3. Correct? This is what we need to find. Will we be able to do this? Easily. Why? Because total we know, right? Total 4-digit numbers. How many total 4-digit numbers? Total 4-digit numbers. What will be the total of 4-digit numbers? Can we easily find that? Total of 4-digit numbers we can easily find. How? For first place, how many options do we have? 9 options we have. For second place 10, for this one 10, for this one 10. For first place we cannot keep 0 because we need to make 4-digit. Repetition is allowed, so 9 into 10 into 10 into 10, that means 9,000. 9000 total will be there, minus number n A union B. This also had the formula, right? This means n A, number of elements in A, that means multiples of 7, plus number of elements in B, that means multiples of 3, minus number of elements in A intersection B, that means multiples of 7 and 3 both. What does it mean? That means we just need to do 9000 minus multiples of 3, multiples of 7, and these should be all 4 digit. 4 digit means it should start by after 1000, right? After 1000. So 1001, 1002, you have to see the first multiple of 7, and you have to go till 9999 till there, right? Between 1001 to 9999, look at the first multiple of 7 and the last multiple of 7. D will become 7, A will be first multiple of 7. I think 1001 itself is a first multiple of 7, right? Let's check. Let me divide. Yeah, 1001 itself will come out to be the first multiple of 7, and 9996 must be last. Not sure, but check. You know how to do this. You know how to find all the multiples of 7. How many multiples will come? That you know. All multiples of 7 plus all multiples of 3 minus multiples of 7 and 3 both. That means multiples of 21. That's what you need to do. That's it. And you can easily get this answer. Edits will do this. Dictionary problem will do. It will come after a while. Don't worry about it. It will come in a while. Dictionary problems also will include. Wait, have patience. Okay, 9000 multiples of 7, multiples of plus multiples of 3 minus multiples of 21. We have to subtract all of this from 9000. Answer should be 5143. Just check once. You know? Just verify once. This is what you have to do. You have to use AP over here. Nothing much. AP only. AP concept. Multiples of 21, you have to subtract between 1001 to 9999, and multiples of 3 between 1001 to 9999, and multiples of 7. You can do this. Okay. You can do this easily. Verify your answer with this one. Some questions I have also included just for you to practice or homework. We cannot solve all the questions in the one shot video. We can take the variety. That's what we can do. Let's see 2 results which are very helpful in counting. What 2 results are helpful in counting? Very good. Number of ways of arranging R distinct objects at R places. This we learned, right? If we have R objects and R places. R objects and R places. So R factorial ways. 7 things in 7 different places. So 7 factorial ways. How can we find multiples of 7? Why? Start with 1001, no? Multiples of 7, Vijay. Multiples of 7. First multiple will be 1001, which will be last multiple. I think, yeah, last will be 9996, right? 9996. You have to find number of multiples, right? You have to do it till number of multiples. But it will take a bit more calculation. It will waste our time. I'll tell you how to find for 7. Right? First multiple is 1001 itself. Divide 1000 by 1 by 7, it will get divided. Next multiple will be 1008. After that will be plus 7, right? Every multiple. So A will become 1001. D, that means difference. Common difference will become 7. Common difference will be 7. Right? What do you need to find? You need to find how many total multiples are there. Last multiple is this one. This is the last multiple. So what you need to do, 9996 is equal to 1001 plus n minus 1 into 7. And you have to solve for n. Whatever is n, that will give you the number of multiples of 7 between 1001 to 9999. This is the last multiple, this is the first multiple. So total number of multiples you will get. You can easily solve this. I will tell you how many multiples are coming. You totally get 1286 multiples. This will come out to be 1286, the value of n. Similarly, you can do with 3. Is there any rule for multiple of 7? Viji, multiple of 7. Suppose you are finding multiple of 7 between 1 to 100. Okay. 7 is the first multiple, 14 is the second, third is 21, fourth is 28. Last is which number before 100 gets divisible by 7? Huh? 100? 99? Got it? Right? That's what we are doing. A means first term, D means common difference. Okay? Chill, relax, no problem. These things, you know, these things happen with students. A good student is that who doesn't hide their doubt or try to do it on your own. Try to do it. I cannot solve all of them completely. I'll give you hints for the approaches. Best I can do is that only. Number of ways for selecting R objects out of, and this is important. This is something new. Selecting number of ways for select. For example, what we were doing. Suppose we have to do. We have P1, P2, or P1, P2, P3, P4, P5. We have 5 people or 5 pens. Let's not select people. Sounds very creepy. But select pens. We have 5 pens. Now in these 5 pens I have to choose 2. I have to choose 2 pens. These two, these two, these two, these two, these two, these two. Like there can be so many choices, right? There can be a lot of choices. How will these choices will be made? How many choices will be made? 5. That means from 5 C2. From 5 things I am selecting 2 things. So total number of my selections will be 5 C2. That means 5 factorial divided by 5 minus 2 3 factorial into 2 factorial. You know this, right? NCR. NCR is nothing but n factorial upon n minus r factorial into r factorial. This is your NCR. Okay. So if you have to choose 2 pens out of 5, the total ways will be 5 factorial upon 3 factorial into 2 factorial. That means 10 only, right? 10. There will be total 10 ways and you can actually count. P1, P2, P1, P3, P1, P4, P1, P5. You can actually count. Check this. P1, P2. If you pick P1, same choices won't be counted. Same choices won't be counted. P1, P2, P1, P3, P1, P4 and P1, P5. These are 4 choices. Now P2, P1 not counted. P2, P3 counted. P2, P3 we didn't mention. P2, P4 counted. And P2, P5 also counted. P3, P1 not counted. It's already there. P3, P2. P3, P2 counted. Not counted. P3, P4 counted. Yes, P3, P4 we can count. And P3, P5 we can count. Yes, P3, P5 we can also count. P3, P5 is not mentioned yet. Now with P4, P4, P1 already included. P4, P2 already included. P4, P3 already included. P4, P5 one more choice. Okay. And you can see with P5 we have already counted everything. P5, P5 is not a selection. We have to choose 2 different things. Right. So 4 plus 6, 10. And yes, same answer comes. We can actually see this scenario. 10 choices are going to be there. Okay. Now the actual chapter, like the questions, or if more a variety or more amount of questions come from these sections actually. Selection process. How do you select? What happened? Sorry, just a minute. Edits, thank you, same to you, thank you and God bless you. Yeah, I was saying selection we are going to learn now. The main 3 things: selection and arrangement, and then distribution. Distribution means distributing things among some people. Selection means among some things we have how many ways to select these many things, that many things, those type of questions. Selection and arrangement, that means first select and now arrange them. Arrangement we have already understood, n factorial, right? We'll be able to get hold of all these with the variety of questions. See, it's not a topic, basically it's just the variety. In PNC, in the entire chapter, it's just the variety. Sometimes they ask you the questions from the very basics, just fundamental principles. Sometimes they want you to actually use NCR, NPR or those things, right? They want you to use formula to get easy answers or get faster answers, that's it. First thing, selection. NCR problems, okay. Committee of 6. Now we won't, although we can do these by fundamental principle of counting, we can actually imagine and count, okay, this can happen, that can happen, but we cannot waste that much of time. So now we'll use NCR to select R things from n given things, to make R selections from n given things. Oh, sorry, I repeat my sentence. To select R things from n given things, or to select R objects from n different objects, what do we have to do? NCR. What we have to do is NCR. What are we supposed to do is NCR. A committee of 6 is to be formed out of 8 men and 5 women. In how many ways can this be done? Okay, there are 8 men. Number of men are 8. Number of women are 5. 8 men and 5 women. Now what are we supposed to do? In how many ways can this be done when 2 men and 4 women are included? Okay, 2 men and 4 women are included. How many men we have? 8. Out of 8 we have to choose 2 men. 8C2. Once we have chosen men, it's not that we are going to stop. It's not that either choose men or choose women. You have to do simultaneously. You have to do both the things simultaneously. You're choosing men first, and in the same job, in the same task, in the same scenario, you are doing the other task as well. You are doing 2 tasks simultaneously. Understand this. 8C2. By 8C2, what you are doing? Out of 8 men, you are selecting 2 men. Number of ways to select 2 men out of 8. 8C2. Now, once this is done, you are doing next thing continuously only. It's not a choice, either men or women. No, both things. You have to make a group, committee you are forming. So you chose 8 men, you chose 2 men out of 8. Now same task, in the same scenario you are doing 4 women. So out of 5 you are selecting 4 women. Both things you are doing simultaneously. So multiplication. Understand this. This will be 8C2 means, calculate this please, don't make me calculate. 8C2 means 8C2 8 6 8 7 divided by 2, I think 48 28. This will be 28, and 5C4 is 5C1 only, so 28 into 5, correct? 28 into 5, 140, right? 140 will be your number of ways in which you can form a committee which has 2 men and 4 women. Now these 2 men can be anyone. All men are distinct, all are different. It's not like all are same. These are all different men. Out of those 8 different men, you have chosen any 2. Understand this also, any 2. Okay, 8C2 into 5C4. A committee of 6 is to be formed out of 8 men and 5 women. In how many ways can this be done when at least 3 women are included? At least 3 women are included. Okay, so what, at least 3, whenever this comes, no, at least 3 women are included, because totally we have 5 women. Suppose 4, we cannot use complement here. It's not like subtract the case when no woman is included, because they have specifically mentioned at least 3 women are included. So if at least 3 women are included, in such a scenario, what we need to do is, we'll make case either 3 women, 4 women, 5 women, correct? At least 3 are included. We have to make a committee of 6. So if 3 women are included, we'll include 3 women out of 5 women, 5C3, and remaining 3 we have included, 3 women are included. So remaining 3 will be men. So we'll have to do 8C3. Remaining 3 will be men. Either this we can do, either we can complete our task like this if we are including 3 women, because at least 3 has to be there, or we can complete our task with this way, where we are choosing 4 women. Out of 5 women, we are choosing 4 women. Correct? Out of 5 women, we are choosing 4 women. And remaining 3 should be, remaining 2 should be men. So 8C2. Here, out of 5, one way only to select all the 5 women. There can be only one way, right? To select all the 5 women. Can there be another way? No, right? All the 5 women, one way only, and remaining, all the 5 women we have selected. Now one person only is remaining to in the committee. 6-person committee we need to make. So remaining will be 8C1, or we can directly just write 8 only. 8C1 is 8 only. So 8 plus this, how much is, we have to add, because the task can be completed either this way, that way, or that way. 3 different ways. Either we can do this to complete this task, or this, or this. That's what we need to understand. Yes, Vijay, very good, correct only. I think 708, yeah, very good, amazing, good calculation. Right, if you're not afraid of calculation, these chapters, binomial, PNC and all, are not going to bother you at all. Very good, good going. So Amir, good. A committee of 6 is to be formed out of 8 men and 5 women. In how many ways can this be done? At most 3 women. Now the cases are, at most means either 0 women, 1 woman, 2 women, or 3 women. That's it. 4 cases will be formed. Nothing else. Right? There will be 4 cases. 0 women, that means no women is included. All 6 are men only. 1 woman, that means 5C1. 1 women we have to select, and remaining 8C5 we have to select men. 2 women means 5C2 we have to do, and remaining 8C4 we have to do. 3 women means 5C3 we have to do, and remaining 8C3 we have to do. And we have to add, because these are the possible ways to complete the task. We are adding. Correct? There will be 4 ways: 8C0, 8C6. 8C0 we didn't include because it is going to be 1 only. I didn't write 8C0, right? It's going to be 1. So all 6 are men only. 8C5, 5C1, 8C4, 5C2. Like this. We add all of them, and let's check the answer. We get 1568. Okay, 4 couples. Next question. Have a look. I'll just be back. A minute's break. You can also have water if you want to. One 1568, Vijay. Somewhere, any answer? Okay, great. 4 couples, husband and wife. Wow, lovely question, I think. Romantic question. Decide to form a committee of 4 members. Find the number of different committees that can be formed in which no couple finds a place. Okay, no couple finds a place means, suppose if there are suppose if there are 4 husbands, husband 1, husband 2, husband 3, husband 4, and 4 wives. Husband 1 has wife 1, husband 2 has wife 2, husband 3 has wife 3, husband 4 has wife 4. So they are saying in a way in which no couple finds a place. The committee which you are making is, and committee 4 couples decide to form a committee of 4 members. So we need 2 husbands, 2 wives. Correct? That's what the question. Everybody understood the question? Understood the question or not? We need 2 husbands, 2 wives. That's what we need. So if we choose and no husband find, no couple finds a place. So one method is that we choose all the 4 husbands. One method is that, or we choose all the 4 wives. In that case also we are not choosing any, we are not making any couple, right? No couple is finding a place. Either we can, if we choose all the 4 husbands or we choose all the 4 wives. In these 2 cases we are not making any couple, or there is no couple which is finding a place. The requirement of the question we are fulfilling. So 2 ways, 1 plus 1, that in this one we chose all the 4 husbands, only one way to choose all the 4 husbands. All 4 come, selecting all the 4 husbands, all 4 you can come, one way only. All 4 wives, also one way, only one way we can select all the 4 wives, all 4 are coming. What else can be the scenario? Either we choose 3 husbands and 1 wife. 3, if we need 3 men and 1 woman, if we need 3 men and 1 woman. So understand over here, if we need 3 men and 1 woman, 3 men means out of 4 we'll choose 3 husbands. We'll choose 3 husbands and 1 wife, but that 1 wife cannot be of the 3 husbands, of those 3 husbands. So we have to select 1 wife remaining, the remaining wife. That means when we are selecting 3 husbands, we are also rejecting 3 wives. Getting my point? If we are very good, Vijay. If we are selecting 3 husbands, we are also rejecting 3 wives. So we are selecting 1 wife, 1C1. Basically, 1C1 we are doing. Correct? This is also one method. Okay, this we have excluded. Now what else? 2 husbands, 2 wives. So 4C2, to select 2 husbands. Now 2 wives. That means from remaining 2. I cannot do 4C2 over here. Otherwise, I'll also be I might also select the wife of the respective husbands. Right? I have to select from the remaining 2. So 4C2 when I have done, then I have to do 2C2, remaining 2 wives. Remaining 2 wives. When I am selecting 4C2, I am also rejecting the 2 wives of the husbands. I am also rejecting 2 wives. Very good, Vijay. I think it's correct. Let's just see. I don't remember. What can be the other scenario? 2 men, 2 wives. 1 man, 3 wives. That can also be there. 1 man, 3 wives. That means from 4 husbands, I can choose 1 husband. And that husband's wife, I don't have to choose. I cannot choose. So into 3C3 or 3C2? 3C3, right? From 3C3, remaining 3 I can choose. 3C3. I'm just writing 3C3. Although you can directly write the number, but to get the feeling, you need to write like this. Correct? Can there be any other scenario? No. 3 husbands, 1 wife. 2 husbands, 2 wives. 1 husband, 3 wives. Committee of 4. And these 2 methods, that means plus 2. These 2, in which all 4 husbands, all 4 wives. These can be the possible scenarios. Either I can make the selection like this, like this, like this, or like this. 4 different ways. What is this? 4C3. That means 4 only, 4. So this will become 4. Plus 4C2 plus 4C2, 6. 4C2 plus 2C2. 4 plus 2, 6. Plus 4C1 into 3C3. Again 4. Plus 2. 10, 16. Yes. Correct. Good. Good, Vijay. Correct. Now, 4 couples decide to, same thing, find the number of different committees that can be for, this answer only is given. Answer only is given. Okay. 16 correct. In examination paper, 12 question consists of 2 parts, A and B. Part A contains 7 questions and part B contains 5 questions. A candidate is required to attempt 8 questions, selecting at least 3 from each part. Okay, a examination paper containing 12 questions in part A and part B. Part A is there, part B is there. Part A contains 7 questions. This part has 7 questions and this part has 5 questions. Okay, let's write the piece of information. Okay, a candidate is required to attempt 8 questions, selecting at least 3 from each part. At least 3 from each part. In how many ways can the candidate select the questions? At least 3 from each part. This thing is very good. Either from first part, from part A, if he is doing 3, let's say, from part B, how many he needs to do? 5. Correct? If he is doing 4 from part A, Then 4 from part B also is need to, total should be 8, right? Total should be 8. Sir, the name, sir, the PDF you uploaded on Telegram are fresh ones that are sites before you write. After you wrote, okay, okay, thank you. Remember the name. I'll see that. I'll see that. I must have the saved ones also. I'll replace them. Don't worry. Okay, I'll replace them. 4 and 4, correct. Now, third way which I can do is if I take 5 questions from part A, then from part B, how many can I take? At least 3 I have to choose. No, I cannot take 6 now. This can also be the scenario. From part A, if I take 3, part B will, from part B I'll have to take 5. I can take 4 from both the parts, or I can take 5 from part A and 3 from part B. This can be the possible case. Otherwise, if I take 6 from part A, from part B I have to take 2, but it is written that 3 from each, at least 3 you have to select from each part. So I think only these possibilities are there. Okay, these possibilities are there. This one, 7C3 into 5C, 5C5. Out of 7 I have to choose 3, out of 5 I have to choose 5. Okay, or I can do 7C4 into 5C4, or I can do 7C5 into 5C3. I have to add all of them, because either I can do this or this or this. 3 different scenarios I can complete this task. 420, okay, correct. Yes, that's correct. Very good. Same question, same type of question came in JEE Mains also. Can you do this on your own? Shall I leave it? Or shall we do this? Shall we do this? Okay. 21 into 420. Yeah, okay. Okay, let's see. There are 3 sections in a question paper, and each section contains 5 questions. 3 sections. So this time A, B, C. Each has 5 questions. This has 5 questions. This has 5 questions, and this also has 5 questions. All these 3 have 5 questions each. Okay. Now what is the scenario? Scenario is that a candidate has to answer total of 5 questions. He needs to answer total 5 questions only, choosing at least one from each section. Okay. So again, cases, same thing which we did in last case. At least one, that means you have to make cases now. At least one question from each of the section, then number of ways in which the candidate can choose these questions. Okay, suppose from A, B, C I am writing. Okay, suppose from A he is doing 1, from B he is doing 1. Total he has to do 5. So 3. Now this thing same can happen with B and C. He can do B, from B he can do 1, C he can do 1, and from A he can do 3. Or what he can do is from A he can do 1, C he can do 1, and B he can do 3. But same type of cases will be formed, right? This thing he can do in 3 ways. So basically whatever we are getting the result from here, into 3 we'll have to do. So 5C1 into 5C1 into 5C3 multiplied with 3 will do. This is one case, right? This is just one case. 5C1 into 5C1 into 5C3 into 3. Why am I doing it with 3? Because this can happen in 3 ways. 1, 1, 3 is done. 1, 3, 1 can be done, right? Or 3, 1, 1 can also be done. But same results we'll get. So this same thing will get multiplied with 3. What else can be done? One more thing we can do is at least 1. So 1, 2, 2 also can be done. This also is giving 5. 1, 2, 2 also can be done, right? 1, 2, 2. Any other way? No. If we do 3, if we write 3 somewhere, then 1, 1. 3 we have already included. We cannot write 4. 3 we have already included. Now we cannot take 4 from any one set. Otherwise, at least one condition will not be valid, right? So 1, 2, 2, 1, 2, 2, 2, 2, 1, 2, 1, 1. Same cases, same type of cases. So whatever we are getting from here, we'll multiply it with 3. This can be done in 3 ways. So plus 3 into 5C1 into 5C2 into 5C2. Correct? This will be your answer. Plus we are doing because either we can complete this way or we can complete it this way. This will be your final answer. Check once. This will be 5, 5, 25 into 10, 25, 100 into 3, 75, 750. 215, yeah, 750 will get over here. And what are we getting over here? 5, 10, 10. 100, 500, 1500, correct? 1500. So, yeah, you have the answer. 2250, right? 2250 is your answer. 2250 should be your answer. Great. In how many ways you can select? Okay, this is a different variety. Let's look at this. But yeah, very general variety. You just need to know what to be done in if such a question or if a similar question comes in your examination or in front of you in some book or while solving. In how many ways we can select 3 numbers out of 1, 2, 3 till 100, out of 1 to 100 numbers such that they form an AP. AP if they are forming, think about it. If we need 3 numbers, A, B, C, A minus D, D, A minus D, A plus D, that don't start thinking in that direction. Just think we need 3 numbers, A, B, C, right? We need 3 numbers. Let's say A we need, B we need, we need C. We also know one special thing about AP is that A plus C divided by 2 will give me B, or I can also say A plus C will be equal to 2 times of B. Okay. That means 2 numbers I need who are even, which are even. I need 2 numbers, which are even. I need 2 numbers whose sum is even. I need 2 such numbers whose sum is even. Right? 2B means 2 into something, 2 and something. So even, this thing is even. Now sum of 2 numbers is even when both the numbers are even or both the numbers are odd. Correct or not? Getting my point? Either both the numbers are even or both the numbers are odd. Instead of ABC, I think I should use ABC. So A plus C is equal to 2B. Let's use this only. A plus C is equal to 2B. Sum of 2 numbers is even for me. So these 2 numbers either both can be even or both of them can be odd. 3 plus 1 is also 4. 2 plus 6 is 8. 3 plus 1 is also even. 2 plus 6 is also even. Sum of 2 even numbers is always even. Sum of 2 odd numbers is always odd. So in how many ways can I choose 2 even numbers out of 100? 50 C2. Out of 100 numbers, 1 to 100, 50 numbers will be even. I have to choose 2 even numbers from 50 numbers. Correct or not? Right? Or either I can do this, I can choose any 2 even numbers. Either I can do this, or what I can do? I can do 50 C2 only. I can choose remaining 50 will be odd. From those 2 I can choose 2 odd numbers. Very good, Vijay. Right? So this same, not multiply, addition. Either I can do this or I can do that. I cannot do both of them. Chose 2 even and chose 2 odd. If you will multiply, that means you chose 2 even and 2 odd. That we don't need to do. Correct? What do we need to do? Either choose 2 even or choose 2 odd from 50. From 50 even, choose 2 even numbers. From 50 odd, choose 2 odd numbers. If we multiply, will be wrong. So it will be 2 into 50 C2. 50 into 48. 2. Yeah, calculate this. I think, yeah, good. 2450. Good. Very good. In how many ways? Next question. This has some particular, this particular variety has some subsets or some subtypes. It's very important to understand these also. 1, 2, 2, 5. No funny devil. It should be 2450. 2450 plus 2450. No. 2450 itself 50 C2. My God. Let's calculate. 50 C2. 50 factorial in 50 into 48. Right? 50 into 49 into 48 factorial. 48 factorial will be downwards also. So only 2 here. What is 25 into 49? 1225. 1225, right? This is 1225, and this multiplied will 2 will be 2450. Correct? Total 2450. 50 street 2 is 1225. Yes, funny devil, you are correct there. You were correct there. You were correct. but we have to multiply it with 2. Okay, next thing. If 3 particular, okay, in how many ways, the question, what the question says, in how many ways can a basketball team of 12 players be selected out of 18 players? Great. 12 players be selected out of 18 players, but there are conditions applied. The conditions, one by one, we'll study all the conditions. Same scenario can be there in some other question with some different, conditions or different scenario. Same type can be there. If 3 particular players are always to be included. Okay, just think of it like this. Think of like a selection coach, right? Think of yourself like a selection coach or selector. You have 12 players. Oh, sorry, you have 18 players. You have 18 players. And you have to make a team. You have to make a team of 12 players. So, generally, if there is no condition, what will you do? Out of 18, you will select 12. 18C12 you will do. Correct? Right? 18C12 you will do if there is no condition. But if there is a condition, suppose you are a biased, suppose you are a biased selector or a selector who takes bribe or favoritism or who prefers favoritism, then this can be the condition that 3 particular players are always to be included. Suppose Ina Mina Dika or somebody, some 3, your favorite ones are always to be included. Very good, Aviji. I think that's correct. Very good. Correct. So, out of 18 players, 3 already are there. 3 already are selected. These 3 are my favorite. These will come. Now, what is remaining to do? Now, you have to select out of 15. 3 you have already selected. Out of these 18, 3 you have already selected. These are there in my team. Now, what is remaining to do? Remaining is that you have to select 9 more. A team of 12 you have to make, right? So, you have to select 9 more from 15 remaining. Correct? Right? From 15 of the remaining ones, you have to select 9 more. Because 3 you have already selected. You already know these 3 are already there. Suppose very good players, not a biased selector. Suppose you already know that these 3 should be there. These are going to make us win. So, these 3 should be there definitely. Now, what the remaining task is, you have to select 9 out of the remaining 15 players. That's it. 15C9 should be the answer. Very easy to understand. Next thing, 15C9 is 5005. Okay. Next thing, in how many ways? If 2 players are to be excluded, that means 2 are to be excluded. I don't need these 2. Again, you are doing kind of a same thing. I don't need these 2 players. So, 2 players you have already set up your mind that these perform very well. So, these 2 perform very well. Last time also they got us lose the match. They don't practice very well. So, you have made up your mind, I don't need these 2. Same thing. So, what are you going to do? You are going to select from 16 only. Right? You know that you don't need these 2. So, you are going to select from remaining 16. How many you need to select? You need 12. You need 12. You will be selecting from remaining 16 because you don't need these 2. From you have 18 players, but you know that 2 of them you don't need. So, you'll already keep them aside and you'll do your selection from 16 remaining ones. So, 16C, how many? 12 players you need. That many ways you can form a team from the 16 players. 2 are already excluded. Okay. Okay. Correct. Now, what will be the answer for this one? Third one you can answer on your own, I think. If 3 players are to be included and 2 players are to be excluded. 3 players you are already including and 2 players you are already excluding. Come on, tell me. So, basically you need 9 players out of remaining 13 ones. 3 are already included, you got 3, and 2 you have already rejected. So, out of 18, 5 selections you have already done. 2 I don't need, 3 of you I need, right. So, remaining from 18 minus 5, so 13. So, you will be selecting remaining 9. 3 you have already included. So, out of 12, 3 you have included, right, and 2 you have already decided that I don't need these 2. So, that you are excluding. So, remaining from 13 you will be selecting 9. Okay. Any problem in understanding this? 13C9, understood, right? 13 means 3 you have kept, and 2 you have rejected. So 5 selections you have already done. So remaining 17C 13. No, Vijayashree, why? Why do you think so? 17C 13? Right? 13, no. 3 you have already kept. That these 3 I want. Okay. So remaining how much? Out of 18, 3 you want. 15. Right? 15. Now from 15 also 2 you don't want. So 13 are remaining. Right? Out of these 13, how many do you need to select? Now you have to select 9 only because 3 you have selected. Right? So 9 only you need to select. So 13C, 9. If 2 particular players cannot come in the team, so total ways minus the case where 2 particular players are always in the team. That's the only way. Right? Any other way you can suggest? I think that should be the way. If 2 players cannot come together in the team, so total number of ways, that means 18C 12. Total number of ways will be 18C 12 only, right? Total number of ways of this selection 18C 12 minus the cases when 2 players are always together. That means we are doing our selection 16C 10. 2 players are always together. So 16C 10. This means 2 are always together. 16C 10 means 2 are always together. 2 we have already chosen. Correct? So 18C 12 minus 16C 10, you can calculate 10556 will be your answer. Same, with the same approach or same method, you can do this question as well. We have B1 to B10, B1, B2, we have B1, B2, B3, B4 till B10, 10 boys, and we have girls, G1, G2, G3 till G5, we have 5 girls. Okay. Then the number of boys forming a group consisting of 3 boys and 3 girls if both B1, B2 should be together. The number of groups is, what will be the number of groups in that case? Both B1, B2 should be together. That means we need 3 boys. Out of 10 boys, we need 3 boys. Right? And 3 girls. So first let's choose girls because restriction is on boys. So what will we do? Out of 5 girls, we'll choose, what we'll do, we'll choose 3 girls. Correct? Out of 5 girls, we'll choose 3 girls because we need 3 boys and 3 girls. And now, now 2 boys are already selected. So what am I supposed to do? Give it a try for a minute. Give me the answer in the chat box. You can do this on your own, otherwise you won't remember this. I'll just drink water. Okay. 5C3 are the number of ways in which we can choose girls, right? From 5 girls, we have to choose 3 girls. Now, second thing is if both B1 and B2 together should not be the member of the group. So, complement you have to create, right? Complement you need to create. How can you create the complement? That subtract the cases in which B1, B2 are always together, right? Subtract the cases in which B1, B2 are always together. Total cases of selecting the boys will be 10C3 minus 8C1 because 2 you have already 8C1, right? Because 2 if you are always keeping together, then you are doing your selection from the 8 ones. from the remaining 8 ones, right? So, and you have to just choose one because 2 are chosen. In this way, you are keeping B1 and B2 always together, some specific 2 always together. So, I think we can solve this, right? 10C3 minus 8C1. Calculate this, check the answer. Answer should be 1120. Tell me in the comments if there is some mistake, let me know. Next, move to next particular scenario. Selection, very important scenario. Total number of selection out of n objects. 1120, Vijay, are you sure? 1120 is the answer, correct. 5C3 into 10C3 minus 8C1. I hope understood, right? 5C3 is for selecting the girls and 10C3 minus 8C1, we are selecting the boys in which B1, B2 are together is not a case. Total cases minus the cases when B1, B2 are together. Okay. Total number of selections out of n distinct objects is 2 to the power n. What does this mean? Basically what we learned in the starting. Okay, suppose I have 4 boys, B1, B2, B3, B4. Now you have to select 4. Now you have to make selections. How many selections can you make? If you have 4 boys, how many selections can you make? What will you do? You will go to boy 1. You will say either I will select you or I will reject you. Correct? Same thing will happen with boy 2. Select you or reject you. Select you or reject you. Select you or reject you. Very mean. Sounds very mean, but this is the case. Okay. This is just an example. Okay. 2 to the power n. That means 2, 2, 2, 2. 4 objects. We have to do selection. Either we'll select or we'll reject. Either we'll select or we'll reject. Either we'll select or we'll reject. So 2 to the power 4. Because for every boy we have 2 choices, 2 options, and that we are repeating 4 times. So 2 to the power 4. That means total 16 selections we are going to have over here. Nothing to worry about. And you can also think like this, NC0. That means from n objects you are not selecting anything, NC0. Either you are selecting 1 object or you are selecting 2 objects, 3 objects, 4 objects. And if you have studied, if you attended the last class of binomial theorem, you will also understand that this is also correct. NC0 means from n objects you are selecting nothing. From n objects you are selecting 1. For n objects you are selecting 2 and you are adding all the possible scenarios. So, all the possible cases you are adding. So, total sum you will get is 2 to the power of n. Correct. Every element can be dealt into another way of thinking which we just talked about. Every element can be dealt in 2 ways. Either it will be selected or not. So, options are 2 and we are repeating that same action n times. So, 2 to the power of n. Okay, great. Very basic examples. Very basic, but yeah, can be directly applied. 5 distinct apples and 6 distinct oranges. In how many ways fruits can be selected? In how many ways fruits can be selected? Come on. Simple. 5 distinct apples, apple 1, apple 2, apple 3, apple 4 or apple 5, or 6 distinct oranges, orange 1, orange 2, orange 3, 4, orange 5, orange 6. In how many ways the fruits can be selected? Not total. Orange and fruits are different things, right? This selection you can do in how many ways? 2 to the power 5. This selection you can do in how many ways? 2 to the power 6. What are you doing? You should add this or multiply this. Tell me that. Tell me that. You have to multiply because you are doing continuously. You are selecting from 5 distinct apples and 6 distinct oranges. You are making the selections. So, number of ways to select apples, number of ways to select oranges, and I am continuously doing this. It is not either I have to select apples or I have to select orange. I have to make selections. So, this will be multiplied. 2 to the power 5 into 2 to the power 6, that means 2 to the power of 11. 1024 into 2, 2048. at least one fruit can be selected. At least one fruit you have to select. Some, no, not some, Vijay. Why some? If you are doing some, that means either you are selecting apples or you are selecting oranges, right? Either you are doing this task or this task. We have to make selection. It's right. It's written in how many ways fruits can be selected. Total selections. So select apples, then select oranges. Number of ways to select apples, number of ways to select oranges. Multiply. Continuous task. Correct? No? Okay. Next thing. At least one fruit can be selected. At least one fruit can be selected means total cases. When we are total cases came out to be just now came no 2048. 2048 total cases, total selection. Only in one way we cannot select. There can be only one way in which we are not selecting any fruit. We did not select any fruit. In all the other cases, we will be selecting at least one fruit. One apple, two oranges, one apple, one orange, something we will be selecting. So 2 to the power of 2 to the power 5 minus 1 nahi, 2 to the power 11 minus 1, 2048. Total cases are, total selections are 2048. Vijay, are you guys able to understand this, right? 2048 is total possible cases minus 1. That means we can do 2047. In 2047 ways, we will be at least selecting one fruit, because there can be only one possible way where we are not selecting any of the fruit. So we subtracted that case, right? This can be this. I think this can be the best approach. Otherwise, I don't think other approaches will help here. There, selection can be made in such a way that at least one orange is selected. At least one orange is selected. Now what should I do? First I'll select apples, because I'm not bothered about, I don't have to think about oranges. First I'll look at apples. To select apples, number of ways are 2 to the power of 5, 32 ways. Now orange, in orange I have to select at least, in 2 to the power 5, I am also including the case where I am not selecting any apple. All apples are rejected. Correct? You understand? I am including that. Very good, Vijayshri. Total minus 1. Total ways of selecting apple oranges will be 2 to the power of 6. Minus that one case where I am not selecting any of the oranges. Because 2 to the power 6 includes that case also where I am not selecting any of the oranges. Correct? Right? So 2 to the power 5 into 2 to the power 6 minus 1. 32 into 63. 32 into 63. Right? 2016. Great. Now, same questions, application in such questions, and this is what can be asked in your JEE exam. This is similar to the PYQs only, some different varieties. First case, where there is set A and A set is of 1, 2, 3, 4, there are 4 elements. Find the number of subsets. If there are n elements in a set, then number of subsets will be equal to 2 to the power n. That means 2 to the power 4. This we can also understand with the approach we just learned, or this is generally we know number of subsets which can be formed by from a set which is having n elements will be equal to 2 to the power n. Number of subsets, 5 will be a subset, right? 1 will be a subset, 2 will be a subset, 3 will be a subset, 4 will be a subset, 1, 2, 3, 3, 4, right? Then 1, 2, 3, 2, 3, 4, 4, there will be total 16 subsets, 2 to the power 4. Number of elements in the sets, right? 2 to the power of that number. Next thing, in how many ordered pairs P and Q can be made where PQ are subsets of A and P and Q is a null set? That means there is nothing common in P and Q, right? There is nothing common in P and Q. So basically you need to make PQ. You need pair, ordered pair PQ. So you will take one you will either send in P or you will send in P and not in Q, because you cannot send in both, because you don't want P intersection Q is null, right? P intersection Q is null. Or you will send here, you will not send here, right? Or you will not send at both the places. Correct? This is the way. So one you will pick here, not here, here, not here. So basically you have 3 choices. and you have to make these 3 choices with 4 numbers. What will be your answer? 3 to the power of 4. Either you will send in P, you will send in Q, or you will not send in both of them. So 3 choices, 4 options. 3 to the power of 4. Get my point? Next, how many ordered pairs P and Q can be made? Same thing which we learned just now, we are doing the same thing. How many ordered pairs P and Q can be made where P and Q are subsets of A and P and Q contain exactly one element? Exactly one element. So that one P and Q, P intersection Q contains exactly one element. That means P intersection Q, that means in P and Q, in P intersection Q, you have exactly one element. Only one thing is common, only one element is common. Now that one common element, first select that common element. From 4 elements, one common element you need, right? One common element you need, that means you will do 4C1. Now what will you do? Now one you have selected, that will be common in P and Q both. Only one common element, exactly one common element is written. So that exactly one common element you can choose. How many ways you can choose that? 4C1 ways. 4 ways to choose that common element. Now for the remaining 3 elements, you will apply the same thing. For the remaining 3 elements, you have to do the same thing which we did in last question. You have to distribute it among P and Q. Remaining 3 you are distributing among P and Q. Now same base, either P, Q or not in P and Q. So 3 to the power of 3. 3 choices, 3 actions. So total will be 4 into 27. Correct? Same question, do it on your own. Same type of question, you can do it on your own. 3 sets, so what? 3 sets, so what? 3 choices. Total choices will become, how many total choices we will have? Number of subsets you can easily answer. Second one, P into Q into R. So there will be 7 choices now, right? Sending in first one, not in these 2. Sending in second one, not in these 2. Sending in third one, not in these 2. This, not in this. This, not, this, not in this one. Like this 7 choices will become. Correct? Try this one on your own. Next thing, yeah, this is also very important. Another type of selection. 3 to the power 3, 108, which one, Vijay? Okay. Now, suppose we have number of ways of selecting 2 A's out of A. These are just observations. These observations will help us in solving the further questions, maybe because of that. Previous one, 108, where, yeah, 16807. Solve it, but don't go on these solutions. Answers you can match. Don't use these solutions. Just match the answers. You'll get the answers. The same question, but think. See, not all questions I can solve, right? And if we keep solving every question, it will take a lot of time. Right? I also have to save energy. So please solve. Recommended that some questions I'll tell you, these specific ones which are same, try solving them on your own. Same approach. This will also give you practice. I'll upload this PPT. Now, number of ways of selecting 2 A's out of 4 A's. What are you saying? Number of ways of selecting 2 A's out of 4 A's. So basically, whatever we choose these 2 A's, these 2 A's, these 2 A's, all are looking same only, no? So there is one, very good, Vijay. One way only. There cannot be any other way. There is only one way. If I say choose 3 A's out of the 4 A's, one way only. Whichever you choose, same, it will look same. Correct? If you choose 4 A's out of 4 A's, same thing. One way only. Here there is a different scenario. Selecting 3 letters out of these. Now 3 letters, you have to choose 3 letters. Either all 3 can be same. What can be the possible scenarios? All 3 same. Now we'll have cases, because we have 3 A's, 2 B's and 3 C's, and we have to select 3 letters out of these. So either all 3 will be same. This can be the case. One same, 2 different. This can also be the case. 2 same, 1 different. Yes or no? Getting my point? If this is the scenario, we'll have to make cases. We'll have to make cases, right? Where the cases can be all three are same, one same and two different, two same and one different, or all three different. That can also be case. All different. All different. This can also be the case. Correct? So here 4 cases are being formed. Maybe in some question we have to make more cases, but we have to, if we have to select in this scenario where there are same letters or same objects in our string or in our given set, then in that case we'll have to make cases, and we are selecting some specific or few ones only. Suppose for example over here we are selecting 3 letters, so we are making cases. We have to select 3 letters, but for these 3 letters there can be different conditions. Either there can be all 3 same, either there can be 1 same and 2 others are different, either there can be 2 same and 1 is different, 2 same and 1 is different, 1 same and 2 is 2 different is different thing. A, B, C, right? A, C, this is different. All different, A, B, C. Sorry, 1 same, 2 different means, oh, wait, this cannot be the case. Sorry, this I have written. 1 same, 2 different would mean the same thing, no? This and this will be the same thing. 1 same, 2 different means all 3 are different, right? My bad. This won't be the case. 2 same, 1 different is the case, and all different is the case. All 3 same and 2 same, 1 different. Now, let's apply this into questions. In how many ways can we select 4 letters out of the word examination? So here this concept is going to be applied. Let's apply it. How will you apply it? Over here. How many E's we have? E we have 1. It's written. X we have 1. A we have 2. M we have 1, I we have 2, N also we have is 2, and T we have is 1, O we have is 1. So basically these are packets. We'll make packets. Multiple letters are these ones. Okay, these are packets. We'll just need this information. It was written like this. Instead of that I just wrote it like this. Now we have to choose 4 letters. 4 letters. We have to choose 4 letters. Okay, now for these 4 letters, how many ways to choose 4 letters? For these 4 letters, what can be the conditions? While selecting these 4 letters, what can be the conditions? That we need to analyze. Either all 4 can be different, first condition. All different, all 4 different. Right? 1 different, 3 same. Or first, suppose these two are same and these 2 are same. So 2 same I am writing. 2 same, 2 same. This can also be the condition. These 2 same, these 2 are same. These 2 are alike or these 2 are alike. We can also call them alike. These 2 are alike and these 2 are alike, or these 2 are same and these 2 are same. But these 2 are different same, these 2 are different same. Suppose these 2 are AA, suppose these 2 are AA, then these 2 are II. But these 2 are same among each other, these with respect to each other, and these 2 are same with respect to each other. Correct? What else can be the scenario? 2 same and 2 different. Suppose 2 are same and remaining 2 are different. This can also be the scenario. Any other? 1 same, 3 different. 1 same, 3 different, don't write. 1 same, 3 different would mean all 4 are different, right? All 4 same, is it possible? All 4 same. All 4 cannot be same. We don't have that set only. Is it possible to have all 4 same? No, we don't have that set. All 4 cannot be same from anywhere. There are no 4 letters which are same. Otherwise, we would have written that case also. Any other case do you think? All 4 different, possible. All 4 can be different. 2 same, 2 same. 2 same of one kind and 2 same of another kind. 2 same, 2 different. 2 are same and 2 other are different. 3 same, 1 different. 3 same, 1 different. Is it possible? No, not possible. We cannot take 3 same. 3 same is not possible only from our given data set. Correct? So only these are possible. All 4 different, all 4 same also we cannot take. So check your data set also while making the cases. Now that's it. This you have to, this you can do very easily. All distinct means out of 8 packets or 8 sets, you have to choose any 4. Out of 8, you have to choose any 4. This one is done then. All 4 different. All 4 will be different. If from these 8 packets you are choosing 4, whatever you are getting on in those 4, all 4 will be different. Second is 2 alike and 2 distinct. 2 alike means from 3 sets, from these 3. Either we can select from this one or this one. So 3C1. 2 alike and 3, sorry, why am I multiplying? Right, this is one case. Let me write over here only, this will be better. This means 8C4. 2 same and 2 the other 2 are same, right? 2 same and other 2 also same. So 3C2, I'll select from these. 2 same means how will I get 2 same? Either I have to select from here or from here. So from these 3 data packets, I'll select any one. So 3C2, any 2 I'll select. From these 3, I'll select any 2. Will my job be done? Will my job be done? Yes. Suppose I chose these 2. These 2, I'll get AA, II. I chose these 2, I'll get II, NN. I chose these 2, AA or NN. From 3, if I choose any 2, I am actually doing the same thing. Try to understand it, okay, with patience. Repeat if you want to, but right now try to understand. 3C2 only we have to do. We don't have to do into 2. Do we need to? No. 3, not 3C1. Not 3C1. For last one you are saying. For last one you are saying, Vijay, 2 same and 2 same. I need 2 same and other 2 same of one kind and other 2 also same of some other kind. So if I choose any 2 from these 3, where can I get 2 same elements from? From where can I get 2 same elements? I can only get from these 3 sets. Nowhere else. Rest all are single ones. So either I'll choose any 2 packets from these 3 packets. I'll get this thing only, 2 same and of one kind and 2 same of another kind. 2 same and 2 different. 2 same and 2 different. How will I do this? 2 same I want. So from these 3, any one I'll select, because I want same. I want same only. I want same. Either I'll select this one, or I'll select this one. I want 2 same. So this will give me 3C1. 2 same will give me 3C1. 2 different, how will I select? From the remaining 7. If 1 selected, these are all 8. So from the remaining 7, select any one. Select any one from the remaining 7. The remaining 2 will be different or not? AY, one set of AIN. AIN means we have to do 4. We have to do 4. Making 4. All 4 different 8C4 we have already included, if you are talking about that. Correct? Okay, I'll take one more question after this. Don't worry. This try to understand very carefully. So 2 same, how will I select 2 same? From these 3, I'll select any one, and remaining from 7, I'll select any 2. Right? From remaining 7, I'll select any 2. So 7C2. Just have to add, either I can complete like this, or like this. 8C4 plus 3C2 plus 3C1 into 7C2. Tell me the answer. 3C1 into 7C2, correct? Very good. 3C1 into 7C2, understood. From remaining 7, you can select any 2. Once you have selected from these 3, you have selected 1. 1 you have selected, remaining will be 7. Now select any 2. If you are selecting 2, suppose this one and this one, you will get 2 different. Suppose this one and this one, you will get 2 different. This one and different also, you will get 2 different. 136 will be your answer. Let's check. Correct. 136 should be your answer. Now do the same thing for Mississippi. Can we do the same thing for Mississippi? Here it's given M is 1 time, I is 4 time. How many we have to select? 4 letters only. S is 4 times and P is 4 times. Just make the cases. Rest you can do, but just make the cases at least. So all 4. You have to select 4. What can be the cases? All 4 are distinct. First case is all different. All different. All distinct or all different or all unlike. Unlike, right? Different or distinct, same thing only. Next, what else can be there? 4 are there. So now you have 4 I's and 4 S also. So you can do more things. 2 alike and 2 distinct. You can say, okay, second case can be, I can have 2 of the same, 2 of them are same and 2 are different. Because from here I can get 2 same, here also I can get 2 same, and here also I can get 2 same. 2 same, 2 different. So how should I write? 2 same, 2 different ones. And if this is the case, then 2 same and 2 same of one kind and 2 same of other kind can also be the case. Yes or no? Right? 2 same of one kind. So 2 same and 2 same. I am writing like this only. 2 same and other 2 are also same. 2 same of one kind and other 2 same of another kind. That also can be a scenario. What has remained? Now I can reach till 4. So fourth scenario I can say, these 3 are same and 1 is different. Right? These 3 are same and 1 is different. So 3 same and 1 different. This can also be the case. All 4 are same can also be the case. Can I say all 4 are same? All same. That can also be the case. One same 3 different is not the case. Okay, don't write 1 same 3 different. 1 same 3 different means all different. Correct? 1 same 3 different would mean all different only. So these 4 cases you have to just identify. All distinct will be, all different will be from 4C 4 only. There can be only one way. 4C 4. Select 4 from 4. There are 4 sets, 4 packets. So from all the 4, 4C 4. Only one way to select all distinct. All different means one way only. 2 alike and 2 distinct. 2 alike. Just a minute. 2 alike and 2 distinct. Think for 2 alike or 2 same and 2 distinct. Then 2 same and 2 same. Do this. These 3. All same. All same means all alike. So 2C 1. All same means 2C 1 because these 2 only. Either this one or this one. From these 2 if you select any one, this will give you all same. What about 3 same and 1 different? 3 same and 1 different. 2C1 into 3C1. 1 different means 2C1. First you will select from these 2 any one, and remaining 3 you can select any 2. 2C1 into 3C2. 2C1 into 3C2 for 3 same and 1 different. Oh sorry, 2C1 into 3C1. 2C1 when you are selecting 3 same will happen and 3C1 also. Right? Like this we will have to do it. Calculate the total scenario. 2 same and 2 different. Write down for 2 same and 2 different. 2 same. Where can you select the 2 same from? Yep. If you want 3 same, here I wrote 3C1 because this also has 2 elements. Because this also has 2 elements. Okay. Complete this. Repeat this on your own once. Answer will be there in the text, it will be 21. Just do all the cases once on your own. Also this one. This is the mains question. Easily you will be able to do this. Same thing, all distinct, 2 same, 3 different, and these different scenarios or different cases you will have to make, in which 4 letters can be chosen, and generally they will ask for 4 or 3 letters only. Okay, they will ask for 4 or 3 letters only, not more than that. Let's do some geometrical counting. Okay, counting is also applied in geometrical problems. Let's see a couple of them so we get a better idea. There are 6 points on a circle. Okay, joining these points, how many lines will be made? There are 6 points on a circle. 1, 2, let's say 3, this is 4, this is 5, this is 6. Any 2 if I join, can I make a line? If I join any of the 2, can I make a line? Will I be making a line? Yes or no? From 6, if I, to make a line, what do I need? I join these 2, these 2, these 2, these 2, or these 2, or these 2, these 2. So many lines. So to make a line, you just need 2 points. So from 6 points, you have the number of ways in which you can select any 2 points from the 6. That will be the number of lines you can make. Nothing typical in that. Next thing, joining these points, how many triangles can be made? On a circle they are on a circle. So none of them are collinear. Why am I saying collinear? Because that will be used in the upcoming questions. So you have to check whether any of the points are collinear or not while making lines and triangles, right? So 6C3, select any 3 points, 6C3. Any 3 points select out of 6, the number of ways to select any 3 points out of the 6 points, that will be the number of triangles will be forming, nothing much, correct? What else? Joining these points, a polygon is made, find the okay, polygon, this is a bit different, not different, not tricky I would say, but different, yeah. Okay, can you tell me the answer for this one? Can you tell me the answer for this one? Six points are there, joining these points, polygon is made. So any 2 points, select any 2 points, right? If you select any 2 points, but while selecting any 2 points, what is happening is you are also selecting this point, these 2 points, these 2 points, these 2 points, and these 2 points, correct? And they are only asking about diagonals. The question is only asking you about diagonals. Find the number of diagonals. So when you are selecting out of 6 points, when you are selecting any 2 points, you are also selecting the sides. That is okay. Out of 6 points, if you select any 2 points, you are selecting the diagonals also. I am not saying you are not selecting the diagonals. You are selecting the diagonals also. These two, these two, these two, these two, like this. You are selecting the diagonals also. But you are in this 6C2, you have also included the, because diagonals are also straight lines, no? You have also included the sides of the polygon. So just subtract 6. How many sides? 6 sides. Correct? In 6C2, you just have to subtract 6, nothing else. 6C2 itself, how much you get? How much do you get for 6C2? 5 into 3, 15. Right? 6C2, 15 minus 6, 9. Right? Equal to 9. Very good. For a diagonal which is, okay, fine. Again, same thing. Straight lines can be, okay, 10 points are in a plane. This is different. This is a bit different. Let's see the approach towards this. There are 10 points in a plane. Out of these points, no 3 are in the same straight line except 4 points which are collinear. Okay, there are 10 points in a plane. 6 are not collinear and 4 are collinear. So 4 collinear first let's make. 1, 2, 3 and 4. These are 4 collinear points. Out of these, and 6 are non-collinear. So let me put them anywhere randomly. Okay, these are non-collinear. Okay, not if, no, I cannot randomly put, otherwise let's put like this. Because there might be a collinearity there also, right? These are non-collinear. These are non-collinear. Now first question says straight lines that can be formed. So basically this is the scenario. 4 of my points are collinear and these are non-collinear. So when I will be making my straight lines, this time here I have to pay attention because this will just give me one line. Correct or not correct? Getting my point? Correct? Right? While making the straight lines, if I join any 2 points out of these 10, 10C2 is okay. 10C2 is okay, not a problem. But these 4 points will also give me lines, na? For example, let's go into this question. Straight lines if I am forming, my 6 points, my total I have 10 points, and from 10 points if I join any, if I select any 2 points, that means if I do 10C2, I'll get all the possible lines. But my scenario was that 4 points were collinear. So when the remaining points, I have to check for these 4 points. Now these 4 points, if I choose any 2 points from these 4 points, they'll also make a line. So when I'm doing 10C2, I'm including these also. This is the same line. This, correct? These will also straight lines, correct? Right? So 10C2 minus 6C, minus 4C2 I have to do. Minus 4C2 I'll have to do. But one thing I'm forgetting, that at least one line will be made. One line will be made. One line we'll have to consider. That one line will add. That's it. That one line will add. 10C2 is 45. Minus 4C2 is 6. Right? 6. Right? 6 plus 1. That means 40. Correct, Vijay. Understood? 10C2 when I'm doing, I'm including all the lines which can be made using any 2 points out of 10. But then I forgot that I have to subtract these, the combinations of these, 4C2, selecting any 2 out of these 4. Why? Because these are making same lines only. These are making same lines only. Right? Like I have already included there. These are collinear points. Okay. Plus 1 I am doing because one line is still there. After on joining these 4, at least one line will be, exactly one line will be there, that I have to include. Hi Anushri. Okay, next thing, there are 10 points in a lane. Achha, triangle we have to make this time, right? Triangles can be formed by using, so now we have to make triangles. Any answers? Hi Anushri. Great, no problem, start learning from where you, wherever it is going on. You can refer to the last few lectures, last few sessions as well. Soon, right? First I'm trying to finish up a few topics of at least 11. Vijay says 10C3. 10C3 is total 120 ways. Correct? No problem. That means 4, but what about 4 collinear points? What about 4 collinear points? By doing 10C3, you are choosing any 3 points out of the 10 points. All the possibilities. But from these, this also includes, does this also include 4C3? This also includes when we are selecting from these collinear points. So what we have to select? 4C3, what do we have to subtract? 4C3 we have to subtract, because this 10C3 is including the triangles formed by using these 4 points. Collinear points cannot form triangles. So we have to subtract that. Do we need to add anything? No, we don't need to add anything, because we are making triangles, not making lines. So that would be our answer. 10C3 minus 4C3. 116. Very good, Vijay. This will be 116. Now, again, quadrilaterals. Can we do about quadrilaterals? Quadrilateral also we can do, right? Collinear points. What we'll do? Total cases will be 10C4 this time. 10C4 this time. Now, what do we have to subtract? The point is, okay, Anushri, you can refer to a few videos. I'll see if in the same comment I can tag some videos. But integration I think will take 2 to 3 more of the sessions. But I'll try to take it up as soon as possible. Okay. Now, what do we pay attention here? What do we have to subtract? What do we need to subtract? What if we select any 3 points from here and 1 point from there? That won't be a quadrilateral, right? This is including all the possibilities. 10C4 is including all the possibilities. We have to subtract some possibilities which will not be making any quadrilaterals. What do we need to subtract? From here we need to subtract. If we take any 3 points from here and 1 point from here, what will it make? It will make a triangle, not a quadrilateral. So we'll subtract 4C3 into 6C1. From these 6 if we select 1, and from these 4 if we select 3, that case we have to subtract. One more case, if we select any 4 from here, that can be also a case, right? All the 4 from here. Yes or no? That can be a case. All the 4 from here, there can be only one way to do that. So this part we have to subtract, that's it, nothing much. So 4C3 into 6C1 will give you 4 into 6, 24, 24 plus 1, 25, 10C4, how much is it coming? 2, 10C4, 10, let me calculate, 2, 1, okay, let's check, 210, right? Yeah, 210 minus 25, that is 185. Alright, check your answers once and check these answers also. Octagonal figure. Can you do this on your own? Okay, I'll give you a hint. Number of triangles whose, this question is of mains, but easily whatever questions we did just now, using the same concept only, you will be easily able to do these questions. 185 for the last one. Yeah, great. Kissinger, very good. Now same concept you are going to use. This is octagon. First of all, it is very difficult to make an octagon. 1, 2, 3. Wait. Something like this. Yeah, very bad, but I'm sorry. Very bad. In this case, what will happen? You'll have 8 points. Number of triangles whose vertices are the vertices of regular octagon, but none of whose sides is a side of the octagon. None of whose sides, none of the triangle side should be a side of the octagon. Give a moment for this question. Give it a chance. Think about it. Total, first of all, write total number of triangles formed. Total number of triangles formed you can easily write, right? 8C3. Now what do you need to subtract? First of all, first thing which you need to subtract is subtract the sides itself, because you don't want any of the sides of the triangles to be a side of octagon. So there will be 8 sides, so there will be definitely 8 triangles which will be having one side as the side of octagon. What else? Number of triangles which will be formed having 2 sides common with the octagon. 2 sides common means, first of all, this one, let's say 2 sides common, okay. We want none of whose sides is a side of the octagon. So in those triangles, what can be the possibility? Either both the sides will be common with the octagon. How can that happen? Suppose this is your triangle. Suppose this is your triangle. Yes, this is a triangle. Both sides are common. How many these kind of triangles will be there? There will be 8 such triangles, right? 8 such triangles. There will be 8 such triangles. Now how many triangles will be there who have one side common? One side common means something like this. So with these 2 points itself, if you join, you can join like this, you can join like this, you can join like, you can join like this. So 4. From any 2 points you can make 4, right? One side common with the octagon. So how many will be total? Total will be 4 into 8 vertices. So minus 8 into 4. This also you'll have to do. Understood? Why minus 8? Because either there will be one side common with the octagon sides, or there can be 2 sides of the triangle common with the sides of the octagon, right? Explain, you know. Either there can be one side common with the side of the octagon, that can be 8 cases, or there can be 2 sides common with the sides of the octagon, that will be 8 into 4, 32 cases. Correct? So just calculate this. That will be your answer. 16 is the correct answer. Now in such scenario where there are points on the triangle itself, you are given with points on the triangle itself. 32 it will be, right? 8 into 4 make the figure, okay. Either one side will be common with the octagon sides, or there can be two sides of the triangle common with the octagon sides. If one side is common, then that can be 8 cases. If two sides are common, then 8 into 4, because every two vertices will make 4, correct? Now, find the number of triangles that can be made joining marked points. Let's understand this very simply. Marked points, okay, instead of this one, let's do this one. Find the number of triangles that can be made joining these marked points. So, let's say on this side, how many points we have? 1, 2, 3, 4, correct? On this side, how many we have? 1, 2, 3. On this side, we have 1, 2, 3, 4, 5. Now, you have to find the number of triangles made by joining these points, right? Total triangles made, how many total triangles we can make? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total 15 points are there. So total triangles, not total triangles, total joints or total combinations we can do of 3 is 15C3. That will give us 15C3. Now out of this, what do we need to subtract? On this side, 1, 2, 3, 4, 5. On this side, 1, 2, 3, 4, 5, 6. Okay. What do we need to subtract? On every side, collinear points, combinations at collinear points, that we have to subtract. On this side, if we see 1, 2, 3, 4, 5, 6. So from this, on this side, we have 6 points. 6 is C3 we have to subtract because these points are collinear. So triangles formed on using these collinear points will not be considered. On this side, 1, 2, 3, 4, 5, 6, 7. So minus 7C3 also. Yes, we are including this point both times. Don't think why are we including? Because this triangle is different, this side triangle is different. Those triangles are going to be different. These side of triangles joining these are going to be different. So include these corner points also. 1, 2, 3, 4, 5, 6, 7. 7C3 we have to subtract, and here 1, 2, 3, 4, 5. 5C3 also will need to subtract. Okay, all this we'll have to subtract. That will be giving our answer. Very good, Vijay. If that's the answer, very good, Vijay. Wow, you're really getting fast at calculation. Same type of question has come in mains. So basically, I'm asking you to solve the mains question, PYQs at least on your own, right? Because similar category or exact similar type we have included. Answer I'm telling you, and you can even check. Okay, I'll tell you the solution. Same thing. Total points are 18. So 18C3 will be total triangles. On this side we have 5 points, 5C3 will be subtracted. Here we have 6 points, so 6C3 will be subtracted. Here we have 7 points, so 7C3 is going to be subtracted. This type of question direct also can come, but there the point is that if you have practiced with this category or this variety of problem, no, a 2-3 type of questions, a similar, small amount of variations can be done. If you have done that in exam, you'll do it in seconds, not seconds actually, like if you take time in calculation, then a minute, otherwise in seconds. I think Vijay can do it in seconds. Right? Easily you can calculate 18C3 minus 5C3 minus 6C3 minus 7C3. So practice this thing also, calculating NCR. Okay. In a plane, there are 6 lines. Okay, this is different question. Okay, this is standard type and this is different also. So I'm writing it. Remember this question. This will help you in other questions also, solving other questions as well. Read the question once. I'll have water. In a plane, there are 6 lines. In a plane, there are 6 lines. No 2 of which are parallel and no 3 are concurrent. What does this mean? Yeah, I'll try to. Roshan, Syed Roshan, first I'm trying to finish up some topics. Okay. In a plane, there are 6 lines, no 2 of which are parallel and no 2 of which are concurrent. Which we first need to understand this thing. No 2 of which are parallel and no 3 are concurrent. Out of 6 lines, no 2 are parallel. No 2, that means if we take any 2, these 2 are not parallel, and no 3 are concurrent. No 3 are intersecting. This just means these lines have one point of intersection. This just means that they have one point of intersection. All these lines have, not all of these, whenever we are taking any, that will give us one point of intersection. Get my point? Okay. This means that whenever two lines are going to intersect, they'll just give one point of intersection. So 2 points when, now what do we need to find out? How many triangles can be made? For triangles, what do we need? We need points. So total points when 6 lines are going to intersect, any 2. From 6, select any 2. If none of them are parallel and none are concurrent, then select any 2. 6C2 if you do, you are basically selecting any 2 lines. That means you are calculating total number of points of intersection. Correct? Total number of points of intersection, every line. Now total points of intersection you have got, that means 15 points you have. Leave points of intersection, you mean 15 points you are having. Now in these 50, you know how to make triangles out of 15 points. Sir, 15C3 we can do. From these 15 points, if we do 15C3, we are making triangles. But here one mistake we are doing is that we are not able to consider collinear points, where the collinear points are going to occur. That case we are not considering. So let's understand this. Now suppose this is one line. Okay, every set of 2 lines is giving us one point of intersection. Every set of 2 lines. Now this, suppose this is some line, and when other lines are intersecting it, they are all giving one point of intersection, right? They are all going to give one point of intersection. I'm sorry for using pink. Let me use this. Suppose this is one line, and whenever other lines are intersecting this, they are all giving one point of intersection. Yes or no? All giving one point of intersection. Yes. So I have to exclude, I have to subtract 5. On one line there will be 5 collinear points. These collinear points I have to subtract. I cannot, I have included these also in 15C3. I have included these also in 15C3. Getting my point? Basically when I am doing 15C3, no, I have included all the points, all the intersection points. But we forget one thing, that when one line is going to be intersected by the others, there will be collinear points on that line, on that particular line. So we have 5 collinear points. So what do we need to subtract? We will subtract 5C3. Why? Because from collinear points the triangles will not be considered. When we are selecting 5C3, that won't be considered. And this thing will happen for all the 6 lines. This thing is going to happen for all the 6 lines. So I'll have to multiply 6. My God. Okay, I'll have to multiply 6 over here. Calculate this. Yeah, 455 was 15C3. So 5C3, 5C2, 10 into 6. 455 minus 60. No. 395, correct? Okay. This is also one variety. We can understand this quickly. Rectangles and square. Look, I'll explain you with the, explain you with the figure only. Rectangles, when we are making, there is no problem at all. There is no boundation, there is no restriction. When we are making rectangles, pay attention over here. When we are making rectangles, we just need to choose any one vertical line, any 2 vertical line and any 2 horizontal lines. Correct? First thing which they are asking us to do is rectangle, forming rectangles. So for forming rectangles, we need any 2 vertical lines, any 2 horizontal lines. We have 5 vertical, 1, 2, 3, 4, 5. Okay, and 6 horizontal, 1, 2, 3, 4, 5, 6. For making a rectangle, there is no problem. Choose any 2 vertical lines, any 2 horizontal lines, you will have a rectangle. Any 2 vertical lines, any 2 horizontal lines, you will have a rectangle. So basically 6C2 into 5C2 will be rectangle. Square, there is a bit of a problem. Not problem I would say, but square you cannot just choose randomly any two. This is for rectangle. This will be total number of rectangles formed. But for squares you cannot do this. For squares what will you need to do? You will have to choose one by one. If you are having one by one square, right, either this one, these two, these two, these two, these two, these two, these two. You'll have to, this gap you'll have to choose, this gap you'll have to choose, this gap you'll have to choose, this one or this one. Think about it. So square rectangle there is no problem, but square there is a foundation, right? You'll have to choose block wise, right? Suppose you are choosing one by one square. So one, these two lines, five ways to choose vertical lines, 1, 2, 3, 4 and 5. 5 ways to choose, horizontal lines, and then 4 ways to choose vertical lines, right? So square, for square I am writing, for square I am writing 5 ways to choose horizontal lines and 4 ways to choose vertical lines. If we are choosing one by one square, one by one square, one by one, one by one. Now if we are choosing 2 by 2 square, this is a formula. If you have done mental ability, counting of figure questions or reasoning counting of figure questions, you'll understand this, right? You'll get this idea. Now if we are choosing 2 by 2 squares, so this one, if we are choosing this, then this. Now we can make, if we are choosing this is 2 by 2, either these two or and these two, or what we can do, 2 by 2, this one and this one, here and here and here and here. So what do we need to do? So this way 2 by 2 can be made from these two, these two, these two and these two, 4 ways. And vertical lines, how many we have? 1, 2, 3, 4, 5, right? We have 5 vertical lines. So what we can do, and we need to make 2 by 2 square. So this one or this one, so into 3, correct? Getting my point? While making square you have to be careful. One by one you have to make cases. 1 by 1 squares you can make, 2 by 2 squares you can make, 3 by 3 squares you can make, 4 by 4 squares you can make, right? Not more than that, right? Because we have 5 vertical lines, correct? Now what else can you do? 3 by 3. So 3 by 3, 1 block, 2 block, 3 block, this one and this one, correct? 3 ways horizontally and 4 ways vertically. 2 ways only vertically. 3 by 3, right? So 1 gap, 2 gap, 3 gap, 1 gap and this gap. This way you can choose and this way you can choose. So 3 into 2. Now you cannot make 4 by 4. Can you make 4 by 4 rectangles? 4 by 4 rectangles also you can make, no problem. Yes, you can make 1, 2, 3, 4 this way or this way, 2 ways horizontally. But vertically we just have 1 way. 1, 2, 3, 4. This is 4 by 4, 4 blocks. So into 1. Now you cannot make. 5 by 5 is not possible now. I'll explain again. While making squares, rectangle you were clear, right? Shubhi? Rectangle was clear? Okay, great. Rectangle, while making rectangle there is no problem. In square you have to make block by block. Either you can make 1 by 1 square. So 1 by 1 square, let me explain here. 1 by 1 square, this one, either you can choose this one, this one and this one, or you can choose this one and this one, this one and this one, this one and this one, correct? So basically horizontally how many ways you have to choose? 1 by 1 square. This particular block you can choose, this you can choose, this you can choose, this you can choose, or this you can choose. How many blocks? 1, 2, 3, 4 and 5. So 5 ways, 5 block you can choose horizontally and 4 you can choose vertically. 1, 2, 3, 4, correct? This is one way of making the square. Other way, next way is you can make 2 by 2 square. This block you can choose, this block you can choose, this block you can choose, or this block you can choose. So how many ways? 4 ways to choose horizontally, and vertically this one or this one. So 3 ways. You can also make 3 by 3 squares. 3 by 3 squares means this one or this one. This one you can choose, this one you can choose, or this one you can choose horizontally. And vertically, this is 3 block, this is 3 block, only 2 ways. Vertically only 3 block, right? So this one and this one. Again, 2 ways 4 by 4, 1, 2, 3, 4. So this particular segment or this particular segment, 2 ways to choose 4 by 4 horizontally, and vertically 1 way only, because 1, 2, 3, 4, 4 blocks only are there, no, only 1 way. This is the case. You can, if this is understood, then quite okay. Otherwise, remember one formula. Suppose you have m and n lines. So start with m minus 1 into n minus 1, then do m minus 2 into n minus 2, m minus 3 into n minus 3 till you get 1. This is a general formula. Add all of them. Add all of them. 20 plus 12 plus 6 plus 2. 40? Yeah, 40 we are getting. Great. Okay, 40. Now, main thing, last part which we are talking about, selection and arrangement. Selection and arrangement. This is quite, we can also say, we'll not say tricky, but this is quite useful, or this is quite applicable in the JEE problems. So listen carefully. How many batting orders? Batting orders means arrangement. As soon as we are talking about order, that means they are talking about arranging things, right? They are talking about arranging things. So how many batting orders of 11 players can be made out of 15 players such that 2 particular players are always among the selected 11 players? Just now we spoke about this, no? No? Just now we spoke about this type of question. Batting, but here you have to arrange also. You have to make the order also. We know how to keep 2 particular people. If you are attending from the starting, you'll understand that how to keep 2 particular people. So out of 15 players, we have to select 11 players such that 2 particular players are always among the selected 11 players. So basically what you are doing is you are selecting from 13 players, because 2 you have already decided, and from 13 you have to keep 9 only, because out of 11, 2 you have already selected, right? Out of these 11 players which you were supposed to select, 2 you have already selected. Now from the remaining 13 players, you have to select 9. Correct? So can I say 13C9 you are doing? And but how many batting orders are possible? After selecting, in how many ways can you arrange them? In how many ways can you arrange 11 people? You can arrange them in 11 factorial ways. Suppose there are, you are selecting out of 10 different t-shirts, you have to select 2. Select 4, let's say. So how will you select? You will select the number of selections, possible selections are 10C4. But now then you are asked that in how many ways you can arrange these 4 t-shirts in 4 different shelves. So you will say 4 factorial. You are selecting then arranging. Very important to understand this actually. Easy to hear, but selecting then arranging. The question is demanding arrangement also from you. Keep that in mind. They are asking you how many batting orders are possible. That means how many arrangements are possible. Batting order means first Virat Kohli, then second Rohit Sharma, then Pandya or whatever, right? Different orders can be there. Different order means different arrangements. How many arrangements are possible for 11 players at 11 places? Selections, 2 particular players were always there. So 13C9 will be the selections. Now, next thing. Gap method and block method. Very commonly used method, and actually these methods will ease your problem solving. Otherwise, this gets complicated sometimes. Problem solving itself gets complicated sometimes if we don't use this particular specific approach. This is not something standard which is mentioned in other books also, or everywhere it won't be mentioned. If you are following some other book, they can name it some other way, or same or some other approach they can teach you. But generally the method few teachers have named this method's name as block method and gap method. It's not some standard name you'll find everywhere, or if you tell somebody in your school that what is gap method, what is block method, it's not necessary they'll reply the same, or they'll tell you what is it. They might know what is it, they might be calling it something else, so don't worry about it. Which type of questions it will be used. In how many ways 7 boys and 4 girls can be arranged? Read the question. In how many ways 7 boys and 4 girls can be arranged so that no 2 girls are together? no 2 girls are together. 7 boys and 4 girls are there. First of all, 7 boys are there. So let's say B1 is there, B2 is there, B3 is there, B4 is there, B5 is there, B6 is there, B7 is there. 7 boys are there. Okay, there are 7 boys. In how many ways? First we'll arrange 7 boys, right? First we'll have to arrange 7 boys. Correct? We have to arrange all of them, 7 boys and 4 girls. Condition will come at, but first thing which we understand is arranging 7 boys in 7 places, right? 7 boys and 4 girls are going to be arranged. So arranging 7 boys in 7 places, 7 factorial, that we know. Okay. Now we have to arrange in such a way, this arrangement should be in such a way that no 2 girls are together. We don't want 2 girls to sit together, right? So what will we do? We'll make these girls sit in these gaps of boys. That's it. If we are able to make the girls sit in these gaps, there will be no 2 girls sitting together. Correct? But gaps are more. How many gaps are there? 1, 2, 3, 4, 5, 6, 7 and 8. There are 8 gaps. Out of these 8 gaps, I need 4 gaps only because I have 4 girls. So first I'll select. Remember, first you'll have to select blocks. Yes, Bunny. Complex number I can take earlier, but integration, might take time. 8C4. Pay attention here first. Okay, it's okay. Even if you have done this chapter, keep listening. If you have come here, keep listening. 8C4. 8C4 is selecting 4 gaps out of 8. Now, actual problems which are asked in mains or even in advanced, those concepts we are going through. So pay attention, please. 8C4 means out of 8 gaps that we created among boys, now we are selecting 4 gaps. 4 gaps we are selecting. 8C4. In these 4 gaps, I have to arrange 4 girls. How many ways can be arranged? Pay attention at this. Arrange 4 girls. So 4 factorial. 4 factorial. 4 girls in 4 places. There can be 4 factorial ways. First I'll select which 4 gaps. First I'll have to know in how many ways I can select 4 gaps. I can have 4 gaps itself. Right? So any 4 gaps I'll select. Right? And then I'll arrange 4 girls in those 4 places. Multiplication, because I'm doing it continuously. And 7 factorial, I did in starting only. 7 factorial is the number of ways to arrange boys. 7 factorial into 8P4. 8P4 also you can say. 8C4. 8P4, 8C4. Yeah, here it will become the same thing maybe. Ritu, I'm saying that you have 7 boys. Right, 7 boys. First of all, think 7 boys can be arranged in 7 factorial ways. That you must have understood by now if you are attending from the starting. 7 boys arranging in 7 different places will be 7 into 8, 6 into 5 into 4 into 3 into 1. That means 7 factorial ways. Now I have to make this arrangement in such a way that no 2 girls are sitting together. That means if I want no 2 girls to be sitting together, I have to make girls sit in these gaps. Here, 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 here or here. Correct? 8 gaps I have created. 7 boys have created 8 gaps. 1, 2, 3, 4, 5, 6, 7. 8 gaps, 7 boys have created. Out of these 8 gaps, first I'll have to do selection, right? First I'll have to do selection because first I'll have to know in how many ways I can take and choose any 4 gaps. Will also be counted in my number of arrangements only. So any 4 gaps I can select by 8C4. 8C4 I did. After selecting, I have to arrange 4 girls also. G1, G2, G3, G4, G3, G1, G2, G4, G4, G2, G1, G3. There can be different arrangements. So by 4 factorial, I am arranging these 4 girls in 4 gaps which I have selected. Correct? So this will be your total answer. Now next look at the second one. All girls are together. This is going to be easy because all girls want to be together. Not a problem. All girls want to be together. That means if there are G1, G2, G3, G4, 4 girls are there, right? 4 girls. I'll put them all together. You stay together. Girl gang. You stay together, form a girl gang, and I'll put them in a packet. Remaining 7, my boys, have no problem. B1, B2, B3, B4, B7. These 7 boys can be arranged without any, there is no restriction on boys, right. So 7 boys, but all girls need to be together. Now 7 boys and this one packet, this will be treated as one packet, no? 7 boys and one packet, that means one more element. This complete thing, either it will be here, whatever, wherever it will be, these will be together only. So I am considering it as one pack, one girl gang. So one element, 7 these elements, 1 this element. So totally 8 elements, and arranging 8 elements will be in 8 factorial ways. But inside this block, arrangement of girls can happen, right? Inside this block itself, arrangement of these girls can happen, yes or no? It will happen. Arrangement of these girls will happen. So in 4 factorial ways. How? 4 girls in 4 places, 4 factorial ways. Understood? Yes or no? Next, all girls are together and all boys are together. Wow. All girls are together, all boys are together. Any problem in this? No. All boys are together. B1, B2, B3, B7. And all girls are together. G1, G2, G3, G. Internal arrangement here will happen. Yes, 7 factorial. Internal arrangement here will happen. 4 factorial. These can be internally arranged, these can be internally arranged. Achha, there can be, this is let's say boys, this is girls. Yeah, this let's say, these are boys and girls only. But internal arrangement of boys and girls can also happen. First boys, then girls, first girls, then boys. So into 2 more ways. 2 factorial, no? Very good, Vijayashree. 2 factorial into 7 factorial into 4 factorial. This should be your answer. Amazing. Now, this is something which you can do on your own. Not all girls are together. Total cases minus the cases when all girls are together. Total cases are 7 plus 4, 11 factorial. Total cases, total arrangements. Then all total arrangements, that means 7 boys are different, 4 girls are different. So total arrangements will be 11 factorial minus the arrangements where all girls are together. Minus the arrangements, total arrangements, I am saying total arrangements minus arrangements where all girls are together. And just now we found out how many arrangements we had when all girls are together. All girls are together. All girls are together, 8 factorial into 4 factorial. So 11 factorial minus 8 factorial into 4 factorial. That's what we need to do. And we'll get our answer very easily. There are 4 boys and 4 girls. In how many ways they can be arranged such that girls and boys are alternate? Can we do this? Girls and boys are alternate. No sir, 8p4 into 4 factorial. Yeah, 8 factorial into 4 factorial, no? Wait. All girls are together. Here we got 8 factorial into 4 factorial. 8 factorial means we put all girls in one pack. Total cases minus the cases when all girls are together, beta. Look, not all girls are together means total cases minus, if we can subtract the cases where all girls are together, we'll get the cases where all girls are not together. Simple. That's what I'm saying. Yeah. Okay. There are 4 boys and 4 girls. 4 boys. B1, B1, B2, B3, B4. In this case, G1, G2, G3, G4. In how many ways they can be arranged such that girls and boys are alternate? Girls and boys are alternate. That means 1 boy, 1 girl, 1 boy, 1 girl, 1 boy, 1 girl. Correct? Right? That's what can happen. B1, G1, B2, G2, B3, G3, B4, G4. This can happen. But these B1, B2, B3, B4 internally can also be arranged. in 4 factorial ways, and G1, G2, G3, G4 can be internally arranged in 4 factorial ways. So 4 factorial into 4 factorial. 4 factorial for boys are internal arrangement and 4 factorial for girls internal arrangement. But there can be one more case. There can be one more case when this thing is starting with girls. G1, B1, G2, B2, G3, B3 and G4, B4. This is starting with girls now. In that case, 4 factorial into 4 factorial into 2. So 4 factorial square into 2. Correct? Two possible cases are there. Okay, in how many ways 3 couples? Let's see this question. This is, I think, a different one. Yeah. Read the question. In how many ways 3 couples can be arranged in a queue from left to right such that no husband is standing before his wife? No husband is standing before his wife. 1, 2, 3, 4, 5, 6. 3 couples means 6 places, no? So let's say first couple, let's say first husband and first wife, we have to place, and we can place them anywhere. This place, but there is only one way. Correct? From these 6, I choose any one couple. Right? But there is only one way of putting them, because no husband is standing before his wife. That means wife is standing before the husband. Right? So first wife, then husband. First wife, then husband. When I am selecting 62, when I am doing 62, basically I am selecting any couple, and then I am the number of way of their rearrangement. Internal arrangement is just one. First wife, then husband. So here we will not do 2 factorial. I'll select any 2 gaps out of these 2. Any two places out of these 6. From 6C2 means that I'll be selecting any 2 places out of the 6 places. So these 2, suppose I'm selecting these 2, I'm selecting these 2, I'm selecting, I've included all of them in 6C2. But internal arrangement I'm not going to do, because the condition is that no husband is standing before his wife. That means only one, either it can be HW or WH, but it is always WH, wife and husband. So one way. So I'm not doing anything for internal arrangement. After this, suppose I selected this and this, WH. After this, from remaining 4, I have to select 2 more. I have to do this continuously, simultaneously. So I'll be selecting 2 more from the remaining 4. There also rearrangement is not applied, because already it is mentioned that only one way to arrange them. Right? 2 more I selected. After that, what? 2 will be remaining, so only one way. There also one way. 2C2 you can write, but 2C2 is 1, and internal rearrangement we don't have to do. So I think this should be your answer. We'll check. Yeah, 90. 6C2, 4C2, 1. Very good. Very good, Vijay. Great. Let's see number of ways of arrangement of few objects when they are alike. For example, let's do with questions. Arrangement of objects when we have alike objects. So read the result. The number of ways of arranging P elements in a row if out of P objects M are alike and N are alike and rest distinct. Out of P objects M are alike and N are alike. Here we have 1, 2, 3, 4, 5. 5 objects in which 3 are alike. 3 M's are there. Right? So what we'll do? We'll do 5 factorial divided by 3 factorial. Total number of arrangements. Why? Because why are we dividing by 3 factorial? Because when we'll treat them as a packet, we'll treat them as a packet. Correct? And if we'll treat them as a packet, we'll have to multiply for rearrangement 3 factorial. Listen to this carefully, otherwise listen again afterwards. Internally also you'll have to rearrange if they were different. So it will be 3 factorial, but now they are same. So we are dividing by 3 factorial. Nothing much. Right? Arrange. How many? 2 A's, 2 R's. Anything else? 2 A's and 2 R's. 2 A's and 2 R's. m objects are alike, n objects are alike. So total 1, 2, 3, 4, 5, 6, 7 factorial is total, and you have to divide with 2 a's, so 2 factorial, and 3 and 2 r's, so 2 factorial more. Whatever is repeating, the number of times it is repeating, divide by that factorial. A, B, 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 so total 5 factorial divided by 2 factorial into 3 factorial, 3 b's, 2 a's. A, triple B, double C, so 3, 5, 7, 7 factorial divided by 2 factorial, 2 A's, 3 factorial for 3 B's and 2 factorial for 3 C's. That's it. Simply remember this. We cannot waste time on making the arrangements by doing calculations, putting packets and all. No, remember this. Whenever you have such a case, when m objects are alike, n objects are alike, in total p objects, then the formula is p factorial by m factorial into n factorial. If there are more, we will see with examples. Yeah, correct. Number of words with or without meaning that can be formed using all letters. See, direct question. This was in 2023 only. With all letters of the word so that vowels occur together. Okay, they want vowels to occur together. So, which are vowels? A, I have A, I, 2 times I is coming, I, O is there. Any other vowel? A, I, O, U only I know. Any other vowel, please check once. Triple A, double I and O, right? Remaining letters we have. So what do we have? S we have 1, 2, 3, 4 times we have S. And N is 2 times, so 2 N's we have. What else? T we have? T we have, right? T we have. Nothing else. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 30, correct. This is it, right? So now what do we want? We want vowels to occur together. What we'll do, we'll put them in packet. Occur together means put them in a packet, treat them as one. Now, sorry. Can you hear me properly? Any problem in voice? So now what do we have? 7 of these and this is one packet. So 8 things you are arranging, 8 factorial. What are similar? 3s we have, correct, and 2n we have. So 3 factorial into 2 factorial. Number of arrangements of these 7 and this one packet 8. We have to keep them together. So, oh, 4s we have, sorry. We have 4s. We have 4s and 2n's. So 4 factorial upon 2 factorial. After doing this arrangement, internal arrangement of vowels will happen. Internal arrangement of vowels also, how many vowels? 6. So 6 factorial upon 3 a's. So 3 factorial into 2 i's, so 2 factorial. That will be your answer. You can calculate this. I hope clear, right? First we did these 7 and this one packet, 8 things we arranged. So 8 factorial, out of which these 4 and these 2 are similar. Okay. After that we did internal arrangement of this packet which has vowels. Vowels itself can be rearranged, no? So there 6 vowels, out of which 3 are same of one type and 2 are same of another type. Okay. Directly this question could be solved, and I think you can calculate this also easily. How much is this? 8765 4 okay, calculate this. I think it will take time. Let's move to the next question. We are already 50400 should be your answer, right? Just check once. Okay, correct only. Now this question try on your own. Nothing much. You have to take 4 at a time. Only one difference is there. You have to take 4 letters at a time. Nothing much, sir. मैं आंसर नहीं लिख पा रही हूँ. Which answer, Shubhi? Which answer are you talking about? This? Solve. So here we won't be able to solve complete, I'm trying to avoid calculations so that we can save time. We have limited time and we have to complete this entire chapter. Too many topics, too many variety are there. So I treat me as a human. I cannot keep on speaking till like 8-9 hours. The energy will go away, so I have to save the energy. Trust me. This one, try it on your own once. You'll be easily be able to do it. not a problem. You have to choose 4. You have to choose 4 at a time. So basically I can write it down. How many eyes are there? 3 eyes are there. Right, you have 3 eyes. I is there. Okay, and what else is repeating? T is repeating. 2 T's are there. Right, 2 T's are there. Then everything is different. I think D, I we have written D, right? D S R B U O N. D S R B U O. O is also ones, right? And N. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right? D S R B U O and N. Okay. Now what you have to do is make 4. Taken 4 at a time. So here 2 types of cases you will have to make. Either 3 will be same. So these 3 are same, and let's say this one is different. Right? Or what can be the case? These 2 are same and these 2 are same. Okay. What else can be the case? Right? These 2 are same. That means these 2 are same and these 2 are different. These 2 are something else. One is let's say pink and one is let's say yellow. If you refer to the last question where take a few minutes break, sir. A few minutes break, still that will be very difficult. Right? Or all 4 are different. That means all 4 are different. 1, 2, 3, let's say 4. All 4 are different. 4 cases you will have to take and you can easily find your answer. Right? In the first case, for example, in the first case when 3 are same and 1 is alike, so you have to choose out of 8, you have to choose 1, which is the one which is going to be different. First you will have to choose that, then 4 factorial upon 3 factorial. Try this question once. Okay, if you don't get it, comment in the comment, you can say I'll solve it in some other session, but try once again, once on your own. Otherwise solution is also going to be there. I've already explained you how to solve it. Let's move to the next. Number of 7-digit integers with the sum of digits equal to 10 and formed using digits 1, 2 and 3. This is a different type. We have not solved this before. Sum of digits 1, 2 and 3. How can we make? What do we need? We need a 7-digit integer. So 7-digit integer with sum of digits equal to 10. If I take all of them 7, suppose if I take all of them 7, suppose 1, 2, 3, 4, 5, 6, 7, sum will be 7. I need 7-digit integer, so I have to increase. If I increase this by 2, does it make any difference? If I increase this by 2, no. Still the sum is 6 plus 2, 8. So I'll have to increase this one also by 2. I'll have to increase this one also by 2. Correct? What else? Now the sum is okay. Do you think so? No, I don't think so. 2 to 4 and 5, 9. Sum is still 9. So what will I do? I'll increase this also by 2. Now let's see. Now the sum is 10. Now the sum is 10. Now number of 7-digit integers, sum of digits equal to 10, formed by using 1, 2 and 3 only. 1, 2 and 3 only. That means digits are going to repeat. Right? Digits are going to repeat. And we can see that. We can see that digits are repeating. Right? Digits are repeating here. 4 ones are there and 3 twos are there. Correct. So number of arrangements over here, what will be the number of arrangements that we'll get over here is, in this case, if we make the sum 10 like this, if we choose the digits, we can use 1, 2 or 3. We did not use 3 till now, but we are getting sum till 10. But using these digits, how many numbers can be formed? That means how many arrangements can be formed. How many arrangements? When 4 are alike. So total we have 7 factorial divided by 4 factorial into 2 factorial. That's what we need to do. No, not 2 factorial, 3 factorial. 3 times 2 is repeating, right? Why am I writing 2? 3 times 2 is repeating, 4 times 1 is repeating, so 4 factorial, 3 times 2 is repeating, so 3 factorial. This is one case. We can also do this with using 3, 2, 3, 4, 5, 6, 7. Again 7 ones, the sum is 7. Suppose I want to make one of them as 3. So last one I'll start with, suppose I'll make this as 3. Then what can I do? 9 I have, right? This one if I make 2. This one if I make 2. There is no other way of making 10 using 1, 2 and 3. Obviously. Right? Sum itself of 1, 2 and 3, sum itself is 6. So we cannot make 10 out of that. We have to repeat the digits. That's mandate. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. We are getting 10. So this can be a case in where we are including 3. Number of arrangements in this case. How many arrangements can we have in this case? 7 factorial divided by, there are 5 ones. So just 5 factorial. Right? 2 and 3 are different. So just 5 factorial. Can there be any other possible way? If I keep this also as 3, 6, then only 4 ones will remain. We need 7 places. I cannot make this also as 3, right? So only these 2 possible scenarios are there. You can check afterwards if you want to. There cannot be any other possible scenario according to me. If you make this as 3, no, you cannot do. 2, 2, 2 we included, right? We cannot include any. Suppose if this becomes 3, then also the case is not happening. So only these 2 scenarios, we'll add these 2. We'll add these 2. 77. 7 factorial by 5 factorial, 77. Okay. Yeah, option is there, then definitely Vijay, correct. Definitely. 77, 42 plus 35. Amazing. Amazing. Now, very special thing. Some not special thing I would say, but yeah, some special kind of problems. Some special kind of problems where dictionary problems somebody asked in the starting. I don't know if he's sitting till now or not. First thing is derangement. Derangement means, suppose derangement, how can I explain? Suppose there is envelope 1 which needs to go in post box 1. Okay. Envelope 2 is supposed to go in post box 2. Envelope 3 is supposed to go in post box 3. Envelope 4 is supposed to go in post box 4. These are the respective post box. Now you have to derange. That means envelope 1 should not go to post box 1. It can go to any of these. Envelope 2 should not go to its respective post box. It can go to any other one. Right? Basically in Hindi we can say ulta pulta, or you have to just jumble it up randomly with the not to the allocated one. The envelope should not go to its allocated address. Instead of except that address, it can go anywhere in the remaining address space. Okay. So this is called derangement. Envelope 3 cannot go in post box 3. Rest anywhere it can go. So how many total derangements can be there? In how many ways can we derange? Arrange means respective, we have to send E1 at P1, E2 at P2, E3 at P3, E4 at P4, like that. Derange means just opposite of that. That a particular envelope should not go to its designated post box. Apart from that, it can go anywhere. Okay. So total number of derangements. Simply remember this. This particular formula is going to help you a lot. And wherever derangement comes, you'll understand. I'll explain you with the help of questions. Find the number of derangements of 4 letters. How many ways are such that only one letter goes to its address? Only one letter goes to its address, rest does not go to its address. Only one letter goes to its address. See, there can be multiple ways of doing this. One letter is going to its address. There are 4 letters. Let's say letter 1, letter 2, letter 3, letter 4. One of these letters are going to its address. Address 1, address 2, address 3, address 4 are there. One of the letters is going to its address and remaining 3 are not going to its given address. That means remaining 3 are being deranged. Correct? L1 is going to A1, let's say, but L2, L3, L4 are not going to A2, A3, A4. They are being deranged. So what we'll do, first we'll select any one which is going to its own address. 4 ways to select any one out of 4, right? in a way only one letter goes to its address. So any one, that means 4 are there. So one, selecting one means 4C1, I've selected which one goes to its address, multiplied with 3 to be deranged. Derangement formula, for example, if I'm finding D5, D5 will be equal to, that means I'm deranging 5 objects, right? This will be equal to 5 factorial multiplied with 1 divided by, 1 minus 1 divided by 1 factorial plus 1 divided by 2 factorial minus 1 divided by 3 factorial plus minus, it will keep going on like this, right? Mostly till 4, 5 you'll have to go, not more than that. So just remember this, minus plus minus will go alternatively, plus minus will go alternatively. It will start with 1, then 1 by 1 factorial, 2 by 2 factorial, 3 by 3 factorial, 1 by 1 factorial, 1 by 2 factorial, 1 by 3 factorial, 1 by 4 factorial, it will keep going on like this. Okay. Now here, what do we need to do? We need to derange 3 elements. That means we can call it D3. D3 will be equal to 3 factorial multiplied with 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. We have to go till 3 only. Okay, so that's what we'll calculate. So into 3 factorial, 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. This will be our answer. Calculate, please. It can be easy calculate. This is 1 only. This is 0. Then 1 by 2 minus 1 by 6. Right? It's minus 2, 4 by 12. 4 by 12. And this is 3 factorial. 6. Yeah, you can easily calculate this. It will be 4 into 3 minus 1, I think, right? 4 into 3 minus 1, that is 8. I think 8 you will be getting. Check somebody. Yes, 4 into 2, 8. 3 factorial into, here it will get cancelled. 8, 8, 8. Right, 8. Okay, in the solution they have calculated 4, D4 also, but we don't need that anyway. We have followed another approach. You can use that only. Select one and derange the rest 3. In an examination, 5 students have allotted their seats as per their roll number, the number of ways in which none of the students sit on their allotted seat. Deranging 5, direct question, right? There is no condition. Getting my point? Direct question. Deranging 5 elements. That's it. 5 students have been allotted their seats as per their roll number. What you have to do? You have to find the ways in which none of the students sit on their allotted seats. Very notorious students. Like, I don't know. Okay. But direct question. D5 you need to calculate. You are supposed to derange 5 elements. So this is nothing but 5 factorial. 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. That's all. Nothing much. You'll be easily able to calculate this. We can check the answer. 44. Yeah, 44, and there is a solution as well. 44 will be our answer. Okay, direct question. But you can see derangement formula can be sometimes directly asked if they are asking. Okay, okay. Now let's come at dictionary problems. Dictionary problems means finding the rank, right? Finding the rank. So, like we have seen dictionary. Suppose you are searching for your own name. Suppose you are searching for Ayush, or suppose you are searching for Aman or Leeta, Neela, Lalita, Lata, anything. Whatever is your name, you are searching for the name. How do you go for that? How do you approach towards that name? First, you'll start with A, letter starting with A, then with B, C, then order wise, right? I hope everybody knows how to see the dictionary, correct? So suppose let's start with problem only. Suppose we have to find the rank of Surat in dictionary. Alphabetical order, exactly. Alphabetical order will be your scenario. Suppose we are going to find the rank of Surat in dictionary. So 5 letters or 5 letter words that can be arranged using Surat, each letter used only once. This is good that each letter is only used once. We are not repeating the letters. This is generally in dictionary problems, they'll do like that only. So what will be the rank of Surat? That means where will Surat come? What will happen? First of all, when you'll open the dictionary, you'll start with A. Okay, A. You'll start with A. You have S, you have U, you have R, you have A, you have T. Letters 5 and 5 letters. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 letters you have. Right? The letters which are starting with A and are of 5 letters, the words that are starting with A and are of 5 letters, A will be the initial, A will be the first thing, and remaining at these 4 places, how many ways can we arrange? You have to arrange these. The dictionary does not have all the letters of the world. First of all, believe that. The dictionary has only the letters which are formed by using the letters of Surat. Correct? Formed by using the letters of Surat. S, U, R, A and T. That is one condition. Don't think that's other 26 into 25 it will become. So basically we are only using the letters of the word Surat. The words which will start with A, here if it starts with A, remaining to fill these 4 places, how many ways do I have? 4 factorial ways. 4 places with 4 different letters except A. 4 factorial ways. Correct? Can I say that? After this, all the letters which have started with A will complete, will get over. Now which letters will start? After A, what comes? R, S, T, U, R will come, right? So now letters with R will start. Here also 4 factorial ways. There will be 4 factorial words starting with A and 4 factorial words starting with R, containing letters S, U, R, A and T. Can I say that? After A and R, what will happen? Now see, pay attention, we need to reach at Surat. We are not finding all the letters which are going to be found. We have to reach at Surat. Now after A and R, R, S, T, U, yeah, after A and R, S will come. S will start looking at the letters. First we are turning our pages very fast. 4 factorials, that means 24 ways. Okay, here also 4 factorial, 24 ways. We have turned our pages very fast, but now we have come to S, because after A, R, the words which will start with S will be starting. Correct? So now we have come to S. S, letters starting with A, S, first few letters, first letters itself will be having A. After S, A will be there. After S, we cannot look at all the letters starting with S all of a sudden, right? From here itself, we cannot start looking at all the letters, all the words which are starting with S. We have to be careful now. After S, first of all, the words which we are going to see will be having S and A. Correct? Agreed with me or not? S and A. Now, S and A is placed, remaining 3 places. How many S and A is placed? First SA will come, right? If we look at S, then SA will first be getting words which are having SA in the starting, right? First 2 as SA. So here we will have 3 factorial ways. That means 6 more words will be formed which will have SA in the starting. After SA, what will be there? SR will be there. A and R, right? So SR will also be there. Here also we will have 3 factorial ways. So 6 words will be of SR starting, will be starting with SR. After SR, because we have to reach till SU, you are getting my point, we have to reach till SU, but before SU, ST will also come, STU, yeah, ST will also come. So here also we will have 3 factorial ways, that means 6. Correct? Now SU will come. After all the words which have started from S and T have gotten over, now we'll have the words which are starting with SU. But here also ST is done, then SU will come. But here also SUR directly won't come. First SUA will come, right? First we'll have SUA. So first we'll have SUA and remaining 2 will have 2 factorial ways. So 2 more will be there, which will be SUA, which will have starting SUA. Then after this SUR, after A directly R will come, no, RSTU, yeah, directly R will come. Correct? Directly R will come. So here SU, now my words will be starting. SUR AT will come first or SUR TA will come first? SURAT will come first. So this will be my next word. So count this: 24, 48, 52, 52, 58, 58, 6, 64, 64, 66, 67th word. Am I correct? Check. 68th word. 68th, 69th. This sum is 68. So Surat will be 69. This will be 69th. Surat will be 69th. This sum is 68, no? 60, 68, 69th. Correct. We are correct. We are correct. Correct. 69th. If all 5 lettered words with or without meaning, okay, do this one, you do on your own. Okay, I think there are 3. Answer you can verify. Verify your answer, right? You have to find the rank of knife. One more we'll do, which is P by Q. If all words with or without meaning having 5 letters formed using the letters of word small and arranged as in a dictionary, then the position of small, although we'll be able to do it easily if we follow the last approach, correct? So first, which letters will start? First A will start. Here only one thing is to be taken care of, that there are 2 L's, right? There are 2 L's. So first of all, we'll start with A. And 4-lettered word, we need to make 4-lettered or 5-lettered? 5-lettered, right? 5-lettered. So there will be 4 spaces. Now in these 4 spaces, there are 2 L's. So how many ways? 4 factorial divided by 2 factorial, because 2 L's, 1 letter is repeating. Remember, repetitions are now. Very good. Very good, Vijay. So 4 factorial by 2 factorial. Now after all the words which have started with A have completed, what will come? L will come. L will come. L will start. But now repetition won't be there. Getting my point? Are you able to see what I am seeing? L is already placed. Remaining L and other 3. So all 4 are different now. So we have to simply write 4 factorial, because in 4 factorial ways, another L and the remaining ones will be arranged. We are not arranging this L. We are arranging these, which has only one L and A, S and M. L, A, S, M we are arranging L, A, S, M at 4 different places, 4 factorial ways. A done, L done. S I think will come in the last only. My God. A done, L done. What will come now? M, M, M. Again, repetition will be there, right? So 4 factorial upon 2 factorial, same thing. Not much of calculation, I think, but yeah. 4 factorial upon 2 factorial. After M, S and A will come, right? S and A will come. Directly SM won't come, SA will come. Now 3 places. 3 places. And there are 2 L's. So what do I need to do? 3 factorial divided by 2 factorial. Arranging 3 different things, but 2 are alike, same, right? After SA, can I directly write SM, LM, AL? No, SL I have to write, SL. Again here, one L is already placed. So remaining 3 factorial ways, 3, M and A. L, M and A you have to arrange. So 3 factorial ways you can arrange. Are we done? No, I don't think so. SL, after SL, SM can come, but yeah. After SL, SM can come. SM, L won't come, SMA only will come. I think SMA, LL will come directly. Do you think the same? Can I say SMA, double L will come directly now? Because A, L, M, SA, then SL, then SM. After SM, SMA only will come, SMA double L will be the direct word. Correct? So calculate this. This is how much? 24. This is 24. 4 factorial upon 2 factorial. No, this will be 12. Yeah, sorry. This will be 12. Any answer? 58, Vijay? Sure. 58 is an option. 12, 24, 12, 3, 6, 48, 51, 57. 57 is the sum here. So this will be 58. Correct. 58. Correct. Just a minute. This wire. Okay. So see, directly dictionary based, simple problem, you just have to think according to the dictionary, right? Don't make a mistake in letter arrangement, alphabetical order and all, otherwise these questions can be handled very easily and they do come often sometimes. Divisor, sum of divisor and exponent of prime. This is standard approach, directly formula based approach. You don't have to do anything much and direct questions can be asked on this approach also. For the number 2 to the power 2, 5 to the power 2 and 17 to the power 1, number of divisors you need to find. Number of divisors means, what will it mean? That we have, for this number we have 2 into 2 to the power 2 into 5 to the power 2 into 17 to the power 1. Number of divisors means, suppose if I take 2 to the power something, 5 to the power something and 17 to the power something. 2 can have which powers? 2 can have 0, 2 can have 1, 2 can have 2. 3 powers can be possible for 2 itself. 17 to the power 1 only, right? If I divide this by 2 to the power 0, 2 to the power 1 or 2 to the power 3, 2 to the power 0, 2 to the power 1 and 2 to the power 2, all 3 will form a divisor. Correct? If I divide it with 5 to the power 0, 5 to the power 1, 5 to the power 3, all 3 are divisors. 5 to the power 0, 5 to the power 1, 5 to the power 2, all 3 will make divisors. Here 17 to the power 0 and 17 to the power 1, that will also make a divisor. So for this place I have 2 plus 1 options, 2 plus 1 because 0 can also be included. For this one also I have 2 plus 1 options. For this one also I have 1 plus 1 option. 2 plus 1, 2 plus 1, 2 plus 1. So basically 3 into 3 into 2, 3 into 3 into 2, let's come on this question. Okay, all. Yeah, 3 into 3 into 2, 3 into 3 into 2 is correct. 18 will be our total number of divisors. Number of even divisors, if we make number of even divisors means we cannot include 2 to the power 0, 2 should be there. So this will decrease, instead of 3 this will become 2, this will become 3, this will become 2. 2 into 3 into 2 will be our answer. Number of odd divisors means total number of divisors minus even divisors, that will give you odd divisors. That only is given as the answer, right? 2 they have included because 2 to the power 0 cannot be included now. So what do we have? What options do we have? 2 to the power 1, 2 to the power 2. 2 options only we have. For power 3, here 3 will remain, here also 2 will remain. Now number of odd divisors will be total divisors minus even divisors. Standard approach, direct approach. Sum of divisors here. Sum of divisors, yeah. Another concept, sum of divisors. How will you create sum of divisors? So this 2 to the power 3 can have either 2 to the power 0, it can be 2 to the power 1, it can be 2 to the power 2, it can be 2 to the power 3, right? Sum of divisors of this. So now if I break this like this 3 to the power 0 plus 3 to the power 1, 3 plus 3 to the power 2 plus 3 to the power, no 3 won't come. Why am I writing? So 7 to the power 0 plus 7 to the power 1 plus 7 to the power 2. This is asking sum of all the divisors. So this multiplied with this, this if we take and multiply in these two brackets, that will form one divisor. This multiplied with elements of this bracket will also form one divisor. Similar thing will happen with all of them. Here also multiplication will form one divisor. Multiplication of the interior elements will form one divisor. Correct? So that is why the sum of all divisor at a to the power m, b to the power n and c to the power q will be equal to a to the power 0 till m, b to the power 0 till n, c to the power 0 till q. That is how I will be forming divisors, right? This is the only way I will be forming divisors. 2 to the power 0 multiplied with 3 to the power 0 multiplied with 7 to the power 0 will form one divisor, 1. Right? 2 to the power 0 multiplied with 3 to the power 1 and 7 to the power 1, that will also form one divisor. So basically multiplication of all three will be giving us divisor, and this is nothing but GP, 2 sum of GP. You just have to apply sum of GP, 2 plus 2 plus 4 plus 8, and this is 3 plus this will be 0 here, 1 plus 2 plus, and here we'll have 1 plus 3 plus 9, and here we have 1 plus 7 plus 7 square. So GP you need to apply here. right? Sum of GP you need to apply, that's it, nothing else. This will become 2 to the power 4 minus 1 upon 2 minus 1, a to the power r minus a upon a minus r, right? 2 minus 1, this will become 3 to the power 3, right? 3 terms are there, so 3 to the power 3 minus 1 upon 3 minus 1, and this will 7 to the power 3 minus 1 upon 7 minus 1. That's it. This product you need to find. Let's check the answer. Direct approach. Remember these direct approaches, this type of question, that only we have to apply. Here again one direct approach question. In this case, find the exponent of 2. Achha, this approach applies only. First of all, I'll tell you the approach. First, let's talk about the approach. If you need to find the exponent of 2 in 40 factorial, how to find? Just start finding greatest integer of 40 to the power 2 plus 40 divided by 2 square plus 40 divided by 2 cube till the time you get 0 as the greatest integer, basically. So this will also go 40 divided by 2 to the power 4 plus 40 divided by 2 to the power 5, which is 32, plus 2 to the power 6 won't come because that will become 64, and greatest integer will come out as 0. So you have to do this, add all of them. These are all greatest integer functions. 40 divided by 2, 20. 40 divided by 4, 10. 40 divided by 2 cube, 8. 5. 40 divided by 16. 40 divided by 16 is 2 point something. So greatest integer will become 2. 40 divided by 32, 1 point something. Greatest integer will become 1. Sum of all this will be the exponent of 2 in 40 factorial. That is, how much is this? 38. Okay, but this is only allowed for finding, write this or finding exponent of prime. Okay, for example, for 3 if we are doing 40 divided by 3 greatest integer, 40 divided by 3 square greatest integer, plus 40 divided by 3 cube greatest integer, plus 40 divided by 3 to the power 4 we don't have to do because 3 to the power 4 will become 81 and the greatest integer will become 0 in that case. Correct? So now 40 divided, this we have to find, this will become 13, this will become 4 and this will become 1, right, 1. Next we don't need to add, next all will be coming 0, so we don't need to add them, although we have to keep doing it until we get 0. So this will become 18 for us, 18, this will become 18 for us. Again 3 is prime, in this case 6 is not prime, in the third case 6 is not prime. So in this case what do we need to do? So we'll break it into prime. 6 can be broken into 3 into 2. We'll find the powers of 3, we'll find the exponent of 3, we'll find the exponent of 2, whichever is smaller. Suppose we have 10 powers of 3 but 20 powers of 2. 6 will be made by 3 and 2 both. So only 10 3s are there, lowest is 10 only. So we'll be able to make 10 6. Suppose we have 5 3s and 20 2s. How many 6 we can make? We can make only 5 6. Why? Because 3 and 2 both are needed. Correct? So here you can tell me the answer. Exponent of 2. Exponent of 2 was how much? How much did you get? 38 we got, right? Exponent of 3 we got as 18. So exponent of 6. Exponent of 6 will become 18 only because we have 18 3s. So an exponent of 6 will be 18. Remember this. Okay. Next thing comes is circular permutations. Again direct approach based question, or sometimes some manipulations can be there in this particular approach. Circular permutations means number of ways of arranging n distinct objects in a circle. You have to arrange objects in a circle. I'll take a minute's break. I'll just come 2 minutes. Okay, you can also take a break if you require. I need water. Okay. Number of ways of arranging n distinct objects in a circle. In a circle, the point is that while I'm audible, right? Yeah. Vijay, can you confirm if I'm audible? Yes. Okay, I'm audible. Number of ways of arranging n distinct objects in a circle is n minus 1 factorial. For example, suppose there is a circle and I have A, B, C and D to arrange. Let's say 4 things we need to arrange: A, B, C, D. Okay, now how? First, in circle there is a problem that first you have to start the circle. First, it's not like a line. For example, a line, when we are doing like this, if we had to arrange like this, we can say from here we'll start, we'll put 4, then 3, then 2 and then 1. Correct. But here the problem is you have to start first. So first, for putting A, there is no number of ways. For placing any one of them, there is no number of ways, right? Suppose I put A over here. Okay, I have 4 places. Definitely in a circle also I have 4 seats. This is 1 seat, this is 1 seat, this is 1 seat and this is 1 seat. Okay, first of all I have to put somebody to start the circle, to begin. My reference point I have to make. In circle, that's the problem. Suppose if I put A here, then circle will start from here. Circle will start moving according to this A. If I put A here, A here, A here. So first I will locate A. After locating A, now I have to arrange my 3 remaining ones in 3 different places. That will be 3 factorial. Correct? Are you getting my point? Why is it n minus 1 factorial? Because you have to set a reference point. You'll need one of the article out of n articles to put there and set the reference point. According to that, we'll do the remaining arrangement. Correct? Because A here, 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 anywhere, it is all possible. If you put A over here, the circle is moving respect to this particular one. You rotate this. It's a circular thing. No, you can rotate it and get to the same position again and again. So first, for making the reference point, you have to put one article, you have to place one article, and remaining articles you'll arrange by n minus 1 factorial ways. Simple to understand. Any problem? No. Okay. If clockwise and anti-clockwise arrangements are considered in necklace, there is a special case. of necklace or garland, mala or necklace, what do we call? Har. Okay, in that case, what will happen? For example, suppose you have three different things, A, B, C. You arrange A, B and C like this, or you arrange B, A, C. This is considered as same because you are rotating your garland, you are rotating your necklace, and it will be considered as the same arrangement. They'll look the same. So total arrangements divided by 2 it will make. If you are supposed to make a garland, that means if you are arranging in circular table or something, there you are not making a garland. But if you are making something like garland or necklace or something whose image will be considered same, then in that case you have to do n minus 1 factorial divided by 2. This you should remember. If garland, necklace or something like that is mentioned, then do this. Direct question, arranging 5 distinct objects can be arranged in 4 factorial ways. Necklace, that means 4 factorial, right? And necklace, this is A. Necklace 1, that means 4 factorial divided by 2. Not 2 factorial, remember it's not 2 factorial, it's 2 divided by 2. We are making the cases half of the total cases because half of them are going to look same on rotating the necklace. Get my point? Am I clear? Now, out of 10 beads, suppose, if they want to make a variety on this question, what type of questions can come, that we are going to discuss. Out of 10 beads of different color, how many necklaces can be made containing 4 beads of different color? Definitely it's a question of selection and arrangement. That feeling we should get after reading the question itself. Selection and arrangement. Are we all getting that feeling? I hope by now we are getting the feeling of selecting and arranging. So we must be comfortable in that. Selecting, out of 10 we have to select 4 beads. Out of 10 different color beads we have to select 4 different color beads. 10C4. Now these 4 beads we have to arrange. Right? Now these 4 beads we have to arrange in a necklace. Necklace is there. So these 4 arranged in a necklace will be 4 minus 1 upon 2. 4 minus 1 factorial upon 2. So 10C4 first we will do. Then we will arrange these 4 in a necklace. So arranging 4 things in a circular thing is 4 minus 1 factorial, but in a necklace we will do 4 minus 1 factorial divided by 2. So 3 factorial divided by 2. Can you calculate this? Okay, let's check the answer. Yes, 630 should be the answer. Do them on your own once also. Please do all of them once on your own. Okay. If the question comes in JEE Mains for this, number of ways in which 5 girls and 7 boys can be seated at a round table so that no 2 girls seating together, creating gaps. Right, creating gaps. No 2 girls seating together means there will be, first we will arrange 7 boys. Arranging 7 boys, here there is no necklace, no garland. Here there is no necklace, there is no garland. First what we will do, in the circle, we will arrange 7 boys. Seven boys we will arrange. To arrange 7 boys, 1 will be placed as a reference point for 6. So 7 minus 1 factorial. This will be the number of ways to arrange 7 boys. After that, what do we have to do? Pay attention. Gap problem. Same 6 factorial into 695. Okay, maybe. Okay. 6 factorial arranged boys. In why 6 factorial? We are arranging boys. Now what are we doing? We are taking gaps. We are looking at gaps. This is a gap, this is a gap. How many gaps are created? 1, 2, 3, 4, 5, 6, 7 gaps are created. Out of these 7 gaps, I have to select how many gaps? 5 gaps. So from these 7 gaps, I will first select 5 gaps. 7C5. Correct? I have to select 5 gaps. Now what do I have to do? After selecting these 5 gaps, I have to do arrangements. But very important point over here, it won't be arrangement of these 5 girls. I selected 5 gaps, I placed girls in those 5 gaps, but now in these 5 gaps, when I'm arranging girls, now I won't do n minus 1 factorial. Why? Because n minus 1 factorial is done only in the starting to set the reference point. Correct? What now? I have already set the reference point while placing B1 itself. So now in these 5 gaps, the number of arrangements for placing or arranging girls will be 5 factorial only. Get my point, everybody? Are we clear? Are we clear? Okay, 6 factorial, 7c5 into 5 factorial. That will be our answer. Here important thing is that this will be 5 factorial. Don't make the mistake of doing this as 4 factorial because you have already set the reference point. Okay. Yeah, I think check the answers once. Answer is not written over here. In how many ways? 20% can sit around a round table. One more variety can be made like this. Check this question. Read this once. Here also same concept which we used in the last one has to be used. 20% can sit around a round table in such a way that there is exactly one person between A and B. So first we have located A and B, right? First we have to locate A and B, then only we can make somebody sit between A and B. Now between A and B have already been located. Number of ways to place a person between A and B. How many persons are left? 18 persons are left. So 18 ways to place a person between A and B. Correct? Number of ways to place. Instead of doing all that, pay attention here, or else it's okay. You can. It's not that somebody is forcing you to attend the session, right? Not a problem. 18 ways to place a person between A and B, correct? Any problem in that? No problem. 18 ways we can place a person between A and B because there are 20 people, 2 we have already placed, now remaining 18. Between A and B, 18 ways. First one, second one, third one, like that 18 ways. Now what we have to do? Remaining of the people we have to arrange. Now remaining are 1 we have placed here, 2 we have already placed, A and B are already placed, 1 person out of 18 we have placed between A and B, remaining are 17. So should we do 17 minus 1 factorial or 17 factorial? Tell me that. Should we do 17 minus 1 factorial or only 17 factorial? We have to do only 17 factorial because reference point has already been set when we placed A and B. So what will be our answer? It will be 18 into 17 factorial. Directly 17 people we are placing. A and B, so there is only one way of arranging A and B. No, A and B, arranging A and B also we have to multiply. Arranging A and B. A and B also can be rearranged. So 2 multiplied with 2 factorial or 2 directly we can write. Again I will repeat, 18 are the ways to, first we placed A and B. Anywhere, let's say anywhere we placed A and B in the circle. After placing A and B, there are 18 ways. Remaining people are 18. So we have to place a person out of these 18 between A and B. 18 ways of doing that. Correct? After doing that, we have to arrange remaining 17 people where reference points has already been set. So we have to do 17 factorial only. 17 people in circular arrangement where reference point has already been set. So 17 factorial will be fine. After that, you have to multiply with 2 to rearrange these A and B among each other. That also needs to be done. Don't forget that. Okay. All right. One question you guys try. This is also same. This is same only. 6 faces of cube. So suppose I make a cube. I'll give you a hint for this one. Suppose I make a cube. So first, any one color you place on any one side. First start, make the reference point. First put any one color on any one of the face. Now for the opposite face you will have 5 options. Suppose you put any one color on this face, right? For this place you will have 5 options. Can we say that? And remaining this one can be treated as a circular arrangement where you have to place 4 things. right? And for this circle you have not set the reference point. Get my point? Suppose any one color out of the 6, it is saying number of ways of painting 6 faces of a cube with 6 different colors. Pick any one color, put it on one side, put it on one face. Okay, this is one side and this is another side. This can be treated as circular, but this is simple only. For one you have set, for remaining you'll have 5 ways to choose a color over here for the opposite face. Right, for the opposite face you'll have 5 ways to choose a color. Now for this circular combination, what you have, 5 multiplied with, here you have to arrange 4 things, and there is no reference point set for this particular circle, so you'll do 4 minus 1 factorial. That's it. Calculate this. I think answer 3 factorial 6 30, right? 30 ways. Okay, leave for homework. Anyway, now comes distribution of objects. This again is an important thing, distribution of unlike and distribution of like objects. Pay attention. Last topic, I think we'll try to cover up, finish this up as soon as possible, but well explained, don't worry about it, you'll get to know. Yes, Ayan, and one more is there, the dominator. Wow, great. You know, right, karma is a very bad thing which happens in life. So if I think people are being paid, thoda paisa lo and do this, don't study but do these type of things, right? These kind of people are also there on internet nowadays. Anyway, we have to ignore such people and keep moving. Number of ways of distributing n distinct objects among m persons. Suppose we have, let's say we have sweet boxes, right? Let's say we have sweet boxes, let's say sweet box number 1, sweet box number 2, sweet box number 3, sweet box number 4, and we have 3 people, let's say person 1, person 2 and person 3. How to distribute? Now I have to distribute these 4 boxes of sweets in these 3 people. How will I do? Simple thing, I'll imagine the condition and I'll start distributing, right? I'll imagine the condition in my head, real life application only. If this happens in real life, what will I do? I'll say that, okay, sweet 1 can be distributed either to person 1, either to person 2 or to person 3. So basically 3 ways for doing this. 3 ways for distributing sweet box number 1, 3 ways for distributing sweet box number 2, 3 ways for distributing sweet box number 3 and 3 ways for distributing sweet box number 4. That's what. What else? Right? That can be the way. Getting my point? So now either I'll distribute to this one or this one, same thing I'll do with this, same thing I'll do with this, same thing I'll do with this. Imagine it in a real life scenario, 3 to the power 4, very good, 3 to the power 4. So total number of ways will be 3 to the power 4. What am I doing? I am distributing n distinct objects among m persons. So m persons, that means 3 persons is coming in the bottom as the base. And how many objects I am distributing? I am distributing 4 objects. So 4 will come in the power. This thing is very important to understand and remember. Otherwise, we might make mistake in doing this while distributing the objects. Always see the number of options. Okay, fine. Let's try to understand this through examples. Great. In how many ways? 5 distinct chocolates can be distributed among 4 students. 4 students are getting the chocolates. How many chocolates are they getting? 5. How many chocolates are from they are getting? 5. Get my point? So imagine this once again. Chocolate 1, chocolate 2, chocolate 3, chocolate 4, chocolate 5 among 4 people, P1, P2, P3, P4. Just doing this once so that you can remember. Again, this has 4 choice, this has 4 choice, this has 4 choice, this has 4 choice, this has 4 choice. So 4 to the power 5. What is coming at the base? Number of people that are getting the object. What is coming as the exponent? Number of objects that are being distributed. Remember this. Okay, this is important. 3 distinct chocolates can be distributed among 4 students, so 4 to the power 3. Directly you have to write. Directly you have to use in questions. No student gets more than 1 chocolate. Think about this now. No student gets more than 1 chocolate. 3 students will get 1 chocolate each, right? 3 distinct chocolates can be distributed among 4 students. Chocolate 1, let's say chocolate 2, chocolate 3 among 4 people. So P1, P2, P3, P3 and P4. No student gets more than 1 chocolate. So what will be the number of ways? Can you write directly? 3 students will get 1 chocolate each. 3 chocolates only I have, right? So 1 student I have to leave. I have to select 3 people, or I have to select 1 people which is not getting the chocolate, all chocolates to 1 student. No, it's written, right? No student gets more than 1 chocolate. So yeah, all chocolates to 1 will be included in the ways we are counting 3 factorial anyway, but 3 distinct chocolates only we have, and we have 4 people now. So first we'll have to select 3 people. First there will be selection and then distribute. This will also include the way this 3 factorial will also include the way where 1 student only is getting all the chocolates. This only, right? Okay, correct. 4 into 3 factorial. Distribution of objects. Sometimes this distribution will have specific condition that give 4 chocolates to this one, 2 chocolates to this one, 3 chocolates to this one, and some other number to somebody else, right? This type of number will be mentioned, that you have to give specific number of chocolates to people. In that case, you will have to understand the formation of groups. In that case, you will have to make groups. You will understand more with the help of questions, but here let's start first understanding how to make groups. Suppose totally we have m plus n chocolates. So we have to make, and we have to give m chocolates to somebody and n chocolates to somebody. So you make packets. What you'll do? You'll make packets. You'll make packet of m chocolates and n chocolates. And number of distributions now over here will be m plus n factorial divided by m factorial into n factorial. Okay. Suppose here, so it will be 15 factorial divided by 10 factorial into 3 factorial. Remember this. This is how you have to do. This is the number of ways of distributing. Arrangement we are not talking. This is just the number of ways of distributing 15 things in such a way that 10 things are given to one person and 5 things are given to, 5 things are given to another person. So it will be 5 factorial here. Okay. 15 things are supposed to be given to people in such a way that 3 things are given to one person, 5 things are given to another, and 7 things are given to another. So in how many ways can you be distributed? It will be 15 factorial upon 3 factorial into 5 factorial into 7 factorial. Now here one more case can be formed where 2 packets have same number of items, same number of chocolates. So in this case, what you are supposed to do? You will do 12 factorial divided by 3 factorial into 3 factorial into 6 factorial, and 2 are of same type, so you will divide by 2 factorial also. Okay, here for example, you have 12 things, so 12 factorial, 2 factorial into 2 factorial into 2 factorial, this you will do first, into 3 factorial into 3 factorial, multiplied with these are of same type, 3 are of same type, and these 2 are of same type. So into 3 factorial into 2 factorial also you will have to divide with. Remember this, direct approach. Example, suppose 6 distinct books have to be distributed among Ram, Sham and Gopal. Here this case is specific. Here they have specified the case, that's the difference. Variety, a different variety, direct approach you can use to be solved. Remember this distribution when the distribution is specific, that this much you have to give to somebody, this much you have to give to somebody else, and so on. So what you have to do is make groups, 6, 1 book, 2 book and 3 book. This is the case which you can make, right? 1 book to Sham, it's specific now. Now you cannot arrange now. Why? Because 1 book is specific for Sham. You have to give 1 book only to Sham. Now these 3 things you don't have to internally arrange. Remember that also. Okay. So what will you do? Simple. Just you'll just calculate number of distributions. How many distributions can be there? There can be, the total can be 6 factorial upon 1 factorial into 2 factorial into 3 factorial. That's it. These will be the total number of distributions. And now you don't have to multiply with 3 factorial. Internal arrangement is not there. Why? Because it's specified. Ram, there is only one way of giving this. There is only one way of doing this distribution. Number of distribution, and there is only one way of doing this distribution, that Ram is getting 1 book, Sham is getting 2 books and Gopal is getting 3 books. So specific. That much will be your answer. Suppose one gets 3 books, one gets 2 books, last one gets 1 book. This is also the same, 3, 2 and 1. In this case, what you are doing? In this case, you will have 6 factorial upon 3 factorial into 2 factorial into 1 factorial. Now, do we need to arrange? No, we don't need to arrange. Correct? Do we need to arrange? We don't need to arrange, or do we need to arrange? What do you think? Do we need to arrange or not? First tell me that. We need to arrange. It's not mentioned who gets which book. One gets 3 books, one gets 2 books and one gets 1 book. Right? So, which one? Internal arrangement is also there when it is not specified. So, internal arrangement 3 people. So, 3 factorial. 3 packets. 3 packets. So, 3 factorial. It's not mentioned, right? Ram is getting. Last question it was mentioned. Ram is getting. There was only one way, that Ram only will get 1 book. Sham only will get 2 books and Gopal only will get 3 books. It was specified. But now it's not specified. Now it is not specified. One gets 3 books, one gets 2 books and last one get 1 book. So these 3 people can be different. So internally we have to arrange. 3 factorial will be the number of ways in which we can internally arrange. Ram gets 4 books while Sham and Gopal gets 1 book each. Internal arrangement will be there. Ram gets 4 books while Sham and Gopal get 1 book each. So 6, 4, 1, 1. Here total distributions will be 6 factorial upon 4 factorial into 1 factorial into 1 factorial. Although we don't need to write 1 factorial, but still just for the practice now write it. Multiplied with these two are same. So into 2 factorial. Correct? And this thing will be multiplied with 3 factorial or 2 factorial. 4 books are going to Ram, that is fixed. But Sham and Gopal, which one is getting which book? Internal arrangement will also happen. So multiply with 2 factorial. Ram and Sham, while Sham and Gopal gets 1 book each. Which book? Books are different, right? 6 distinct books we have. Books are different. Which book? So internal arrangement between Gopal and Sham will happen. So 2 factorial. For Ram it is fixed. So not 3 factorial, only 2 factorial. Pay attention at these small things. Okay. Okay, let's solve a PYQ. Direct question, this is, you can take it as direct question. In a hotel, 4 rooms are available. 6 persons are to be accommodated in these 4 rooms. There are 4 rooms available in hotel and there are 6 persons to be accommodated in these rooms, in such a way that each of the room contains at least 1 person and at most 2 persons. Very good. This actually solves most of our problems. Do you think the same which I am thinking? This is actually resolving most of our problem. This part is actually resolving most of our problem. How? 4 rooms are available. 6 persons are to be 1, 2, 3, 4. Distribution. Distribution only we are doing. Right? First of all, we have to understand this is a problem of distribution and also understand that what can we apply. Just a minute. The mic is a big trouble for me. Yeah. Okay. 4, we have to divide in 4 rooms. 6 people in 4 rooms. Minimum 1 and maximum 2. At least 1 and at most 2. What can be the distribution? If I take 1 here, 1 here, then what can be option for these 2? Total 6 rooms are there. So 2, 2, right? Any other case you can form. At most 2. Suppose if I do 2 here, 2 here, then 1, 1 here. If I do 2 here, 3 I cannot use because at most 2. 3 I cannot use because at most 2 rooms, at most 2 persons can go in a room. Correct? At least 1, at most 2. So I cannot use 3. If I cannot use 3, I cannot have any other case. Do you believe the same? 1, 1, 2, 2 is only possible. correct or not? So just that's it, number of distributions. This is 6 factorial upon 1 factorial into 1 factorial. So I'm not writing 1 factorial now. Okay, I'll write 1 factorial, 1 factorial, 2 factorial, 2 factorial. These two are same, so 2 factorial for these. These two are same, so 2 factorial for these. So basically 1 factorial will go to 2 factorial to the power 4 will come. Okay, 2 factorial to the power 4 will come, and this will become, I'll write 6 factorial upon 2 factorial to the power of 4 will come, but internal arrangement, because it's not specified that which one is getting which room. So internal arrangement also you'll have to do 4 things. So 4 factorial, 4 different rooms, right? So 4 different rooms are going to 4 different people. 4 factorial will be the number of ways to arrange. You can calculate the answer. 32 90, no, 4 factorial, 6 factorial it is, 2 factorial to the power 4, and then here it was 4 factorial. So remaining we have 3 into 2 into 1, 93, 270 into 2, 10, what are we getting? Can you calculate? 1080 should be the answer. Very good, Vijay, amazing. 1080 should be the answer. Same type of question. In how many ways 9 students can be divided in 3 study groups? Each one contains at least 2 students and no group is left empty. So first one I think easily we can do. 9 in 3 different groups, right? 9 in 3 different groups. Each group contains at least 2 students. What can be the possible scenarios? Let's make at least 2. So this can be 2. If this is 2, if I make this as 5, this can be 2. Okay, 9. At least 2 it is saying, right? So we can use 3 also. At least 2, that means we can use 3 also. Suppose if I take this one 2, this one 3, 3, 4, 5, this one will get 4. Okay, correct? And remaining 3, 3, 3, obviously I can use 3, 3, 3 also. 3, then 3, then 3. Anything else? 2, 5, 2. At least 2 we have to create. So 2, 3, 4 also we have used. 3, 3, 3 also we have used. I don't think any more cases will be there. Only 9 are left. Where only 9 are left? This one you are talking about? Okay, this one. Okay, this case. 4, 4, 1. 4, 4, 1 we cannot take, no. At least 2 is mentioned. 4, 4, 1 we cannot take. At least 2 should be there, right? At least 2 should be there in a group. So 4, 4, 1 won't come. Get my point? Now that's it. So this one will become 9 factorial upon 2 factorial, 2 factorial, 5 factorial, right? Into 2 factorial, into one more 2 factorial. This will become 9 factorial divided by 2 factorial, 2 factorial, 5 factorial into 2 factorial. Why? Because these two are same. Plus 9 factorial upon 2 factorial, 3 factorial, 4 factorial. This will be like this. Plus 9 factorial upon 3 factorial into 3 factorial into 3 factorial into 3 are same. So one more 3 factorial. That will be the case, right? This sum will also be multiplied with 3 because it's not mentioned which group, which student in which group. So these 3 distributions, these 3 groups can also be internally arranged. So we'll multiply with 3 factorial more. That will be the case. Okay. Try doing this on your own. No group is empty. No group is empty. I'll give you an idea. So no group is empty means total groups you make. Subtract the groups when only one group is empty. Ways when only one group is empty. Then also subtract the ways when only 2 groups are empty. Okay. Try this on your own. Total ways of distribution. Total ways of distribution you can find very easily. You know how to do that, right? Now subtract the ways when only one group is empty. Only one, exactly one, not only one, exactly one. Exactly one is empty. Also subtract the ways exactly 2 are empty. This question also you can do with 2 ways. Think about it. 2 ways you can do. So total number of ways in which we can distribute 9 things in 3 study groups will be actually 3 to the power 9. Will be actually 3 to the power 9. Right? Alike objects. This is a very important case. Also, we also call it as Beggar's method. I'll tell you what. Number of ways of distributing n identical objects among r persons. Suppose I have all dairy milks, all same dairy milk chocolates. All dairy milk chocolates. And I have 3 children or 2 children, children 1 and children 2. How many ways can I give them? In how many ways can I give them? Either I'll give this chocolate to this one or won't give this chocolate to this one, right? If I have to distribute n identical objects among r different people, simply you have to follow this formula. Remember this. Its derivation or its explanation, don't get into that. Instead, just remember, when you have to distribute n identical objects in r people, the number of distributions, the number of ways in which you can distribute or number of ways in which they can receive this gift of yours will be equal to n plus r minus 1 upon r minus 1. For example, over here we are distributing 4 identical things among 2 people. So 4 plus 2 minus 1 c 2 minus 1. So 5c1. There will be 5 methods. Okay. 10 identical 1 rupee coins can be distributed in 3 beggars. Why we call it beggar's approach? It's not a standard name, but in many coachings or many books also they'll use this name. So I'm just making you familiar with this name. Don't think that what was beggar's approach, is this something else which is taught in PNC? It is actually the method of distributing n alike objects in n alike items in r people, in r different people. Okay. 10 identical 1 rupee coins can be distributed among 3 beggars. 10 plus 3 minus 1, that means 12. C 3 minus 1, that means 2. So 12C2 ways will be there. Now how? This is not, the question is not just going to come like this. It might come directly also, that you are distributing some n like objects among r different people. Direct question can also come, but generally what has been observed in JEE, this type of question will come. It will be for non-negative integral solution of equations. X plus y plus z is equal to something, x y z is equal to something. Those type of questions we will have. So we are going to see one set we are going to see on our own, one you can solve, you will be able to solve on your own, don't worry about it. Find the number of integral solutions of x plus y plus z is equal to 12 such that x, y, z both are greater than equal to 0. Right, all 3 are greater than equal to 0. So what are you doing actually? You are distributing 12 things among x, y and z. Correct? You are distributing 12 things among x, y and z. That's it. X plus y plus z is equal to 12. 12 things among x, y and z. Number of ways of distributing 12 identical things among x, y and z. How can you do that? Simple approach, simple formula you can use. 12 plus 3 minus 1 c 3 minus 1. Directly you will get 14C2. You will get 14C2. There are 14C2 integral solutions of doing this. Okay, 14C2 integral solutions of doing this. Here x, y and z all are greater than equal to 0. Either I'll not get anything or I'll get something. Either I'll not get anything or get something. Either this z will not get something, not get anything, or it will get 1, 2 or 3, anything. Right? So these 3 are beggars. Just think of it as beggars and you are distributing 12 identical coins among these. Okay. Next thing, number of non-negative integral solution. Achha, same thing only. If x is greater than 2, y is greater than equal to 0 and z is also greater than equal to 0. Now x is basically saying that I want at least 2. X is saying that I want at least 2. So how many integral solutions can I have? Now if x is already getting 2, so what am I actually doing? I am distributing x, y and z. I am solving this where x already has gotten 2. More than that he can get. More than that he can get. So basically what will I have? 12. Now I have 10. Now I am solving this where x, y, z all three are greater than equal to 0. So what will I do? 10 plus 3 minus 1 c 3 minus 1. So it will be 12 c2. 12 c2 integral solutions will be there. Try doing this one. I'll just be back. (66) 12 c2. Yeah. Aditya, basic, which this one? If you're talking about, I'll explain the starting so that you can understand. Here what we are doing is we are distributing n things, n identical objects among r persons. Suppose we have 1 rupee coin and I have to distribute it among 2 people, person 1 and person 2, right? So now it's about just how many coins. Now it's just about how many coins person 1 or how many coins person 2 can get. Either 1 coin, either no coin, 1 coin, 2 coin, 3 coin, 4 coin, 5 coin, person 2 also 0, 1, 2, 3, 4 or 5, right? So we have to distribute it like this. It's upon me. Now I am the distributor. I am the very holy person and I am distributing this. Think of it like this. And the method is n identical objects distributed among r different people. So formula is n plus r minus 1 c r minus 1. Total number of distributions will be n plus r minus 1 c r minus 1. Hope you'll get this. Okay, next one, yeah, solved. Vijay, 11c2 c50, 11c55. X is greater than 1. Yeah, okay, x is greater than 1, y is greater than 2. So x will at least get 1, y will at least get 2. So there will be 9 left. X will at least get 1. I want 1 at least, right? Y will say I want 2 at least. So now 9 will be left. X plus y plus z is equal to 9, where x greater than equal to 0, y greater than equal to 0, z greater than equal to 0. It can be anything. It can take any number of values. X greater than equal to 0, y greater than equal to 0 and z greater than equal to 0 means that now they can take any number of values. Any number of values. Okay. So now basically 1, 1, 1 we are distributing. Why am I continuously saying identical objects? Because we are actually distributing 1, 1, 1, 1, right? Same things. No 1, 3 ones, 2 ones, 4 ones, 5 ones. Getting my point? Nobody asked that why are you saying identical objects? Identical objects because we are actually distributing 1, 1, 1, 1 and that will make 3, 4, 5. For 9 it can be 5, 4, 0, right? 1, 3 or 5, right? These kind of things. Okay, so this one will become 9 plus 3 minus 1 c 3 minus 1, 11 c2. Very good. Now you know what to do. Great. This also minus 2. Here there is a different thing. Minus 2. Minus 2 means your 2 is ready to give. That means x is ready to give 2 of its chocolates or 2 of its gifts, whatever. You take 2 from me. So basically it will become 14 and 1 is taken by y, so it will again become 13. Correct? Getting my point? So it will be 13 now. X plus y plus z will become equal to 13 now. Okay. You can solve this one again. Here if this case comes, what you have to do, x can be minimum, it can be 1, or maximum it can be 4. So x is equal to 2, x is equal to 3 and x is equal to 4. 4 different cases you will have to make. When x is 1, y plus z will be equal to 11. When I'll write the cases. When x is 1, y plus z will become 11. So your cases will be 11 plus 2 minus 1, c 2 minus 1. Right? If x is 2, y plus z will become equal to 10. Your cases will be 10 plus 2 minus. Now you are distributing among 2 people only. You know how to do this. Right? You know how to do this. 10 plus 2 minus 1, c 2 minus 1. This will give you y plus z equal to 9. So in this case 9 plus 2 minus 1, c 2 minus 1. This also you can find. This will give you y plus z equal to 8. So 12, right? Yeah. So it will become 8 plus 2 minus 1, c 2 minus 1. Add all of them. All are your possible favorable scenarios. So you will have to add all of these up. Correct? All 4 cases you will have to add and you will get your answer. So now let's solve one of the question. Yeah, number of ways in which 21 identical apples can be distributed among 3 children in such that each child gets at least 2 apples. Try this once. Try this once. Among 3 children, you are distributing x plus y plus z. Same thing only, no? Kind of a same problem. X plus y plus z is equal to 21. But here each child gets at least 2 apples. So x greater than equal to 2, y greater than equal to 2, z greater than equal to 2. Same type of problem it has become. Direct approach you can use, not a problem at all. So they'll hold 2 at least, 6 will be reduced from 21. So you'll have 15. So basically your x plus y plus z will become equal to 15. And to do this, and here x, y and z are greater than equal to 0. Getting my point? Can you tell the answer? 15 plus 3 minus 1. That means 17, c 3 minus 1. So 17 c 2 will be your answer. Calculate this match. Are we getting or not? 17 c 2. 17 into 16 divided by 2 factorial. 17 into 8. 136. We are getting the answer. Direct approach based questions can also come in your mains and advanced. So remember this as it is, and very simple. Beggar's approach is actually very simple to understand, right? Because when we are distributing identical objects, it's only about who is getting how much. It's not about ways of distribution, right? Because we are just distributing same things. So now it's not about who is getting how much or who is getting which thing. We are not distributing different things. Otherwise it would have been about which person is getting which of the things and in what quantity. But here we are distributing identical things among the people. So it's about who is getting how much. It's about the number now. It's about numbers. Are you getting first person is getting 0, 1, 2, 3, 4 like that. So okay, same, and this integral type of questions either can be asked or these type of questions can be asked. Okay. One more problem we can see. Yes, this is also a direct approach based. Total number of 3-digit numbers whose sum of digits is 3. Whose sum of digits is 3. That means your x plus y plus z, these are the digits, should be equal to 10. But here there is a condition. X, the first digit, cannot be 0. Remaining digits can be 0. So you will put the condition x greater than equal to 1. Y greater than equal to 0, no problem. Z greater than equal to 0, no problem. Directly you will get the solution. How we write 17C2? Aditya, you will have to start from a bit earlier. Please beta, try to watch it from arrangements. Then you will be getting this. Or try to watch it from identical distributions. There you will get all this thing. Maybe you have joined a bit later. That's why this is happening. Don't worry. You will understand. And if you are in 10th, no, try to understand till selections. Don't get into this right now. You'll get this when you approach 11th and 12th. Right now, learn till selections. That much will be enough. Even if you are aiming for PRMO, IOQM or anything, that much will be enough. Okay. Otherwise also, if you watch the lecture once again, you will understand all these things. Don't worry about it. Okay, this we can do. Vijay says 11C2. Correct. 11C2, that means 11C2 will be your answer, that is 55. 11C2, 10 plus 3 minus 1. Sorry, not 10, 9. X is always greater than 1. It is holding 1. Right? It is holding 1. So you have to do for x plus y plus z equal to 9. That will be 9 plus 3 minus 1. So 11 C 3 minus 1, 11C2. 11C2 is 55, right? 55. Not 55, 54. Okay, maybe. Okay, wait. X is equal to 10 is not possible, right? That is why we have to reduce that one case. First number cannot be 10 also, right? First number cannot be 10, right? That is why we have to reduce that one case, right? First number cannot be 10. Otherwise, it will become 2 digit. That is why we are removing that case. The total number of possible integral solutions x, y, z such that x into y into z is equal to 24. I hope you got the last one, right? Why did we decrease 1? Because x cannot be 10, right? We also considered the case where x could be equal to 10. So we are removing that case when x is equal to 10, right? We thought greater than equal to 1 and the sum was 10. So x could be 10. We are removing that particular case. We could take x also as 10. All ones we have distributed to 10, then x will become 10. But first digit cannot be 10 or 0. So that is why. Okay. The total number of possible integral solutions x, y, z such that x into y into z is equal to 24. Very simple question it is. 2021 it was asked. I'll give you a hint. Try to solve it on your own and I'm sure that you'll be able to solve it on your own. 24, how can you make 24? 8 into 3. That means 2 into 2 into 2 into 3. Correct? That's what? Possible integral solutions for x, y, z. So basically your x into y into z can be equal to 2 into 2 into 2 into 3. Now you have to distribute these 3 2's among these 3 people. Correct? Got your answer? Try solving it now. I'm waiting. 2 into 3, 2 to the power 3 into 3. Yes. So basically you are going to distribute these 2's first. You are going to distribute these 2's first. Okay. Try doing this once. Here you will have to use the Beggar's approach. And this 3 you know what to do about. Try it. 3 2's have to be distributed among x, y and z. Three objects are to be distributed among 3 people. So 3 plus 3 minus 1 upon 3 plus 3 minus 1 C3 minus 1 10C2 5C2, right? These 3 identical. These 3 are identical. These 2 are to be distributed among 3 people. So 3 plus 3 minus 1 C3 minus 1. This will be for distributing your 3's. And now you have to allocate this 3 also. So in how many ways can you allocate that? Multiplied with 3C2. From any 3 you have to choose any 2. Or 3C1 also. 3C1 also will be fine. You can give this 3 to anyone. 3C1 will also be fine. Alright, how much are we getting? 30. Very good, Vijay. Very good. Okay, so for today's lecture, the thing is we have solved a lot of variety. It's not about specific, some specific methods, specific approaches are there for some particular specific type of questions. So those are fixed, those you can directly use, and you must have observed that JEE also is asking type based approach or type based question. So go through this lecture, I'll upload the PDF definitely, go through this lecture once again entirely throughout, try to solve the problems on your own. Once you can look and next you can solve on your own. Vijay has performed very well. If you go through this entire thing once again, no Vijay, this chapter will be done. Almost 99% of the types and approaches have been covered. But yeah, these approaches are going to be applied in multiple scenarios. So definitely solve some more questions from more books. You have books, you have modules, you have coaching material, or internet is full of questions. So there also you can find PYQs, solve more PYQs. That will also be a good practice. Board mein date wrong hai. Which date? JEE Main 25th Feb 2021. This one or 2153? Anyway, okay. So yeah, then I think this was last, right? Yeah, this was last. Okay. If you have not subscribed, I'll ask you to subscribe and also ask your friends to subscribe. Otherwise, send this video, take help from this video, keep learning, keep watching, keep solving, right? Math is a subject which you'll be interested in and which you'll be more comfortable with if you are not afraid of solving. So never be afraid of solving, right? If you are giving up on solving and seeking more of solutions, that means you are losing maths. And trust me, math can change your JEE score. Whichever class you are into, 11th or 12th, 10th, 9th, any class, if you are aiming for JEE, then math can change your ranks, definitely, trust me. Nowadays, people have started getting 40, 50 or 60%. Earlier, it was hardly 15, 20%. But still now, also math is capable of changing your entire score. So, good night, take care, thank you, sayonara, bye-bye, vadakkam, thank you, good night.